Welcome back to our lecture. In today's lecture, we are diving into the fascinating world of ethical hacking and exploring why Python stands out as the ultimate programming language for this field. So, if you are interested in cybersecurity and curious about the tools that power ethical hacking, you have come to the right place. Let's get started. Before we dive into the Python's role, let's briefly understand what ethical hacking is all about. Ethical hacking refers to the practice of testing and securing computer systems, networks, and applications with the permission of the system owners. It helps identify vulnerabilities and weaknesses, ultimately strengthening the overall security posture. One of the primary reasons Python is favored by ethical hackers is its versatility and ease of use. Python is a high-level programming language known for its simplicity and readability. Its clear and easy-to-read syntax makes it beginner-friendly and allows hackers to quickly grasp its fundamentals. Python has a vast collection of libraries and frameworks that provide ready-made tools for ethical hacking. For instance, libraries like Scapy, Request, and Beautiful Soup enable network scanning, HTTP communication, and web scraping respectively. These resources significantly accelerate the development process and enhance productivity. Python's fast prototyping and scripting capabilities makes it ideal for ethical hacking. Its interpreted nature allows for quick development and testing of hacking tools, making the process more efficient. With Python, hackers can rapidly iterate and adapt their code to changing circumstances. Another significant advantage of Python is its cross-platform compatibility. Whether you are targeting Windows, Linux, or Mac OS, Python can run seamlessly on different operating systems without requiring extensive modifications. This flexibility is crucial for ethical hackers who often need to work with diverse environments. Also, when it comes to exploit development and reverse engineering, Python shines yet again. Python allows hackers to build custom exploits and analyze target systems efficiently. Its capabilities, combined with libraries like PinTools and PyCrypto, enable professionals to dig deeper into vulnerabilities and devise effective countermeasures. Python's versatility extends beyond its own libraries and frameworks. It seamlessly integrates with existing security tools and frameworks, such as Metasploit, Nmap, and Wireshark, making it an indispensable language for ethical hackers. Python acts as a glue that connects different tools and enables hackers to orchestrate powerful and complex attacks. In this section, you will learn about the different kinds of data you can work with in your Python programs. You will also learn how to use variables to represent data in your programs. So what really happens when you run main.py program? So let's take a closer look at what Python does when you run this program. And as you can see here, Python does a fair amount of work even when it runs a simple program, right? So when you run this code, you should see this following output here. So when you run this program, the ending PE here indicates that the file is a Python program. So your editor then runs the file through the Python interpreter, which reads through the program and determines what each word in the program means. For example, when the interpreter says the word print here, followed by the parentheses like this, it prints the screen whatever is inside in the parentheses. So as you write your programs, your editor highlights different parts of your program in different ways. For example, it recognizes the print is the name of a function and displays that word in one color. It recognizes that hello world Python or hello typhoon is not a Python code, and it displays that phrase in a different color. As you can see in this case, it's green, and this is called the syntax highlighting. So here, for example, this is a green, right? So this is syntax highlighting. The Python tells us this is a string that's going to be printed on the screen, and this is a function, built-in function that Python has, and these are the parentheses here. Let's see here. So whatever we write inside this parenthesis will be printing here. And let's try using a variable with this print here. So now we will add a new line at the beginning of the file and modify the second line. So we will create a message, or my super message here. And now we will, let's make it this message, hello Typhoon, welcome to this Python course. And here after that we will print this message. Oh, like this, print, and inside this we will enter our message, print my super message. And now let's run this program and let's see what happens. By the way, you can run this program with Shift and F10, this combination of shortcut, and you can also run this by pressing this run main button here. And so we added variable named message here, this message here. Every variable is connected to a value, right, which is the information associated with that variable. In this case, this variable here, let me actually get my pen. Yes, so this variable here is connected. So this is the value. So this value here is connected to my super message named variable. So adding a variable makes a little more work for Python interpreter when it processes the first line. So this is the first line. Firstly, it associates this variable my super message with the hello Typhoon, welcome to the Python course value. So when it reaches the second line, it prints the value associated with my super message, in this case it's welcome, hello Typhoon, welcome to this Python course here, right? And let's expand on this program by modifying this main PE to print a second message. Now let's add a blank line here and then add 2 new lines of code. So here we will again write my super message, and this is the best and fastest Python course in the world. And that's it. Now we will again print the message, which is my super message. Now here, let's run this and you will see what happens now. So you can change the value of variable in your program at any time, and Python will always keep track of its current value. So for example, when we first defined my super message, its value was this. Hello Typhoon, welcome to this Python course, and this is the print that we printed here. And the second variable, this is the same variable, right? These are the same. These are the same for now. These are the same variables, but they after line 4, they do not contain the same values. That's it. You can change variables whenever you want in Python. And here, now let's learn about the naming and using our variables, which is you will need in Python a lot of times. So I'm waiting you in the next lecture. When you're using variables in Python, you need to adhere to a few rules and guidelines. Breaking some of these rules will cause errors. Other guidelines just help you write code that's easier to read and understand. And be sure to keep the rules in mind when working with variables. So first, let's start with variable names. So variable names can contain only letters, numbers, and underscores. They can start with a letter or an underscore, but not with a number here. For instance, you can call variable message underscore 1. So you can define variables like this, but you cannot define 1 underscore message, but not like this. And this is a mistake because you cannot define a variable that starts with a number, right? So this is a mistake. And you cannot define variable with spaces here. So avoid, and also avoid using Python keywords and function names as variable names. For example, do not use word as print as a variable name. So Python has reserved it for a particular programmatic purpose. And variable names should be short but descriptive. For example, name is better than n, or student name is better than sn, right? So, and so the name length here is better than length of person's name, right? So be careful when using the lowercase letters and uppercase letter, the lowercase letter L and uppercase letter O here, because they could be confused with the numbers 1 and 0. And it can take some practice to learn how to create a good variable names, especially as your programs become more interesting and complicated. As you write more programs and start to read through the other people's code, you will get better at coming up with meaningful names. So, and avoid name errors when using variables as well. So every programmer makes some mistakes, and most make mistakes every day. Although good programmers might create errors, and they also know how to respond to those errors efficiently. So let's look at an error you are likely to make early on and learn how to fix it. So here we will write some code that generates an error on purpose. So now we'll write this following message. So message, my super mega message, and message here, and we will make this message, for example, hello every student from your instructor Typhoon here. And here we will print this message, print my super mega message. So when, let's run this here. This is, so when an error occurs in your program, the Python interpreter does its best to help you figure out where the problem is. The interpreter provides a traceback when a program cannot run successfully. So a traceback is a record of where the interpreter ran into trouble when trying to execute your code. Now we will write this. For example, this code is successfully interpreted here and run. And let's delete this S from the message, and let's run it. And as you can see here, this is our traceback. This is an example of traceback that Python provides after you accidentally misspelled a variable's name. So here we will need an S here, right? So and as you can see here, the name my super mega message is not defined here, and we have an error in line 2. And the output reports that an error occurs in line 2 of the file of main.py. So the interpreter shows this line to help us spot the error quickly and tells us what kind of error it found. And in this case, it found a name error, and here name error, and reports that the variable being printed message has not been defined. That's because we entered the wrong value in it. And in a name error usually means we either forgot to set a variable's value before using it, or we made the spelling mistake when entering the variable's name, as we did here. And if the Python finds a variable name that's similar to that one, it doesn't recognize, it will ask if that's the name you meant to use. So in this example, we omitted the letter S in the variable name my super mega message in the second line. So the Python interpreter doesn't spell check your code, but it does ensure that the variable names are spelled consistently. For example, watch what happens when we spell message incorrectly in the line that defines the message here. So let's make it again, and as you can see here, our code is run successfully. So in this case, the program runs successfully, right? So the variable names match. So Python sees no issue. So as a result, and programming languages are strict, but they disregard good and bad spelling. So as a result, you don't need to consider English spelling and grammar rules when you're trying to create variable names and writing code. So many programming errors are simple, single character typos in one line of program. If you find yourself spending a long time searching for one of these errors, know that you are in a good company. And many experienced and talented programmers spend hours hunting down these kinds of tiny errors and try to laugh about it and move on. So knowing it will happen frequently throughout your programming life. And we also need to know about variables. So variables are labels. So variables are often described as boxes like this that you can store values in it. So for example, let's name it the variable. Oh, sorry, let's actually get the pen. So let's make it variable, and we have the value. So the idea can be helpful. This idea can be helpful the first few times you use a variable, but it isn't an accurate way to describe how variables are represented internally in Python. So it's much better to think of variables as labels that you can assign to values. You can also say that a variable references a certain value. So this distinction probably won't matter much in your initial programs, but it's worth learning earlier rather than later. At some point, you will see unexpected behavior from a variable, and an accurate understanding of how variables work will help you identify what's happening in your code. And the best way to understand new programming concepts is to try using them in your program. So if you get stuck while working on exercise in this course, try doing something else for a while. So if you are still stuck, review the relevant part of that section and watch this lecture again. If you still need help, you can ask me anytime and I will answer you immediately. Note that this assignment sign in the statement, for example, user age equals 19, has a different meaning from the sign we learned in math. So in programming, this assignment sign is known as an assignment sign. Actually, in the program is equal sign. So it means we are assigning the value on the right side of the sign. This is the value that we are assigning to this variable in the left side. A good way to understand the statement user age equals 19 is to think of the user age this, right? So this statement A equals B and B equals A has a very different meanings in programming. Confused? An example will clear this up. So let's type this following here. X equals, or A equals 5, B equals 10, and A equals B here, right? So now we will print this here, print our A equals to A, and print again our B equals to B, right? And now let's run the program. And as you can see here, A equals to 10, B equals to 10. So now, although A has an initial value of 5, you can see here, declared on the first line, and the third line, A equals B, assigns the value of the B to A here. So we are assigning, with this code, we are assigning a value of B to A, and now we are assigning, in the first line we are assigning 5 to A, and after that we are assigning 10 to B. So here are A equals to 5, and now B, we don't have B here, so we don't have B here, and here A equals to 5, B equals to 10, and here our A equals to 10 and b equals to 10 here. And next we can modify this by changing only one statement. So let's change the third line from a equals b to b equals a. Now let's run this program again, and as you can see, we have a equals 5 and b equals 5. And here mathematically, the a equals b and b equals a mean the same thing. However, this is not so in programming. And now let's run this program again, and as you can see, we got this a equals 5, b equals 5. So you can see that in this example, the a value remains as 5, but the value of b is changed to 5 from 10. So this is because the statement is in the third line, b equals a, assigns the value of a to b, and b becomes 5 while a remains unchanged as 5. Because most programs define and gather some sort of data and then do something useful with it, it helps to classify different types of data. The first data type we'll look at is strings. Strings are quite simple at first glance, but you can use them in many different ways. The string is a series of characters. Anything inside quotes here is considered a string in Python. You can use a single or double quotes around your strings like this. So this is the flexibility allows you to quotes and apostrophes within your strings. So let's explore some of the ways you can use with strings. We can also change the case in a string with methods. So one of the simplest tasks you can do with a string is change the case of the word in a string. Let's look at this following code. Let's here name this is the world's best Python course here, and here we will print is our name, right? Name dot title, and let's make it this here. That's it. Now let's run this here with Shift and F10 shortcut, or you can press on this button as well. And as you can see here, this is the world's best Python course, right? In this example, the variable name refers to the lowercase string. This is the world's best Python course, and the method title here appears after the variable in the print call. A method is an action that Python can perform on a piece of data. The dot here, this dot here, so you can, oh sorry, that's actually, yes, this dot here, after name in the name.title tells Python to make the title method act on a variable name. So we will act this title method on a variable name. So now every method is followed by a set of parentheses because methods often need additional information to do their work. This is the first parenthesis. For now it's empty, but the print method has something to show us, right? And that's why we have this parenthesis here. And here the title function for now doesn't need any additional information, so these parentheses are empty. And the title method changed each word to title case, where each word begins with the capital letter. In this case, the T here, and this is the world's best Python course. So it changed all the words that starts with a capital letter. And that's what title does here. So this is useful because you will often want to think of a name as a piece of information. For example, you might want to program that recognize the input values of this here. For example, this or this or this and or this, right? So you might want to program the recognize these outputs as the same name and display all of them as this, right? So several other useful methods are available for dealing with case as well. For example, you can change a string to all uppercase or all lowercase letters like this here. Let's change this. Oops, actually let's delete this useless information here. And now we will use the name.upper, which is gonna, as you can see here, this give us output with all uppercase characters. And we can also use the lower big, and as you can see here, this is the all lowercase, and our actually it didn't do anything in particularly, but because our name variable, our name value was the all lowercase. So if you do like this, oh sorry, let's make it the uppercase as uppercase here, and as you can see here, now we are seeing something that has changed. And the lower method is particularly useful for storing data. So you typically don't want to trust the capitalization that your users provide, so you will convert strings to lowercase before storing them. So then when you want to display the information, you will use the case that makes most sense for each string. You can also use variables in strings, which you will learn in next lecture. In some situations, you will want to use a variable's value inside a string. For example, you might want to use two variables to represent a car's model and make, and respectively, and then combine those values to display some car's full model, right? So now we will make this car here, car make, and in this case, let's actually make it BMW, and now car model, and here we will make it 500 series, 5R series, and let's actually make the year, right? 2014. And now we will make it car here. We will make it F. This is the format. And car make. Oops, sorry. First the car make. And after that, we will enter the car model. Car model, right? And as you can see, that's it. Now we will print this. Print car. Let's print this. And as you can see here, BMW 5R 2014. And to insert the variable's value into string, place a letter F. Place a letter F immediately before the opening quotation mark here. That's what we did here, right? We placed the letter F, and after that put the braces around the name or names of any variable you want to use inside a string, and Python will replace each variable within its value when its string is displayed. In this case, it's, as you can see, inside braces we have car model, we have space here, this is a space here, and that we also have space here. Oops, not here, here. And we also have car model, which is our car model was 5R 2014, and this is it, right? And these strings are called, so these are these strings here, these strings are called the F strings here. F strings. These strings are called F strings. So this F here means format. Format. Because Python formats the strings by replacing the name of any variable in braces with its value. So the output of this code will be this here. You can change these variables and values as well here. So you can do a lot with F strings. For example, you can use F strings to compose complete message using information associated with a variable, as like this. For example, we have a car, right? So we can also do this, right? So my message here, it's gonna be F Typhoon drives a car, and that's it. Now let's and actually let's use this uppercase, And as you can see here, oops, instead we have to change the car, so to my message. And here Typhoon drives a BMW 5R 2014. So that's a full name. This is the full message is used in a sentence that reads that sends the user that what Typhoon drives, and we have the variables that used with the f strings. You can also use f strings to compose a message and then assign the entire message to variable as we did here. And now we will here let's actually do another here, and here we have my message Typhoon, here my bigger message here, and we will do again. So f here my message, firstly my message, and he crashed it. And here we will do print again my bigger message here, and as you can see Typhoon drives a BMW 5R 2014 and he crashed it. In programming, a white space refers to any non-printing characters such as spaces, tabs, and end-of-line symbols. You can use white space to organize your output so it's easier for users to read. Now let's add a tab to your text. So you can use this character combination to add tab to your text. So now let's print here, print this here. This is a Python tab, and after that we will add this character combination, or actually let's add this between this is M and Python tab. T here. Now let's run it. And as you can see here, we have a tab here. This is a tab. So to add a new line in a string, you can use the character combination of N here. And as you can see here, this is a new line. This is a new line. And after that, we have another space character that we used here. So let's delete this and this. Here you are seeing the new line without any spaces here. So we can also do like this, for example, print programming languages and languages, and here we're gonna add the new line and Python, or we can also before programming languages, let's add character tab so it will look nice. So Python, C++, or yes, new line C++, new line Java, new line Swift. And here, as you can see here, we have a tab here, Python, C++, Java, and Swift with new lines here. So you can also combine the tabs and new lines in a single string, and the strings nt here, nt, tells Python to move to a new line and start the next line with tab. Now we will do that here. Let's actually add two tabs here. You can add here. And as you can see here, there are programming languages, Python and C++ with two tabs here. This is the first tab and second tab, first tab and second tab. And here we have Java with only one tab and Swift with only one tab here. And as you can see, it's here, new line tab, new line tab, and new line tab tab here, and new line tab tab. So new lines and tabs will be very useful in the next two sections when you start to produce many lines of output from just a few lines of code. Extra white space can be confusing in your programs. To programmers, Python here, Python, and this Python here looks pretty much the same when you print it, right? But to a program, they are two different things. Python detects the extra space in this second Python here and considers it significant unless you tell it otherwise. So it's important to think about white spaces because often you will want to compare two strings to determine whether they are the same or not. For example, one important instance might involve checking people's usernames when they log into a website. Extra white space can be confusing in much simpler situations as well. Fortunately, Python makes it easy to eliminate extra white space from the data that people enter. So Python can look for extra white space on the right and left side of a string. To ensure that no white space exists at the right side of a string, you can use the rstrip method. So here, let's actually my best language or my best coding language here. So here we will have the Python here. So Python, but with white space here, as you can see here. And secondly, we will use the my favorite, or let's actually print it firstly, my best coding language. And as you can see, it's Python here, and we have a one white space here, obviously. Now we will do my best coding language .rstrip. That's it. And here we will print this my best coding language again. And here you will see nothing. As you can see here, they are the same. So in order to do that, here we will use with here. So this is just a temporary. We will use the permanent method as well. But for now, we're gonna use temporary here, rstrip, and here we will do. That's it. And here, as you can see, we have no white spaces here. We have no white spaces here, but here we have one white space, right? This is the white space here. So with rstrip, we remove the extra white space on the right side of a string. The value associated with my best coding language contains extra white space at the end of the string, as you can see here. So when you ask Python for this value in terminal session, you can see the space at the end of the value. When the rstrip methods acts on the variable my best coding language, this extra space is removed. However, as I said, it is only removed temporarily. So after that, if we do like print the my best coding language again, it will still print us with the white space here. So this here, this is the third here, second here, oops, second here, and this is the first Python print here. So as I said, it's only removed temporarily here. This is with the white space again, as you can see here. So if you ask for the value of my best coding language again, the string looks the same as when it was entered, including the extra white space. To remove the white space from the string permanently, you have to associate the stripped value with the variable name. In order to do that, we're going to do my best coding language equals my best coding language dot rstrip. Now we will see this here. As you can, this is the with white space and without white space. Let's print this more than one time to see here. And as you can see here, we will get the same result, of course. So this is the without the white space, with the white space, and all of these are without the white space. So that's it. To remove the white space from the string, you strip the white space from the right side of the string, and then associate this new value here, this new value with this here, because rstrip here we have, and we are associating this my best coding language with stripped version to normal version here. So in this example, we start with the. So let's actually use this, add this here, and you will see this. And as you can see, we all have the here. Now we're gonna do another example. So firstly, we will define this my best coding language with the two white spaces on the both sides. And after that, we have my best coding language dot rstrip. And here we will print it, of course. Firstly, print my best coding language dot rstrip. And here, as you can see here, we printed with the right strip here. So now we're gonna do as well as left strip. else strip. And here, as you can see in the first example, we have no right white space, but we have a left white space. But here we have no left space, but we have in a right side we have a white space. So in order to do that, we will firstly associate my base coding language that equals the my base coding language dot L strip here, and after that we will my base coding language dot R strip, and after that we will print the value. So as you remember, this is a permanent solution here, and as you can see here, we have no right spaces or left spaces on the both sides. So when working with strings, another common task is to remove a prefix. Consider a URL with the common prefix of HTTPS. Here we want to remove this prefix so we can focus on just the part of the URL that the user needs to enter into an address bar. Here's how you do that. So Udemy URL here, Udemy URL, and here we will enter the Udemy URL here, HTTPS and udemy.com, and here they will use the Udemy URL dot remove prefix, and here we will enter HTTPS here. Now we will print the Udemy URL, or actually let's print this here, print here, and here let's see, as you can see here, we removed the HTTPS from the Udemy. So enter the name of the variable followed by a dot here, and then the method is remove prefix. Inside the parentheses, you enter the prefix you want to remove from the original string, like we did here. So like the methods from the removing white space, remove prefix leaves the original string unchanged. So if you want to keep the new value with the previous prefix removed, either assign it to the original variable or assign it to a new variable. So now we will use this. So Udemy URL without prefix, and here we will enter this Udemy URL dot remove prefix and HTTPS here, and here we will enter the print and Udemy URL without prefix here, and as you can see, we removed Udemy URL that had HTTPS prefix before it, and we printed it, so we have that variable permanently. But whenever we try to print this Udemy URL, it will show us the same because we didn't change this Udemy URL. We created new variable here. This is the new variable, and we took that. So we removed the prefix. So this has the udemy.com, but in the first variable we have the HTTPS udemy.com. So these are two separate variables. Don't confuse here. These are two separate variables. They don't have the associations. And only association this variable has is that it only took this from the variable. So, but they are separate variables and they are can be manipulated separately. One kind of error that you might see with some regularity is syntax error. A syntax error occurs when Python doesn't recognize a section of your program as a valid Python code. For example, if you use an apostrophe within a single quote, you'll produce an error. This happens because Python interprets everything between the first single quote as the apostrophe and the apostrophe as a string. It then tries to interpret the rest of the text as Python code, which causes error. So here's how a single use of double quotes correctly. Now we will use, for example, my special message, and here we will use this is the fastest and best Python course in the world. So this is the fastest in, or actually let's make the Pythons here. Yes, it might sound grammatically incorrect, but it is just a code and example. So Python's course. Now let's print this message. Print my special message, and as you can see here, we have no error even we have a single quotes here. So the apostrophe appears inside a set of double quotes, so that if let's actually make this like that. So here we are, we're gonna see this here, as you can see here. This is the fastest. This is the error, like this is the invalid syntax. In order to do that, here you have this backslash here, and it will fix the code. And if the same applies for the single quotes as well, let's actually add our single quotes. As you can see here, we have a code without a problem. And if we add this here, Pythons, and we are seeing error again. So in the output, you can see that error occurs right after the final single quote here. So this syntax error indicates that the interpreter doesn't recognize something in the code as a valid Python code, and it thinks the problem might be a string that's not quoted correctly. Error came from a variety of sources, and I will point out some common ones as they arise. So you might want to see syntax errors often as you learn to write proper Python code. So syntax errors are also the least specific kind of error, so they can be difficult and frustrating to identify and correct. So if you get stuck on a particular stubborn error, you can ask me and I will answer you immediately.
Numbers are used quite often in programming to keep scoring games, represent data in visualizations, store information in web applications, and so on. Python treats numbers in several different ways, depending on how they are being used. So let's first look at how Python manages integers, because they are simplest to work with. So you can add, subtract, multiply, and divide integers in Python. Let's do this following example. My value here, 2 plus 10 here, and let's print this value, my value. And here you can see here 2 plus 10 is equal to 12, or let's actually 9 subtract here 99 here, and as you can see here my negative 9 negative 90, and let's multiply it. For example, multiply 5 by 10. Oops. Multiply 5 by 10, and here we have 50. And let's actually divide 5 by 10 and 0.5. So in a terminal session, you can also Python simply returns the result of the operation. And here Python uses two multiplication symbols to represent exponents like this. For example, 5 exponent 10 is equals to this here. For example, 3 exponent 3 equals 27, and 10 exponent 6 equals 1 here, 1 2 3 1 million here. So Python supports the order of operations too, so you can use multiple operations in one expressions. You can also use parentheses to modify the order of operations, so Python can evaluate your expression in the order you specify. For example, this. So my value here, 2 plus 3 and multiply by 4 or 5. And here you can see we first 5 multiplied by 5 here. So the spacing in these examples has no effect how Python evaluates the expression. It simply helps you more quickly spot the operations that have priority when you are reading through the code. And we also have floats in Python. So Python calls any number with a decimal point. Python calls any number with a decimal point is a float. For example, this 1.478 is float. So this terminology is used in the. Let me actually firstly fix this here, because our marker menu should be here somewhere. Yes. So the term is used in most programming languages, and it refers to the fact that a decimal point can appear at any position in a number. So every programming language must be carefully designed to properly manage decimal point numbers, so numbers behave appropriately, no matter where the decimal point appears. For most part, you can use floats without worrying about how they behave. simply enter the numbers you want to use, and Python will most likely do what you expect. For example, 0.2 plus 0.9, and here 1.1, and here, for example, 2 multiplication 0.2, and here, oops, sorry, yes, 0.4, and here we have the, run it again, yes, 0.4, and here we have 2 multiplication by, for example, 99 here with some this, and here you can see we multiply this number with 2. So this happens in all languages, and let's actually, there's some bug here. Not bug, but you should see it. So here we have 3 multiplied by 0.1, and this here. So and this is a little concern, right? This happens in all languages here, in C++, in Java, and so on. So Python tries to find a way to represent the result as precisely as possible, which is sometimes difficult given how computers have to represent numbers internally. Just ignore the extra decimal places for now, and you will learn ways to deal with this extra spaces here. Just here, ignore this here for now. So when you divide any number, when you divide any two numbers, even if they are integers, that result in a whole number, and you will always get a float in mathematically, right? So let's do this. For example, 4 here, 2, and we got 2.0 here. So if you mix any integer and float in any other operations, you will get a float as well. Like, for example, 1 plus 2.0, and we got 3.0. Let's actually use 2 multiplied by 9.0. We got 18.0. And if we this same applies for the multiplication here, exponential exponents. So 3 exponent 2.0, we are seeing here 9.0. So Python defaults to a float in any operation that uses a float. So even if the output is a whole number. When you are writing long numbers, you can group digits using underscores to make large numbers more readable. For example, this. The students. And here we will use this students variable as a count of students. For example, let's make it for 15 million, right? So when you print a number, students, print students here. So when you print a number that was defined using underscores, Python only prints the digits. So Python ignores the underscores when storing these kinds of values, even if they don't group the digits in trees. And the value here, let's actually, the value here will be still affected. So for Python, the 1000 like underscore after 1 is the same as underscore after 10. So this feature works for both integer and floats. And we also have multiple assignment here feature in Python. So you can assign values to more than one variable using just a single line of code. So this helps you shorten your programs and make them easier to read. And you will use this technique most often when initializing a set of numbers. For example, here's how you can initialize the variables a, b, c to 0 here. A, b, c, and here 0, 0, 0. 0, 0, 0. So you need to separate the variable names with commas here and do the same with the values. So, and Python will assign each value to its respective variable. As long as the number of value matches the number of variables, Python will match them up correctly. So let's print this here. Print a here, a equals to a, and print b equals b. Let's print the B, print here, and C. Now we will here, and as you can see here, A equals to 0, B equals to 0, and C equals to 0. If we delete this, we will get an here error because non-iterable inc project. So if you do like this, for example, A equals to 0, B equals to 98, C equals to, for example, 55. And here, as you can see here, we assign them accordingly. And we also have constants in Python. So a constant is a variable whose value stays same through the life of a program. So Python doesn't have built-in constant types, but Python programmers use all capital letters to indicate a variable should be treated as a constant and never be changed. So for example, one of the constant might be, for example, maximum number of, for example, maximum value here, or maximum customers, for example, and in this case, let's make maximum customers 500. So when you want to treat a variable as a constant in your code, write the name of variable in all capital letters. And we also have comments in Python. So comments are extremely useful feature in most programming languages. Everything you have written in your programs so far in Python code. So as your programs become longer and more complicated, you should add notes with your programs that describe your overall approach to the problem when you're solving. So a comment allows you to write notes in your spoken language within your programs. So how do you write comments? In Python, the hash mark, this hash mark, oops, sorry, fix that. So in Python, this hash mark indicates a comment. Anything following this hash mark here in your code ignored by the Python interpreter here. So for example, let's say this, right? Oops, here. Hello everyone. This is a comment and I'm explaining something about my code. So here, after that, we will print, example, print hello my students here, students. Now we will print this, and as you can see here, Python ignores the 5th line here and executes the 2nd line. What kinds of comments you should write? So the main reason to write comments is to explain what your code is supposed to do and what you are making it work. So when you are in the middle of working on a project, you understand how all of the pieces fit together. But when you return to a project after some time away, you will likely have forgotten some of the details. So you can always study your code for a while and figure out how segments are supposed to work, but writing a good comments can save you time by summarizing your overall approach clearly. So if you want to become a professional programmer or collaborate with other programmers, you should write meaningful comments. Today, most software is written collaboratively, whether by a group of employees at one company or a group of people working together on an open source project. Skilled programmers expect to see comments in code, so it's best to start adding descriptive comments to your programs now. So writing clear, concise comments in your code is one of the most beneficial habits you can form as a new programmer. So when you're deciding whether to write a comment, ask yourself if you had to consider several approaches before coming up with a reasonable way to make something work. So if so, write comment about your solution. It's much easier to delete extra comments rather than go to back and write comments for sparsely commented program. For now, I will use comments in examples through this course to help explain sections and codes of this course here. In the section and next, you will learn what lists are and how to start working with the elements in a list. Lists allow you to store sets of information in one place, whether you have just a few items or millions of items. Lists are one of the Python's most powerful features, readily accessible to new programmers, and they tie together many important concepts in programming. What is a list? A list is a collection of items in particular order, and you can make a list that includes the letters of the alphabet, the digits from 0 to 9, the names of all the people in your family. You can put anything you want to into list. And the items in your list don't have to be related in any particular order or way. So because a list usually contains more than one element, it's a good idea to make the name of your list plural, such as instead of my special, you can write my special numbers like this, or letters, digits, or names. So in Python, these square braces indicate a list, and individual elements in the list are separated by commas here. And let's create a simple example of a list that contains a few kinds of car models or car makes. So car makes here, and here we will enter, for example, Mercedes. Mercedes here, as Benz here, and we will enter the BMW, and we will enter Volkswagen, Honda, Kia here, Hyundai here, and so on. So here we will print this car makes here. And as you can see here, we have Mercedes-Benz, BMW, Volkswagen, Honda, Kia, and Hyundai. So if you ask Python to print a list, Python returns this representation of the list, including the square braces here. So because this isn't the output you want your users to see, let's learn how to access the individual items in a list. Lists, and this is why we draw this drawing here, and we will explain on this list here. So we first created my special numbers here, as you can see here. So this associated with this here. Now let's get here. That's it. So lists are ordered collections, so you can access any elements in a list by telling the position or index of the item desired. So to access an element in a list, write the name of the list followed by the index of the item enclosed in square braces. So now let's try with my special numbers here. So if we want to write my special numbers here, we will delete this. Let's actually delete this, my car names, and now we will enter the print my special numbers. Let's print the number 65. In order to print the 65 here, we will enter the index of the 65, 3. So remember, index starts from 0 here. And here, as you can see here, we printed 65. So that's the answer you will get here. So this is the result you want your users to see. Clean, neatly formatted output. So you can also use the strings methods in this. Let's actually delete this here. And let's make the print car makes, the car makes dot. You can also use string method. For example, car makes dot. We will use the uppercase. Car makes dot. First we will enter the, for example, 1, index 1, and upper here. Now you will see this. As you can see, BMW started with uppercase, but BMW was uppercase actually. So instead of this, let's try with Hyundai here. So 0 here, let's count this. So this is 0, 0, BMW 1, index Volkswagen 2, index of Honda is 3, index of Kia is 4, and Hyundai is 5. That's it. So we will enter the 5 here inside the square braces, and now let's run it. And as you can see here, we've written it Hyundai in upper cases, and this example produces the this output here. So we can and keep in mind that index positions start at 0 and not 1. So I want to write this here because I want to the new programmers can sometimes be mistaken about the index position starting point here. So index, actually let's write with text here. So index positions start at 0 and not 1. That's it. Keep in mind this word here. Index positions start at 0 and not 1. That's it. Here. Now, a Python considers the first item in a list to be at a position of 0 and not position 1. So this is true for most programming languages, and the reason has to do with how the list operations are implemented at lower level. So if you are receiving unexpected results, ask yourself if you are making a simple but common off by 1 error. So the second item in the list has an index of 1, right? Index of 1. And using this counting system, you can get any element you want from a list by subtracting 1 from its position in the list. So for instance, to access the fourth item in the list, you request the item or index at 0, right? 1, 3. So if you are, so the Honda is actually the fourth item in this list, but in order to access them, we will use 3 here. So now we will, let's run this with again, and here, and as you can see, we got Honda here. So Python has a special syntax for accessing the last element in a list. If you ask for the item at index -1, Python always returns the last item in the list. So here, and as you can see here, Hyundai was the last item in our list. So here, let's actually do this. -1 returns -1 always returns the last item in the list here. Also keep in mind this. So that's it. Oops, sorry, not like this. -1 always returns the last item in the list. That's it. So this code here, as you can see, it returned Hyundai, and this syntax is quite useful because you will often want to access the last items in a list without knowing exactly how long the list is. So this convention extends to other negative index values as well. For example, -2 returns the second item from the end of the list, and -3 returns the third item in the end of the list, and so forth. So you can also use the individual values from a list. So you can use individual values from a list just as you would any other variable. For example, you can use f strings to create a message based on a value from a list. So let's try pulling the first our car model from the list and composing a message that uses that value. So now here we will do this. Print. Let's make the we will use the f here, and now my first car was let's say BMW here, and we will use this braces, but BMW, so car makes that 1 because the BMW index has 1, and we will use this, for example, title, right? And here my first car was a BMW. The syntax for modifying an element is similar to the syntax for accessing an element in a list. To change an element, you can use the name of the list followed by the index of the element you want to change, and then provide a new value you want that item to have. For example, let's say we have a list of car makers, and the first item in the list is BMW, right? So let's make the car makers here, and we will create the 5 or 3 items here, so it will easy to print on the screen. So Honda or BMW here firstly, and then Honda, and then for example like Kia, right? Or Ford. Yes, Ford. That's it. And here we will print the car makers. That's it. And as BMW, Honda, Ford. There is nothing weird in here, right? We didn't change anything or manipulate anything. Now we will write, for example, this car makers from index 0. We will change BMW to Jeep or Dodge here. And as you can see here, we will firstly write print this. And as you can see here, we changed BMW to Dodge, and our new list of car makers doesn't have the BMW inside it. So here we define the list of car makers with BMW as a first element, and then we change the value of the first item to Dodge. And the output shows that the first item has been changed while the rest of the list stays the same. You can change the value of any item in a list, not just the first item. Just remember here. So let's do the same to here. And as you can see here, we changed Ford here to Dodge. And you can also add an element to a list, and you might want to add a new element to a list for many reasons, right? For example, you might want to make a new car makers, add a new data to visualizations, or add a new registered users to a website you build. So Python provides several ways to add a new data to existing lists, and the simplest way to add a new element to a list is to append the item to the list. So when you append an item to a list, the new element is added at the end of the list, and using the same list we had in a previous example, we will add the new element. We will add a new element, for example, Jeep, to our end of the list. So car makers dot append Jeep here, and after that we will print the car makers, and that's it. And here, as you can see here, we added Jeep here. So here we append methods adds Jeep to the end of the list without affecting any other elements in the list. And the append method makes it easy to build the list dynamically. For example, you can start with an empty list and then add items to the list using a series of append calls. Let's do this here. For example, car makers, and here we will create the empty list here, and car makers that append BMW, car makers that append Honda here. Here let's append Jeep here. Append Jeep, and here we will also append the Ford. That's it. Also, of course, we need to print it to show you, and that's it. We created list from 0, and this resulting will look exactly the same as the list in the previous examples, but we changed a little bit here because as you remember, the Jeep was at the last and Ford was firstly here. That's okay. Here a building list this way is very common because you often won't know the data your users want to store in a program until after the program is running. So to put users in control, start defining an empty list that will hold the user's values, and then append each new value provided to the list we just created. Now you can also insert elements to list. So you can add a new element at any position in your list by using the insert method. So you can do this by specifying the index of the new element and the value of the new item. So we'll create a car makers to don't confuse you, and car makers, and we will make it the BMW, or let's start with Honda. It doesn't make any difference for now because it's variable. So BMW, Honda, and let's make it the Volkswagen, and Jeep here, let's fiat here, and Opel here, Sab. That's it. That's okay. That's enough here. So you can add a new element to any position in your list, as I said, by using the insert method. So you do this by specifying the index of the new element and the value of the new item. So for example, car makers here, car makers dot insert. So here we will insert 0. So let's find the new Mercedes here, right? Or let's use some Japanese cars, in this case Lexus. And here we will print the car makers now. And here, as you can see, we changed the Honda to Lexus. But instead, you remember, here we didn't change the Honda here. Honda is still appears here, but we added Lexus here. So instead of 1, 2, 3, 4, 5, 6, 7 items, here we have 1, 2, 3, 4, 5, 6, 7, 8 items. So we added Lexus at the start of the list. So in this example, we insert the Lexus at the beginning of the list, and the insert method opens a page at position 0 and stores the value the Lexus at that location. So this operation shifts every other value in the list by one position to the right. Here, sorry, let's get this pen. So here BMW was 3 here. Oops, let's actually get my pen here and make it proper color. Yes. So Honda was 0, BMW was 1, Volkswagen 2, Jeep 3, Fiat 4, Opel 5, and Saab was 6 item in that has 6 index of the list. And here since we added Lexus here, Lexus now is 0, Honda is 1, BMW is 2, Volkswagen is 3, Jeep is 4, Fiat is 5, and Opel is 6. Lastly, that's because we added one item at the start of the list here, and we have the 7 on the sub. So as I said, the this operation shifts every other value in the list one position to the right. We can also remove an element from a list. So often you will want to remove an item or set of items from a list. For example, when a player shoots down an alien from the sky, you will most likely want to remove it from the list of active aliens, or when a user decides to cancel their account on a web application you created, and you will want to remove that user from the list of active users. So you can remove an item according to its position in the list or according to its value. Now, if you know the position of the item you want to remove from a list, you can use del statement like this. So we will first print the car makers to make sure what we changed in this list, and we will del here car makers 0. That's it. And after that we will print our car makers. And as you can see here we use the del statement to remove the first item, which is BMW, from the list of car makers. So you can remove an item from any position in a list using the del statement if you know its index. For example, here's how to remove a second item BMW, or yes, here we remove the Honda here, but in this case we will remove the remove the third item. In this case we will enter the Q, and as you can see here we removed the Volkswagen. So now the third item is deleted from the list. In both examples you can no longer access the value that was removed from the list after the del statement is used. Sometimes you will want to use the value of an item after removing it from a list. For example, you might want to get the A and B position of an alien that was just shot down, so you can draw an explosion at that position and so on. So in a web application you might want to remove a user from a list of active members and then add that user to a list of inactive members. So the pop method removes the last item in a list, but it lets you work with the item after removing it. The term pop comes from the thinking of the list as a stack of items and popping one item off the top of the stack. So in this analogy, the top of stack corresponds to the end of the list. So let's pop sap and from the list of car makers. Now we will make this, for example, this, right? So popped car, and here we will enter the car makers dot pop here. That's it. And after that we will print the popped firstly car makers, and after that we will print the popped car. That's it. And here we start by defining and printing the our car makers, and then we pop a value from the list with this here, as you can see here. Absolutely. Let me actually adjust my mouse speed. Less. So now I will explain all of this now. So firstly, we define the list of the car models here, car makers. Oh, sorry, car makers, and then we print it. So after that, we pop a value from the list and assign that value to popped car. In this case, our popped car is equals to sap here because we popped sap here and nothing else. And after that, we are printing our car makers, which is here at the second here. And as you can see here, we don't have sap here. And after that, we are printing our popped car here, which is here. Sap. That's it. So then we print the popped value, and to prove that we still have access to that value that was removed. So the output shows that the value sap was removed from the end of the list and is now assigned to a variable named popped car. And remember, this is not a list, this is just a variable, this regular string variable. So how might this pop method be useful? So imagine that the car makers in the list are stored in chronological order according to when we own them, right? If this is the case, we can use the pop method to print a statement about the last car model we bought, car maker we bought, right? So we can also use this. Now we will, since we pop the car, now we will print the car maker. After that, we will print the popped car, and we will add another print, which we will use the format, right, as we used in previous year. The last car maker or car model that Typhoon owned is a and last, so here popped car, or actually let's change this here to last owned car here, and pop last owned car. That's it. The output is simple sentence about the recent and last owned car model we had here. In this case, it was sap. You can use pop to remove an item from any position in a list by including the index of the item you want to remove inside the parentheses. So for example, let's make this here. So this is the 0, and we will change it to first owned. So here first owned car, and here first owned car. And remember, the firstly here our first owned car variable was sap, right? It's because of this, when we use the pop method without any parameters inside this, we will get the last item. And here we will enter the 0 index here, and as you can see here, we got Honda here. So remember that each time you use pop, the item you work with is no longer stored in the list. So if you're unsure whether to use the del statement or pop method, here's a simple way to decide. So When you want to delete an item from a list and not use that item in any way, you can use the del statement. So, but if you want to use an item as you remove it, you can use the pop method. You can also remove an item by a value. So sometimes you want to know the position of the value you want to remove from a list. So if you only know the value of item you want to remove, you can use remove method like this. Remove. So here, for example, say we want to remove the BMW from the list of car makers. We will do this BMW here. That's it. And now we will enter here, and as you can see, none here, but here we removed BMW because we cannot save this. Watch here, we removed, and here let's actually we can delete this now, and as you can see here, we removed BMW. So you can also use the remove method to work with the value that's being removed from a list, but let's remove the value of the Jeep and print a reason for removing it from the list. So now first we are printing the raw car makers without any manipulation, and after that let's too expensive here, expensive, and here we have Jeep here, and now car makers start remove too expensive here and print car makers, and after that we will print this some formatted text here. So first we will write in Jeep, so in this case too expensive, that title is removed, so is too expensive for me. That's it. Here you can see here Jeep is too expensive for me, and we removed Jeep from our list. After deciding the list here, let's actually explain this code one by one. So after defining the list, we assign the value Jeep to a variable called too expensive. So when we use this variable to tell Python which value to remove from the list, and here let's actually, I need my marker now to draw some things on the screen, and here. So here we used this value here. We used this value to remove Jeep here. So the value Jeep has been removed from the list here, but it's still accessible through the variable too expensive, right? So allowing us to print a statement about why we removed Jeep from the list of car makers. Often, your lists will be created in an unpredictable order, because you can't always control the order in which your users provide their data, right? So although this is unavoidable in most circumstances, you will frequently want to present your information in a particular order. Sometimes you will want to preserve the original order of your list, and other times you will want to change the original order. So Python provides a number of different ways to organize your list depending on the situations. We can also sort a list permanently with a sort method. Now let's create a new list here. Let's cars, and it's going to be BMW here, cars, BMW, Audi here, Jeep, Jeep here, again Toyota, and Kia, Honda. And here, so Python sorts method makes it relatively easy to sort a list. Imagine we have a list of cars that we write here, and we want to change the order of list to store them alphabetically. To keep the task simple, let's assume that all the values in the list are lowercase, and here we will use the cars.sort here, and that's it. And after that we will print this here, and print cars. So here the sort method changed the order of the list permanently, and the cars are now in an alphabetical order, and we can never revert the original order here. So you can also sort this
list in reverse alphabetical order by passing the argument reverse through here like this. So we pass the argument this reverse through to the sort method, and now this will gives us a reverse order here, but again it will sort our list. So again, the order of the list is permanently changed. So the sorting a list is temporarily with a sorted function. So we can also sort the list temporarily with the sorted function. So let's try this now. So to maintain the original order of the list but present it in a sorted order, you can use the sorted function. The sorted function lets you display your list in particular order, but it doesn't affect the actual order of the list. Let's try this function on list of our cars that we created here: BMW, Audi, Jeep, Toyota, Kia, and Honda. Now we will print here. This is our original list here, and after that we will print the cars, and after that we will print again. This is a here. Let's actually use the new line. So this is a sorted list, and after that we will print the sorted cars here, and after that we will print the list again. This is our original list. That's it. Here now I will explain this code one by one. So we first print the list in its original order here, and then in alphabetical order here. After the list is displayed in a new order, we show that the list is still stored in its original order here. Sorry for that. Let's add the print cars here again. As you can see here, these are the two same original orders. So after presenting it in sorting it out, even we can use the original owner of the list. So here notice that the list still exists in its original order, and after the sorted function has been used, the sorted function can also accept reverse through here and argument if you want to display a list in reverse alphabetical order. And sorting a list alphabetically is a bit more complicated when all the values are not in lowercase. So there are several ways to interpret capital letters when determining a sort order, and specify the exact order can be more complex than we want to deal with at this time. However, most approaches to sorting will build directly on what you learned in this section. To reverse the original order of a list, you can use this reverse method. So if we were originally stored the list of cars in chronological order according to when we owned them, we could easily rearrange the list into reverse chronological order like this. For example, let's delete here and print cars firstly, and after that we will cars.reverse here, and after that we will print the cars again. So notice that the reverse doesn't sort backward alphabetically, it simply reverses the order of a list. So here we have Honda 1 first here, Kia second, Toyota third, Jeep fourth, Audi fifth, and BMW last year in sixth. This is how reverse method works. So the reverse method changed the order of list permanently, but you can revert the original order anytime by applying the reverse again, right? Like logic here. And as you can see here, we apply the reverse second time, and we have the original list, original order. So we can find the length of a list as well. So you can quickly find the length of a list by using the len function. So now firstly use this print
len here, and after that we will enter our list. And here, as you can see, we have 6 items. 0, 1, 2, 3, 1, 2, 3, 4, 5, 6 items here. We have 6 items here. And you will find len useful when you need to identify the number of aliens that still need to be shut down in a game. Determine an amount of data that you have to manage in visualization, and or figure out the number of registered users on a website, among other tasks. So Python counts the items in a list starting with 1, so you shouldn't run into any off by 1 errors when determining a length of a list. And also you should avoid the index errors when working with a list here. So there's one type of error that's common to see when you are working with a list for the first time. So let's say you have a list with 3 items here. Let's actually, instead of BMW, Audi, and Jeep, right? So you have a list of 3 items, BMW, Audi, and Jeep. If you let's delete this as well. If it print the 3 here, this example will give us an index error. So Python attempts to give you the item at index 3, but when it searches the list, no item in cars has an index of 3. Because of this off by 1 nature of indexing in lists, this error is typical, and people think the third item is item number 3 because they start counting at 1. But in Python, the third item number is 2 because it starts from the 0. It starts from 0, 1, and 2. So there's no thing in this list such as 3, right? So if you want to reach the last item, you should enter 2 instead of 3. Okay, that's why we got the list index out of range error. So an index error means Python can't find an item at the index you requested. So if an index error occurs in your program, try adjusting index you are asking for by 1. So then run the program again to see if the results are correct. And here keep in mind that whenever you want to access the last item in a list, you should use the index -1, and this will always work even if your list has changed size since the last time you accessed it. So the index -1 always returns the last item in a list. In this case, the value is Jeep here. And the only time this approach will cause an error is when you request the last item from an empty list. And as you can see here, list index out of range. And here we have no items in cars for now, so Python returns another index error. If an index error occurs and you can figure out how to resolve it, try printing your list or just printing the length of your list, and your list might look much different than you thought it did, and especially it has been managed dynamically by your program. And seeing the actual list or the exact number of items in your list can help you sort out such logical errors. So in this section you learned what lists are, how to work with the individual items in a list. You learned how to define a list and how to add and remove elements. You learned how to sort lists permanently and temporarily for display purposes. You also learned how to find the length of a list and how to avoid index errors when you are working with lists. In previous section, you learned how to make a simple list, and you learned to work with the individual elements in a list. And in this section, you will learn how to loop through an entire list using just a few lines of code, regardless of how long the list is. So looping allows you to take the same action or set of actions with every item in a list. As a result, you will be able to work efficiently with a list of any length, and including those with thousands or even millions of items. So you will often want to run through all entries in a list, performing the same task with each item. For example, in game, you might want to move every element on the screen by the same amount. In a list of numbers, you might want to perform the same statistical operation on every element. Or perhaps you will want to display each headline from a list of articles on a website. So when you want to do the same action with every item in a list, you can use Python's for loop. So let's say we have a list of magicians' names and we want to print out each name in the list. We could do this by retrieving each name from the list individually, but this approach will cause several problems. For one, it will be repetitive to do this with a long list of names. Also, we'd have to change our code each time the list length changed. So using a for loop avoids both of these uses by letting Python manage these uses internally. So let's use for loop to print out each name in list of car models or car makers. So car makers here, and we will use the BMW, or Kia here, Ford, Dodge here, Dodge, and we will also use, for example, BMW, Kia, Mercedes, or it was, yes, Mercedes, and Volkswagen, and so on. So now that's enough actually. So 0, 1, 2, 3, 4, 5 on index and 6 items. So we begin by defining list, and now we will write our for loop. So for cars or makers, you can do here makers. You will understand what these makers or cars are. Instead of using makers plural, we can use one here. So car in car makers, and after that we will use double dot here, and we will print the car. That's it. So now I will explain all of this code here. So we begin by defining a list, just the regular list, just as we did in previous lectures, and as you can see here, it's car makers. So let's, instead of using red, and also use another color here. So we define the list of car makers, and here the next we tell Python here, and also firstly here we have for loop. Look at this. So this line tells the Python to pull a name from the from the car makers and associate it with the variable car, right? So, and next we tell the Python to print the name that has been assigned to car here. So here, as you can see here, we printed each of line this BMW, Kia, Ford, Dodge, Mercedes, and BMW in separate print functions here. So, and Python repeats these last two lines once for each name in the list. It might help to read this code as for every car maker in the list of car makers, print the car maker's name, right? So the output is going to be this, as you see here. So now let's take a closer look at this loop here. So looping is important because it's one of the most ways a computer automates repetitive tasks. For example, in a simple loop like we used in this Python here. So Python initially reads the first line of the loop, which is for car in car makers. So this tells Python to retrieve the first value from the list car makers and associate it with the variable car, right? So this first value is here BMW, and Python reads the new line here, and Python prints the current value of the car makers, which is BMW, because the list contains more values. So, and Python returns to the line of the first loop. So now Python retrieves the next name in the list, which is Kia here, Kia, and associates with the value with the variable magician. So here we have firstly in first loop here we had BMW, secondly we had Kia here, in third loop we had Ford, and here Python prints the current value of car again, which is now here, right? And Python repeats the entire loop once more with the last value in the list. in this case Ford, and then Dodge, Mercedes, and lastly Volkswagen. And after that we are ending this loop, and here we printed all the loop. So when you are using loops for the first time, keep in mind that the set of steps is repeated once for each item in the list. So no matter how many times items are in the list. So if you have a million items in your list, Python repeats these steps a million times, and usually very quickly. And also keep in mind when writing your own for loops that you can choose any name you want for the temporary variable that will associate it with each value in the list. You can do, for example, my car make or so on. And of course you have to change the my car make here. That's it. However, it's helpful to choose the meaningful name that represents a single item from the list. For example, instead of doing cars here, writing this for cars in car makers, or for dogs in dogs, you can write for dog in dogs here, or for cat in cats, because this first item represents just a one item, but here this represents list in this case. The naming conventions can help you follow the action being done on each item within a for loop. Using a singular and plural names can help you identify whether a section of code is working with a single element from the list or the entire list. You can do just about anything with each item in a for loop. Let's build on previous example by printing a message to each car makers, telling them that they have performed a great model, or let's actually tell them that what their models and great car. Let's actually, instead of telling what they are, let's provide just a great car, right? The only difference here we will make, I will tell you right now, in this code we will compose a message to each car make, starting with the car makes make, right? So in this we will print this, we will use the format again, and car, oops, not like this. Here inside this format we will car make and title, and this was a great car, great car. And after that, let's print this out. And as you can see here, the only difference in this code is where we compose a message to each car model, starting with the car model's name, and after that we are telling our message. So the first time through the loop, the value of car make is BMW. So Python starts the first message with the name of BMW, and the second time through, the message will be the Kia here, right? So and here, as you can see here, the Kia, and the third time through, the message will be Ford. Fourth time is gonna be Dodge. The fifth time is gonna be Mercedes, and the sixth time is gonna be Volkswagen. So you can also write as many lines of code as you like in the for loop. Every intended line following in the line for car make and car makers is considered inside the loop. So here this is the outside the loop, but if we write the tab here, and this is inside the loop, so it will loop inside here every time our loop works. So therefore you can do as much work as you like with each value in the list. So let's add a second line to our message, telling each car makes that we are looking to their next trick. And now in order to do that, we will use this inside here. So we will print this again. We will use the format, and cars are great car, and now we will something car here. So now we will do this, that BMW, or
mpg is high on, or let's actually miles per gallon, and yes, miles per gallon is high on this car. For example, in this case we will use car make. And now let's run it, and as you can see here, the BMW great car, miles per gallon is high on BMW. Kia great car, miles per gallon is high on Kia. Ford great car, miles per gallon is high on Ford. And here, because we indented both cars to print here, each line will be executed once for every car make in the list. So the new line, let's actually use the new line here and see how this output will change. And as you can see here, a new line in the second print calls insert a blank line after each pass through the loop. So this creates a set of messages that are neatly grouped for each car make on the list. So now let's run this list here. So this is our first iteration. So this is our first loop, second loop, third loop, fourth loop, fifth loop, and sixth loop. And here our loop ends because we do not have any item anymore, any item into the list, and that's why our loop breaks here. That's it. So oops, let's actually fix that. And here, that's it. So here you can use as many lines as you like in your for loops. In practice, you will often find it useful to do a number of different operations with each item in a list when you use a for loop.
What happens once a for loop has finished executing? Usually you will want to summarize a block of output or move on to other work that your program must accomplish. Any lines of code after the for loop that are not intended are executed once without repetition. So let's write a thank you to group of car makers as a whole, and thanking them for putting on an excellent cars. So to display this group of message after all of the individual messages have been printed, we place the thank you message after the for loop without the indentation here. So now we will write print and thank you every car makers. These cars are special and great. And here, now let's run this, and you will see this message is just executed once. So the first two calls to print are repeated once for each car makers in the list, as you saw earlier. However, because the last line is not intended, it's printed only once. If we add indentation to it, you will see, as you can see here, thank you every car makers, thank you every car makers, thank you every car makers, and so on. So we will delete this indentation and we will get this thank you message only once, because it's not included in this loop because of the indentation we didn't put before the print here. So when you're processing data using the for loop, you will find that this is a good way to summarize an operation that was performed on an entire dataset. For example, you might want to use a for loop to initialize a game by running through the list of characters and displaying each character on the screen. You might then write some additional code after this loop that displays a play now button after all the characters have been drawn to the screen. Python uses indentation to determine how a line or group of lines is related to the rest of the program. In these examples, The lines that printed messages to individual car makers were part of the for loop because they were indented. So Python's use of indentation makes code very easy to read. Basically, it uses white space to force you to write neatly formatted code with a clear visual structure. In longer Python programs, you will notice block of code indented at a few different levels. These indentations levels help you gain a general sense of the overall program's organization. So as you begin to write code that relies on proper indentation, you will need to watch for a few common indentation errors. For example, people sometimes indent lines of code that don't need to be indented, or forget the indented lines that need to be indented. So seeing examples of these errors now will help you avoid them in the future and correct them when they do appear in your own programs. So now let's examine some of the more common indentation errors. So you can also forget the indent. Always indent the line after the for statement in a loop. If you forget, Python will not remind you here. And as you can see here, expected an indented block. So here, if we write, for example, car makers and just delete this indentation, get an error also. So let's actually delete this and I will explain all of this. So the call to print should be indented. So, but it's not here. So when Python expects an indented block and doesn't find one, it lets you know which line it had problem with. And if we run this code again, and let's run here, and as you can see, we have an indentation error as line 3. So you can usually resolve these kinds of indentation errors by indenting the lines or lines immediately after the for statement. You can also forget to indent additional lines. So sometimes your loop will run without any errors but won't produce the expected result. So this can happen when you are trying to do several tasks in a loop and you forget to indent some of its lines. For example, this is what happens when we forget to indent the second line in the loop, and here we will not get any error here. And now if we run this, and as you can see here, list object has no attribute title. As a result, the first print, and if makers here, this code will, and as you can see, let's car make. This code will run without a problem. We just edit this, and if we change this to car make, and we will get this as well. So here, as the result here, the first printf call is not indented, and so that's why first print call is executed once for each name in the list because it's indented. But here the second print call is not indented, so it's executed only once after the loop has finished running, because the final value associated with Volkswagen here, and Volkswagen is the only one who receives the who receives the thank you every car makers. These cars are special and great, and Volkswagen only one who gets the miles per gallon is high on Volkswagen. And here, this is a logical error. This syntax is valid Python code, but the code does not produce the desired result because a problem occurs in its logic. So if you expect to see certain action repeated once for each item list and it's executed only once, determine whether you need to simply indent a line or group of lines. So here, that's now we are getting this error here because in for loop, if you have a for loop here, for now This print message will execute at once, but your program firstly execute your for loop again, and again, and then after completing the for loop, it will go to next lines here. Many reasons exist to store a set of numbers. For example, you will need to keep track of the positions of each character in a game, and you might want to keep track of players' high scores as well. In data visualizations, you will almost always work with a sets of numbers such as temperatures, distances, population size, or altitude, longitude values, among other types of numerical sets. So lists are ideal for storing set of numbers, and Python provides a variety of tools to help you work efficiently with lists of numbers. So once you understand how to use these tools effectively, your code will work well even when your list contains millions of items. So you can also use the range function. So Python's range function makes it easy to generate a series of numbers. For example, you can use the range function to print a series of numbers like this for my value here in range, for example, from 1 to 10, and here we will print my value. And here you will see, and here you will see range from 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So although this code looks like it should print the numbers from 1 to 10, it doesn't print the number 10. In this example, range prints only the numbers from 1 through 10. So I want to explain this by drawing something on the screen here like that. For example, this is range here. For example, we wanted variable 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 9, and 10. Here when we ask range for a number from 1 to 10, it will give us from here and from 1 to 9. So this is the number this code will give us here. So as I said, in this code, the range prints only numbers from 1 through 10, through 9. Let's run it again. And here, so this is another result of the off by 1 behavior you will see often in programming languages. And the range function causes Python to start counting at the first value you give it, and it stops when it reaches the second value you provide. Because it stops at the second value, the output never contains the end value, which would have been 10 in this case. To print numbers from 1 to 10, you will do this. Just 11, write 11, and that's it. Here, as you can see, we printed values from 1 to 10. So if your output is different from what you expect when you are using range, try adjusting your end value by 1. So you can also pass range only one argument, and it will start a sequence of numbers at 0. For example, range 6 here will return the numbers from 0 to 6. So you can also use the range to make a list of numbers. So if you want to make a list of numbers, you can convert the results of range directly into a list using the list function. So when you wrap list around the call to range function, the output will be a list of numbers. In this example, in the example of previous section, we simply printed out series of numbers, and we can use list to convert that same set of numbers into a list. So in order to do that, we will do numbers, or my special numbers, numbers equals list here and range 1, 6 or 11 here. So now we have to add here, and we will add, after that we will print the my special numbers. That's it. Here you can see the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can also use the range function to tell Python the skip numbers in a given range. If you pass a third argument to range here, Python uses that value as a step size when generating numbers. For example, here's how we'll list the even numbers between 1 and 10. We will do here 2, and we will do 2 here again, and here, and as you can see here, 2, 4, 6, 8, and 10. So in this example, the range function starts with the value 2 and then adds 2 to that value. It adds repeatedly until it reaches or passes the end value 11. I want to also illustrate this on screen here. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, 9, 10 here. So here, what you see is, so here we are saying that we will start from 2 and end from 10, 11, but this means 10 here, as we explained here. So we will start from the 2 here. So we will start first from this 2, 4, because as you can see here, we are passing 2 in each number, and then we come here, and here we go to 6, and here we come here, and here we go to 8, and here we are, and then we are going to 10, and this is where our range ends. So you can create almost any sets of numbers, or you want to use so you can also create almost any sets of numbers you want to using the range function. So for example, consider how might make a list of the first 10 square numbers, that is the square of each integer from 1 through 10 in Python, which is 2 asterisks like that. So let's actually close this. So now here's how you might put the first 10 square numbers onto a list. So here we have a my special, or my squares here, and here we will create an empty list. Now we will use the for loop, my value here in range, and here we will start from 1 to 11, and here we will use the my squares here equals my value asterisk 2, add dual asterisk here, and 2, and here we will use my squares here that append or my value here, here my squares that append or my square here, and we will change it, my square equals my value asterisk 2, and here we will use my squares that append the my square, and that's it. And after that, of course, we will need to print the squares here, but outside the for loop. As you can see here, we are printing outside the for loop squares here, or my square. Yeah, that's it. Now let's run it, and as you can see here, 1, 4, 9, 16, 25, 38, 49, 64, 81, and 100. So we start with an empty list called squares here. Actually, let me here. So here we start with the empty list called my squares. Here, let's actually use that marker. So here we start with the empty list called my squares. Then we tell Python to loop through each value, from 1 to 10. in this case we write 11 using the range function. So inside the loop, the current value is raised to the second power and assigned to the variable my square here. Each new value of square is then appended to my square list here. As you can see here, we are using append here. So this works like that. For example, this is our my squares here, and here we added, and then another loop comes, we added another value, and then another loop comes, we added another value inside it, and until the 10 times here. So that's it. And finally, when the loop has finished running, the list of squares is printed on the screen. In previous lectures, you learned how to access a single element in a list, and in this section, you've been learning how to work through the elements in a list. So you can also work with a specific group of items in a list called a slice in Python. So to make a slice, you specify the index of the first and last elements you want to work with. As with the range function, Python stops one item before the second index you specify. The output of the first three elements in a list you will request here indicates truth 0 to 3 here. So now if we write 0 to 3 here, we will get this here, and this is our slice. So here I will create some examples here. So let's again make some example about car makers, or let's sometime now car makers is okay. Car makers, here we will add BMW, Honda here, we will add Volkswagen, we will add the Ford, Hyundai, Kia, and Nissan here. So here we will print the 03. So print car makers 03 here. So this code now this code prints a slice of the list. So the output retains the structure of a list and includes the first three car makers in the list here. So in this case, it's gonna print us here. It's gonna print us BMW, Honda, and Volkswagen. So it will print us these three items since we write in 0 and 3 here. So now let's print this, and as you can see here, BMW, Honda, Volkswagen. So you can generate any subset of a list. For example, if you want to second, third, and fourth item in a list, you will do this. Here, as you can see here, we started Honda, Volkswagen, and Ford. And this time the slide start with Honda here and ends with the Ford. So if you omit the first index in a slice, Python automatically starts your slice at the beginning of the list, like this here. You just need to add this double dot here, and as you can see here, we got BMW, Honda, Volkswagen, and Ford here. So a similar syntax works if you want a slice that includes the end of a list. So for example, if you want to all items from the third item through the last item, you can do this, 2 double dot, but this double dot here will come after the number to get the last item. So here, get from the last item. Now in this case, we will get, as you can see here, it's actually, where's my marker? Yes. So here we got Nissan, Kia, Hyundai, Ford, Volkswagen, and that's it. We got from here to here. So we got 2 here. We counted 0, 1, second, And from second, we told Python that get all those items from the last. So Python returns all the items from the third item through the end of the list. Volkswagen, Ford, Hyundai, Kia, Nissan. So this syntax allows you to output all the elements from any point in your list to the end, regardless of the length of the list or something. So recall that negative index returns an element a certain distance from the end of a list. Therefore, you can output any slice of the end of a list. For example, if you want to output the last 3 car makers on the car makers, we can use this slice like this here. -3, -3 here, and this double dot here, and after that we will print this. And as you can see here, we printed Hyundai, Kia, Nissan here. So you can include a third value in the braces, indicating a slice. So if a third value is included, this tells Python how many items to skip between items in the specified range. So you can use a slice in a for loop if you want to loop through the subset of the elements in a list. So in this example, we will loop through the first 3 car makers and print their names as a part of a simple car maker. Now we will print here. Here are the first 4 car makers in my list here, and after that we will use for loop for car maker in car makers, and here we will enter this. Here 4, and after that we will print here. We will print the car maker dot title. So here we will, let's run this, and as you can see here, we got this example. We got this output. So instead of looping through the entire list of players or car makers, Python loops through only the first 4 car makers. So slices are very useful in a number of situations. For instance, when you are creating a game, you could add a car maker's model to a list every time that that car is running or playing, the player is playing with that car. So you could then get a player's top 3 scores by sorting the list in decreasing order and taking a slice that includes just the first 3 scores. Often you will want to start with an existing list and make an entirely new list based on the first one. So let's explore how copying a list works and examine one situation in which copying a list is useful. So to copy a list, you can make a slice that includes the entire original list by omitting the first index and the second index, like this, right? So this tells Python to make a slice that starts at the first item and ends with the last item, producing a copy of the entire list. For example, imagine we have a list of our favorite car makers and want to make a separate list of car makers that our friend drives. So this friend likes everything in our list and drives everything on our list so far, so we can create their list by copying ours. So in order to do that, you will write friend that likes cars, and here we will use this, and let's actually my favorite cars, and here friend's favorite car, and here now we will use this my favorite cars and this, and after that we will firstly print this friends favorite cars, and after that firstly, of course, this is the friend's favorite cars and this is my favorite cars, and after that we will first print the my favorite cars. So print my favorite cars are like this, and after that we will print our my favorite cars, and after that we will print, of course we need to add a new line before it. So my friends favorite cars are here, and after that we will print friends favorite cars, and here we will run this now, and as you can see this is our output. So I added this new line here. Oops, sorry, again it's not work, or yes, it's working now. Okay, so here I added this new line character to this to show our output new line here. So I could be added this new line after the my favorite cars here, but it's more easy to add here instead of writing some formatting and things in last my favorite cars print function. So first we make a list of car makers we like, called our favorite car makers, called my favorite cars. Then we make a new list called friends favorite cars, and we make a copy of my favorite cars by asking for a slice of my favorite cars without specifying an indicator like this here, and assign the copy of my favorite cars to friends favorite cars. So when we print each list, we see that they both contain the same cars. So to prove that we actually have two separate lists, we will add a new new car to each list and show that each list keeps track of the appropriate person's favorite car. So in order to do that, we will do after my favorite cars here, we will do my favorite cars that append here. Let's add new car maker name. In this case, Toyota, right? So Toyota. Oops. Toyota here, and after that we will also add friends favorite cars, and we will append the let's add Fiat, right? And here we will not change this print functions, and now we will run our code and see what will change here. And as you can see here, so we copy the original items in my favorite cars to the new list called friends favorite cars, as we did in the previous example. And next we add a new car maker to each list, and we add Toyota to my favorite cars, and we add Fiat to friends favorite cars. And when and we then print the two lists to see whether whether each of these favorite cars is in the appropriate list. So here the output shows that our Toyota appears in our list of favorite cars, but Fiat does not. So we can see that Fiat now appears in our friends list, but Toyota doesn't, right? If we had a simply set friends favorite cars equal to my favorite cars, we will not produce two separate lists. For example, here's what happens when you try to copy a list without using a slice. Oops. Without using a slice. And as you can see here, we both have Fiat. So instead of assigning a copy of my foods to my favorite cars to my friend's favorite cars, we set a friend's favorite cars equal to my favorite cars. So this syntax actually tells Python to associate the new variable to my favorite cars with a list that is already associated with my favorite cars. So now my favorite cars, it will also appear in friends' favorite cars, and so on. So likewise, the Toyota will appear in both lists, even though, or Fiat will appear in both lists, even though it appears to be added only to my favorite cars. And as you can see here, Toyota and Fiat appears in the same list. So the output shows that both lists are the same now, which is not we wanted here. And don't worry about the details in this example for now. If you are trying to work with a copy of list and you see unexpected behavior, make sure you are copying the list using a slice, as we did in this in the first example here. Lists work well for storing collections of items that can change through the list of a program. So the ability to modify lists is particularly important when you are working with a list of users on a website or a list of characters in a game. So, however, sometimes you will want to create a list of items that cannot change. So tuples allows you to do just that. So Python refers to values that cannot change as immutable, and immutable list is called tuple. So a tuple is just like a list, except you use parentheses instead of a square braces. Once you define a tuple, you can access individual elements by using each item's index, just as you would for a list. For example, if we have a rectangle that should always be a certain size, we can ensure that its size doesn't change by putting the dimensions into a tuple. So my dimensions here, we will add 250 here and 100 here, and here we will print first we will print dimension 1, and then we will print oops, not like that. Of course we need to get a variable name. So my dimensions 1 here, and here, as you can see here, we define the tuple dimensions using the parentheses instead of a square braces like we did in lists. So then we print each element in the tuple individually using the same syntax we have been using to access elements in a list. And as you can see here, we first printed 250 and 200 after that. So and actually let's see what happens if we try to change the items or change one of the items in the tuple dimensions. Now here we will write my dimension. Actually, let's name it my tuple, right? So it will be more explanatory. My tuple dimensions, and here we will use the my tuple dimensions equal 0. Let's make 0 to 150 here, and after that print this my tuple dimensions 0, and after that print my tuple dimensions 1. And here, so this is the error we got here. Actually, delete this for now. So this code tries to change the value of the first dimension, but Python returns a type error because we are trying to alter a tuple, which can't be done to that type of object. And Python tells us we can't assign a new value to an item in a tuple here. As you can see here, tuple object does not support item assignment. So this is beneficial because we want to Python raise an error when a line of code tries to change the dimensions of the rectangle. And tuples are technically defined by the presence of a comma. So the parentheses make them look neater and more readable. So if you want to define a tuple with one element, you need to include trailing comma here. So if you want to define tuple just one element, you need to include this trailing comma. Yeah, so it doesn't often make sense to build a tuple with one element, but this can happen when tuples are generated automatically. So you can also loop through all values in a tuple. So you can loop over all the values in a tuple using just a for loop, just we did in previous lectures with lists. So here, now we will add new tuple. So my tuple or my car models, my favorite car models that I will like forever. And this is not the best name for that, but I've just general explanatory purposes. And here we will add tuples that, for example, I like BMWs. I like here, for example, I like Volkswagen, but the sporty ones. Here I like Fords here. So that's it, Ford. And here we will loop through all the tuples in this list. So remember, this is not a list. This is actually, let me here. So remember, keep in mind that this is not a list. This is tuple. This is tuple here. So here we will loop through all the items in this list. So for my fave car, and here we will do in my favorite car models that I will like forever. And here we will print here my fave car, and let's print this. And here, as you can see here, we loop through all the elements here. So Python returns all the elements in a tuple, just as it would for a list. So although you can modify a tuple, so that's it, how this works here. So although you can't modify a tuple, you can assign a new value to a variable that represents a tuple. For example, if you wanted to change the dimensions of a previously created rectangle dimensions, here, for example, 250 and 100, and we will print the original dimensions here, original dimensions here, and after that we will create a for loop, dimension in dimensions, and after that we will print here, we will print the dimension, and here we will, after that we will do again dimensions. We will change the dimensions here, dimensions, and equals, for example, 500 and 200, right? And after that we will print this new line, modified dimensions, and here we will create a new for loop. Actually, let's use double dots here, make it look nicer, right? So for dimension in dimensions, and here we will print dimension again. That's it. And here we will, let's run it. That's it. And here, this is our output. So the first 4 lines defines the original tuple and print the initial dimensions. And we then associate a new tuple with the new variable dimensions, and print the new value. And Python doesn't raise any error this time because reassigning a variable is valid. So when compared with list, tuples are simple data structures, and use them when you want to store a set of values that should not be changed throughout life of a program. Conditional programming or branching is something you do every day, every moment. It's about evaluating conditions. If the light is red, then I can cross. If I'm hungry, I need to eat. And if I am late for work, then I will call my boss. And the main tool is the if statement, which comes in different forms and colors, but its basic function is to evaluate an expression and based on the result choose which part of the code to execute. As usual, let's look at this example here. So if I am m is late here and true here, true, and after that we will, if is late is true, then print I need to call my boss. And this is possible the simplest example. So when fed to if statement, the is late acts as a conditional expression which is evaluated
in a Boolean context. And remember that is late here, this is late variable here is Boolean, not string, not value, tuple, or anything. It is a Boolean. It's another primitive type, Boolean. You will learn about that in next lectures also. So Boolean also can, Boolean has two values, either false or true. So if the result of the evaluation is true, then we enter the body of the code immediately after the if statement. Notice that the print instruction is indented, which means that it belongs to scope defined by the if here, and as you can see, this is indentation here. So if we run this code, as you can see, I need to call my bus. If we make it is late false, so we are not late for now, and as you can see, we didn't evaluate anything. So this code didn't work or didn't need it to work here. So depending on the result of evaluating the late is late expression, we can either enter block 1 or block 2, but not both. So block 1 is executed when late evaluates to true, while block 2 here is executed when the late evaluates to false. So trying assigning false and true to this is late to see how the output of this code changes accordingly. So in this example, also introduced the else clause in which becomes very handy when we want to provide an alternative set of instructions to be executed when an expression evaluates to false within an if clause. So the else clause is optional, as is evident by comparing preceding two examples, and with these examples we will do in next lecture. So I'm waiting you in next lecture. Often you will want to take one action when a conditional test passes and different action in all other cases. Python's if-else syntax makes this possible. The if-else block is similar to a simple if statement, but the else statement allows you to define an action or set of actions that are executed and run when the conditional test fails. When the if test fails, and in this case we will execute else. So we will display some message here. Now let's write something that, for example, we have a car here, and actually let's draw a car here. And we don't want this car to for example, older than 10 years, right? So let's make this 10 years. So we want this car to less than 10 years, so we will want a new car, right? And that's why we're gonna do here that let's make, for example, car model. Here it's going, in this case, let's make it BMW, and car year, in this case, let's make it 2015, and here we will add if our car model, so car year minus 2023, in this case, of course, today's year is 2023, and actually let's delete this for now. Also delete this, and now car year minus 2023 is, so our car year, for example, in this case, our car year is going to be 8, while 8 is less than 10, then it will evaluate 3, right? So in this case, print your car is, and we will also use format here. Format your car is car year minus 2023, years old and it's almost new, right? And here we will also add else statement. If our car has age of more than 10, we will write this here. Else print sorry, I don't want, or sorry, our company doesn't buy cars that more that age is more than 10. And after we will print again, and your car age is, of course we need to add F here, format car year minus 2023. Your car, or yes, actually instead of car we can also write BMW, right? So, or car model is years old and it's almost new and we can buy it. And here in else, sorry, our company doesn't buy BMW. Let's actually add another format here. So we will add F here and format car model that age is more than 10 and car year here. Now let's run this. And as you can see here, your BMW, oops, actually we need to do this opposite here. Sorry for this. We got right numbers, but we got negative here. So we need to do this. We need to subtract our car year from 2023. Let's do the same here. And now your BMW is 8 years old and it's almost new. We can buy it. But in else here, else command here didn't execute it because if here evaluated true. If we make our car year, for example, 2005, then it will give your BMW is 18 years old and it almost, no, oops, car year. Of course, we need to change it again. 2023 minus car year. And here we will get else here. Sorry, our company doesn't buy BMW that age is more than 10 and your car age is 18. So in first example, actually, let's try again, 2015. So in this example, our if conditional test passes and the first block of this print here call is executed. So if the test evaluates to false, then the else block is executed. For example, 2005, and in this case, our false will not be executed because it is here, because it is false, right? So it will not execute. Instead, our else command here will execute here. So this code works because it has only two possible situations to evaluate. A car is either old enough or not, right? So the if-else structures works well in situations in which you want Python to always execute one of possible situations or actions. So in a simple if-else chain like this, one of two actions will always be executed, no matter if our car year is 1000 or some here. As you can see, sorry, our company doesn't buy BMW that age is more than 10. Programming often involves examining a set of conditions and deciding which action to take based on these conditions. Python's if statement allows you to examine the current state of a program and respond appropriately to that state. In this section, you will learn to write conditional tests, which allow you to check any condition of interest, and you will learn to write simple if statements, and you will learn how to create a more complex series of if statements to identify when the exact conditions you want are present. And you will then apply this concept to lists, and so you will be able to write a for loop that handles most items in a list one way, but handles certain items with specific values in different way. So this example here, we will show the if tests that let you respond to special situations correctly. Imagine you have a list of cars and you want to print out the name of each car. So car names are proper names, so the names of most cars should be printed in title case. However, the value BMW here should be printed in all uppercase, and here we will do that right now. So we will car makers here, and after that we will equal to, so first we will enter the Volkswagen, the BMW, the Toyota, Ford, and G. And here we will use the for car in car makers, and here, so if car equals to BMW, then we will print the car dot upper, and else here we will print the car dot title. That's it. So now let's run it. That's it here. If BMW, that's it. Now this will work here. So now the loop in this example first checks if the current value of a car is BMW. If it is, the value is printed in uppercase here with this function, right? If the value of a car is anything other than a BMW, it is printed in a title case. And here, this is our output. Here, all of these names are written in title case, but here BMW is written in uppercase. So this example combines a number of concepts you will learn about in this section. Let's begin by looking at the kinds of tests you can use to examine the conditions in your program. So we can also use conditional tests in Python. So at the heart of every if statement is an expression that can be evaluated as true or false, right? So Python uses the values true and false to decide whether the code is in an if statement should be executed or not. So if a conditional test evaluates true, then Python executes the code following the if statement. So if the test evaluates false, Python ignores the code following the if statement. We can also check for equality. So the most conditional tests compare the current value of a variable to the specific value of interest. So the simplest conditional test checks whether the value of a variable is equal to the value of an interest. In order to do that, we will just delete for now our for loop, and we will print here now car equals BMW here. Or let's actually, instead of writing that, let's use car makers. BMW's index is 1, BMW, and BMW here. So now, as you can see, we got an error, cannot assign to a function call. So here, that is, we're gonna get an error if you try to do that. However, if you try this in Python console, which we will now, here we opened our Python now. You can reach this by using just Python. And here you're gonna see this Python 64-bit or 32-bit. You just enter that, and here you can see the new tab opened. Here, let's actually make it closer. So most conditional tests are compare the current value of a variable to a specific value of interest. Let's create a new value named car here and make it BMW. And after that, we will check the is car equal to BMW. And here you can see we got true. So the first line here, actually, let me get this. So this first line, let me fix this. Now here, this first line here sets the value of a car sets the value of a car to be actually BMW using a single equal sign. So here we used the single equal sign here, right? As you've seen many times already, this sign. So the next line checks whether the value of a cars is BMW here. You see here? Oops, actually, let's use different color here. So now we are checking this by using a double equal sign. Double equal sign. Here, car is BMW. So this is an equality operator. So so this equality operator here, this is named equality operator. Let me actually write that here. This is equality operator. So here, this equality operator returns true, like in this case, if the values on the left and the right side of the operator match. In this case, these are matched. So car is actually equals to BMW. Actually, let me use the different color. So here, our car is equals to BMW here, because we already assigned that in first line, and our BMW here equals to BMW, right? So we are checking this BMW. And here they match. In this case, they will return true. That's it. But here the values in this example match, so Python returns true. So when the value of a car is anything other than a BMW, for example, let's try car equal the Jeep here, we will get false. If car equal uppercase B, BMW, we will get false again, because these equality operator are case sensitive in strings. So here, if we try something, ice cream, we will get false again. So that's it here with operators. So a single equal sign is really a statement, and you might read the first line of a code here that we are set the value of a car equal to, for example, Jeep. On the other hand, a double equal sign asks a question. Let me actually write that down. Some new programmers might confuse this with initialization here. So this double equal signs asks this. Let me get this text here. This asks this. So is the value of car equal to BMW? So here our double equal sign asks whether a value of this value of a car in this case is variable, right? Because we use this car as a variable name, and here is the value of car equal to BMW. In this case, it's equal, so it will return true. In this lecture, you will learn how to write functions, which are named blocks of code designed to do one specific job. So when you want to perform a particular task that you have defined in a function, you call that function responsible for it. So if you need to perform that task multiple times through your program, you do not need to type all the code for the same task again and again. You just call the function dedicated handling that tasks, and
call tells Python to run the code inside the function. So you will find that using function makes your program easier to write, read, test, and fix. So let's first design a function now. So now we will def here, greet typhoon here, and after that we will write this here, print here, hello typhoon, right? Or hello students here. And here, after that, we will just call that function, in this case, greet typhoon here. And as you can see here, we wrote hello students here. And the best thing with functions is you can call that function how many times you want here. So for example, let's write this here. 6 get greet typhoon here, and as you can see, we got 1 2 3 6 hello students message here. So this example shows the simplest structure of a function. The first line, actually I want to draw here so it will be help you to visualize things here. So that's it. So here the first line uses the keyword def here to inform Python that you are defining a function. So here this is the function definition, which tells Python the name of the function here. This is the name of the function here, which we are telling greet typhoon, and if applicable, what kind of information the function needs to do its job. So in this case, we're gonna add this parameters inside this parenthesis here, which you will learn right here. So, and also the parenthesis holds that information. In this case, the name of the function is greet typhoon, and it needs no information and to do his job, right? So its parentheses are empty here, empty here, empty here for now. So even so, parentheses are required. So if you want to define the function, whether it's empty or not, you need that parenthesis here. So it's a basic syntax. So finally, the definition ends with this colon here. The definition ends with this colon here, right? So any intended lines here, any indented lines that follow greet typhoon makes up the body of the function. So here, this is the body of our function here. Let me actually take this here. So here, body of function. So the text on the second line here, the text on the second line is here the print, right? So here this it look actually here, as you can see, this is the hello student, but we can also get that parameter from something. For example, this, in this case, it's name, right? And here we could do, for example, hello, wherever the parameter we entered, and then name, which you will learn in this section of our course here. And the line print hello students is the only line of code in the body of this function. So the greet typhoon has just one job, which is print hello students, right? Print hello students. So when you want to use this function, you have to call it. A function call tells Python to execute code in the function. So to call a function, you write the name of the function here, followed by any necessary information in parentheses. So because in our greet typhoon function, there's no information needed here, calling our function is as simple as entering greet typhoon here, and when we enter this as expected, we write our outputs here, which is hello students.
If you modify the function greet typhoon slightly, it can greet the user by name. For the function to do this, you enter username in the parentheses of the function definition at here def greet typhoon here. So by adding, for example, username here, you allow the function to accept any value of username you specify. So the function now expects you to provide a value for username each time you call it. So here, let's run this code, and here we got an error because greet typhoon missing one required positional argument, which is username, right? So in order to get rid of the error, we need to give some value in it, right? So for example, let's make it one of our student name, for example, Alex here, Alex. And here we got no error, but here the Alex variable here has no use state. So we got to get rid of the error, but we are not using Alex here. So in order to do that, we will write a print function again. So print if hello here, print, we're gonna use format hello dear student, and after that we will use username dot upper here, for example. So we will write Alex name uppercase, and after that we will add this ternary here. That's it. Let's run this, and here hello dear student Alex. So entering greet typhoon Alex here, actually let me get this. So entering greet typhoon Alex calls greet typhoon and gives the function the information it needs to execute print call. So the function accepts the name you passed it and displays the greeting for the name. So let's actually draw this on the screen, how this works on diagrams. So here we are getting the name, some username, right? So in this case, let's call this a username, and after that, whenever some function or some function call uses it here, the Alex actually goes to here, right? So actually let me delete that. Here we will write this again. So here this Alex, we are giving this Alex to this username, right? And after that, this username goes to this print here, which we are printing username.upper. So whenever we call this typhoon here, first we pass this value to greet typhoon, and then greet typhoon uses this value inside the print statement, right? So in order now, when we enter the greet typhoon at the first here, Alex was like this, Alex here, and here the username here, this is the fifth line here, and after that we are giving to first line. So in first line Alex is again like this, but here we are printing Alex here. In the second line we are printing Alex, but with uppercase. Actually we didn't change it here, Alex here, and as you can see here we've written it in uppercase here. So actually we as you know from previous lectures, we didn't change this Alex variable permanently. So if we use that without the upper method of strings, we will get the Alex that we wrote here. So likewise, entering the, for example, let me actually greet here, and one of our students' name, for example, Murtaza here. And when we try this, we will get same, but with Murtaza here. So again, after using Alex here, so this is our first call, we are calling Murtaza, which applies the same. Let me actually use the different color here. So we are calling Murtaza. This Murtaza gives the username gets to username here, and after the both here uses the upper method to make it print the uppercase here. So if we do, for example, greet Typhoon here, Nikat here, and this will do the same no matter what. Here Nikat is gonna go here again. Nikat is gonna go here again to username, and username will go to this print function. So you can do this how much you want, whenever you want here. And here in this code here, the greet Typhoon function, we defined the greet Typhoon to require a value to for the variable username, right? So once we call the function and gave it the information, for example, a person's or student's name, it printed the right greeting. So the variable username in the definition of greet user is an example. Greet Typhoon here is an example of parameter. So this username, as we said, this is a parameter, right? So for example, we can give, as I said, we can give it whatever value we want. We can even give it an integer here, integers here. Let's try this. And as you can see here, we got error because the upper method, it doesn't exist on integer here. So, and as you can see here, when we deleted the upper, we get rid of an error. We even printed the numbers, which you will learn how to find that and fix that in next lectures. If you modify the function greet Typhoon slightly, it can greet the user by name. For the function to do this, you enter username in the parentheses of the function definition at here def greet Typhoon here. So by adding, for example, user name here, you allow the function to accept any value of username you specify. So the function now expects you to provide a value for username each time you call it. So here, let's run this code, and here we got an error because greet Typhoon missing one required positional argument, which is username, right? So in order to do get rid of the error, we need to give some value in it, right? So for example, let's make it one of our student name, for example, Alex here, Alex. And here we got no error, but here the Alex variable here has no use to it. So we got to get rid of the error, but we are not using Alex here. So in order to do that, we will write a print function again. So print if hello here, print, we're gonna use format hello dear student, and after that we will use username dot upper here, for example. So we will write Alex name uppercase, and after that we will add this ternary here. That's it. Let's run this, and here hello dear student Alex. So entering greet Typhoon Alex here, actually let me get this. So entering greet Typhoon Alex calls greet Typhoon and gives the function the information it needs to execute print call. So the function accepts the name you passed it and displays the greeting for the name. So let's actually draw this on the screen, how this works on diagrams. So here we are getting the name, some username, right? So in this case, let's call this a username. And after that, whenever some function or some function call uses it here, the Alex actually goes to here, right? So actually, let me delete that. Here, we will write this again. So here, this Alex, we are giving this Alex to this username, right? And after that, this username goes to this print here, which we are printing username.upper. So whenever we call this Typhoon here, first we pass this value to greet Typhoon, and then greet Typhoon uses this value inside the print statement, right? So in order now, when we enter the grid typhoon at the first here, Alex was like this, Alex here, and here the username here, this is the sixth line, no, fifth line here, and after that we are giving to first line. So in first line Alex is again like this, but here we are printing Alex here. In the second line we are printing Alex but with uppercase. Actually we didn't change it here, Alex here, and as you can see here we've written it in uppercase here. So actually we as you know from previous lectures, we didn't change this Alex variable permanently. So if we use that without, again, without the upper method of strings, we will get the Alex that we wrote here. So likewise, entering the, for example, let me actually greet here, and one of our students' name, for example, Murtaza here. And when we try this, we will get same, but with Murtaza here. So again, after using Alex here, so this is our first call, we are calling Murtaza, which is applies the same. Let me actually use the different color here. So we are calling Murtaza. This Murtaza gives the username gets to username here, and after the both here uses the upper method to make it print the uppercase here. So if we do, for example, greet typhoon here, Nikat here, and this will do the same no matter what. Here Nikat is gonna go here again. Nikat is gonna go here again to username, and username will go to this print function. So you can do this how much you want, whenever you want here. And here in this code here, the greet typhoon function, we defined the greet typhoon to require a value to for the variable username, right? So once we call the function and gave it the information, for example, a person's or student's name, it printed the right greeting. So the variable username in the definition of greet user is an example. Greet typhoon here is an example of parameter. So this username, as we said, this is a parameter, right? So for example, we can give, as I said, we can give it whatever value we want. We can even give it an integer here, integers here. Let's try this. And as you can see here, we got error because the upper method, it doesn't exist on integer here. So, and as you can see here, when we deleted the upper, we get rid of an error. We even printed the numbers, which you will learn how to find that and fix that in next lectures. Because a function definition can have multiple parameters, a function call may need multiple arguments. So you can pass arguments to your functions in a number of ways. So you can use positional arguments, which need to be in the same order the parameters were written, keyword arguments where each argument consists of variable name and the value, and list and dictionaries of values. So let's look at each of these in turn. So let's start with the positional argument. So when you call a function, Python must match each argument in the function call, but the parameter in the function definition. So the simplest way to do this is based on the order of the arguments provided. So the values matched up this way are called positional arguments. To see how this works, let's create some code that displays information about courses, and the function tells us what kind of course, so course category is, and the course name. So here we will define describe or get course here, print course here, and we will, and actually instead of writing this, output or display, yes, display course here, we will enter course here. So as a first parameter, we're gonna use the course category or course topic, it's gonna more here. So course topic, and after that we will use comma here, and course name. That's it. And after that we will use double dot here, and here we will use the comments, which is display information about course here. And after that we will print using the format, so print here f and new line, of course, after that. So the course name, actually, instead of, let's add another parameter and named course duration, or yeah, course hours, yeah, course hours here. So first we will enter the course topic, and after that we will enter the course topic name, course topic, and again we will print the again format, and after that we will enter the here, and after that we will enter the course name here, and now we will enter course name again, and after that we will again add a new last print function. In this case it's course hours here. Course hours, and after that we will again add the course hours here. That's it. And after that, for example, we will enter the display course here, and course topic, for example, Python with Nikat here, and course name, the course topic is course here. We will in course name learn Python in short, learn Python fast and hard way by Nikat here, and after that we will add another here, course hours, which is 3 hours. Or actually, instead of writing this, let's make course hours integer here, and we will change this course hours and hours here. That's it. So we are taking 2 strings and 1 integer. That's it. Now let's explain this code here. So the definition shows this function needs a type of course. So when we call the display course, we need to provide an course topic and course name and course hours, right? In that order. So first we need to enter the course topic here according to this. Here, course. Actually, instead of writing this, so firstly we are entering the course topic, and then this is our course name, and after that we are entering the course hours, right? So for example, in this function call, the argument Python is assigned to course topic, and in the function body these 3 parameters are used to display information about the course, and we are describing the course here. Now what we're gonna do is here, for example, firstly we are entering the course topic which we are getting from here, and then we are entering the course name which we are getting from the second parameter and writing this, and then we are getting the course hours, which is an integer type, and here we are adding course hours here. Now let's try the output here. Let's see what this gonna show here. So actually let's add 2 spaces to match these up. And as you can see here, course topic is Python, course name is Learn Python Fast and Hard Way by Nihat here, and course hours is 3 hours here. So here, as you can see here, we are first adding the 3 here, and then we are adding hours as additional format here. That's it. So we can also add another variables or functions as well. So let's call another here, display course, car coolant, or actually let's use the Python or R programming here and learn R programming. Oops, of course it's going to be a string, learn R programming, or actually let's make different name, R programming master class by Nikat here. The course hours is going to be, for example, 10 hours, and after that we are going to show this again, and as you can see here we got this output here, course topic in Python. Here we are firstly printing Python, and then we are printing the R programming, course topic R programming, course name R programming masterclass by Nihat, and course hours is 10 hours. And as you can see, this is the how we shorted our course here with just adding a function into our code here. A keyword argument is a name value pair that you pass to a function. So you directly associate the name and the value within the argument. So when you pass the argument to the function, there's a new confusion and you won't end up with the, for example, course topic named course hours, right? So keyword arguments free you from having to worry about correctly ordering your arguments in the function call, and they clarify the role of each value in the function call. So now let's rewrite our program using this keyword arguments to call, for example, to call display course here. Now what we're gonna do is course hours here, as you can see here, and course here. And now we can also, when we call display course, right, so we will also mix these up here, right? So now we're gonna use course hours, or course hours here is gonna be 5, for example, and course name or course topic, we can also use course name, but this is just an explanatory here. Course topic is gonna be Python, and the course name is going to be mastering Python. And here, this is what, and as you can see here, we got the same result, but we mixed up the orders. So here the function display course hasn't changed, but when we call the function, we explicitly tell Python which parameter each argument should be matched with. So when Python reads the function call, it knows to assign the argument course topic to it knows to assign the variable Python to course topic, so mastering Python to course name. So however, if our order is changed here, so course hours goes to here, our course topic goes to here, and mastering Python, so which is course name, goes to here. So this is mixed up, but however we get the same result with the keyword arguments in Python. So the order of keyword arguments doesn't matter, because Python knows where each value should go. And here in the first here in the second display course call here we used the standard function call, but here we are using the display course which is keyword argument calling. So as I said, it's more clear way to call functions here. So we also have a default values in functions. So when writing a function, you can define a default value for each parameter. So if an argument for parameter is provided in the function call, Python uses the argument value. So if not, it uses the parameter's default value. So when you define a default value for a parameter, you can exclude the corresponding argument you'd usually write in the function call. So using default values, you can simplify your function calls and clarify the ways your functions are typically used. For example, if you notice that most of the calls of this display course are being used to describe courses, So you can set the default value of the course type to just online course, and now anyone calling the display course for a course online course can omit that information. And here what we're gonna do here is let's actually delete these lines. So here, so course topic is gonna be just an online course here. So sorry, and here we got an error, and no default parameter follows default here. No parameter follows default parameter. So here we got an error because if we are providing this, we need to also provide the default parameter for all of this. Course name unknown and course hours 0 here, for example, and as you can see we got rid of an error. Now here we got no problem showing this because we already provided this information for our function. But if we enter some values, for example, if we display course, we just know that this course name, we will do this. So course name here, Java course here, and after that we will not get an error because we already defined this if the default values for this. And here now let's run it here. Actually we did run it, and here course topic is online course. We added just a Java course here, and the course hours is 0 hours because we didn't provide it, and course topic is online course here, and as you can see here we did this here. So course hours is 0, course name is unknown, but when we enter the Java course, is this unknown here actually emitted here, and we entered the Java course here. And we didn't change or enter the course topic here, and that's why we got the default value, which is online course. So also the order of parameters in the function definition had to be changed because the default values makes it unnecessary to specify a type of course as an course topic as an argument. The only argument left in the function call is the course name here. So when we enter just a Java course here, we will not get an error here, but and as you can see here, we enter the course topic as Java course, but course name is unknown. So I hope you understand it, how this works, and how you should use default values in Python here. A function doesn't always have to display its output directly. Instead, it can process some data and return a value or set of values. So the value the function returns is called return value. So return statement takes a value from inside the function and sends it back to the line that called the function. So return values allow you to move much of your program's grunt work into functions, which can simplify the body of your program. So we will create a simple function that takes the model and make and year and returns a neatly formatted full car information, right? So here we will define get formatted car info here. Actually, if the function names can be descriptive, but I think this is a very long name, which you can also shorten it. For example, get car info, it's better now, right? And here we will get 3 parameters: the car maker, car model, and car year, right? So car year, that's it. And here we will add another command to return a full car info here, and after that we will create a car info here, and we will enter the format, of course, as we always do.
And firstly, we're gonna enter car maker, we will write car maker in uppercase, upper here. And after that, we will use the car model. With car model, we will use, let's use the title is okay for car model. And now we will enter the year. So we can also get the integer car year, but we can also get the string way. So yeah, I think it's gonna be better if we take car year as a string, as an integer, sorry, not a string. And now we will just print the car model. So here, oops, we did some error here actually. And after that, we will enter car model dot title, and after that we will enter the car year. So, and here your car model or car info here in uppercase, and we will enter new lines every time we start this line. And after that, return the car info. That's it. And here, yeah, return the car info without the parentheses here, because this is the variable and not function here. Car info is not function, this is variable. We created variable from these parameters. And here we will let's make it BMW here, and we will use the get car info. First we're gonna enter the car maker. Let's make it BMW, and car model 528 of we will enter it in strings 528e here, which e means here is injection. It's a gasoline here in most of my car manufacturers. And we're gonna enter also car year, for example 2016. And now we will print the BMW. That's it. And here, as you can see, car info BMW 528e, and the year is 2016. So we can also use, for example, in Volvo, so my Volvo here, and get car info Volvo S40, or yeah, S40 is okay. And 2008 here. We can also add another BMW car, or let's add Volkswagen now. Volkswagen car here, get car info, and Volkswagen, and Golf 7, and the year is 2014. That's it. And here, as you can see here, of course we need to print use again, print my Volvo here, my Volvo, and of course let's actually use this with formatting. My Volvo is best here, and after that we will enter the my Volvo variable and print Volkswagen car, and here we will add format Volkswagen is the best here. We can also, and after that we will enter this here, and that's it. And here, as you can see here, we are firstly we are printing car info, then my Volvo is best, and after that we are printing car info Volvo S40, Volkswagen is the best, car info Volkswagen Golf 7 2014. So here, however, when you consider working with a large program that needs to store many first and last names separately, functions like get formatted name or get car info becomes very useful. So you store first and last names, or car maker, car model, and car year separately, and then call this function whenever you want to display a full name or full car info. That's it with today's lectures. And here, let's try this again. And as you can see here, we are using return to get this information from here to here. And as you can see, we are firstly using get car info,
which here returns this, and then returns this, and then returns this. And after that we are printing this. In first we didn't use any variables to print in BMW, and after that we added format and entered my Volvo, and then Volkswagen is the best, and after that we are entered formatted info of Volkswagen car.
Object-oriented programming is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations. And you create objects based on these classes. So when you write a class, you define the general behavior that a whole category of objects can have. So when you create individual objects from the class, each object is automatically equipped with general behavior. So you can then give each object whatever unique traits you desire. And you will be amazed how well real-world situations can be modeled with object-oriented programming. So making an object from a class is called instantiation. And you work with instances of a class. So in this section you will write classes and create instances of these classes, and you will specify the kind of information that can be stored in instances, and you will define actions that can be taken with these instances. So you will also write classes that extend the functionality of existing classes. So similar classes can share common functionality, and you can do more with less code. So you will store your classes in modules and import classes written by other programmers into your program files. So learning about object-oriented programming will help you see the world as the programmer or coder does. So it will help you understand your programs, and not just what's happening line by line, code by code, but also bigger window here and bigger concepts behind it. So knowing the logic behind classes or object-oriented programming will treat you think logically, so you can write programs that effectively address almost any problem you encounter. So classes also make life easier for you and other programmers, and you will work with as you take increasingly complex challenges. So when you and other programs write code or programs based on the same kind of logic, you will be able to understand each other's work, and your programs will make sense to the people you work with, allowing everyone to accomplish more. So you can model almost anything using classes. Now we will write a simple class, which here we will create a car. That represents car, but not one car in particular, but any car. So what do we know about most cars? Well, they all have car makers, they all have models and years, and we also know that the most cars are automatic or manual, right? So use three pieces of information, which is car, model, make, and year, and those behaviors, which is automatic and manuals, will go in our car class because they are common to most cars. So this class will tell Python to make a new object representing a car. After our class is written, we will use it to make individual instances, so each of which represents one specific class. So now we're gonna create a car class. So each instance created from the car class will store a car model and make. This will be same variable and year, and we will give each car the ability to drive and stop. Or actually we can also add automatic and manual, but yeah, we will decide that here. So class car here, class car, and here we will add just a simple program that that written for cars, and here we will use init, but you will learn what init is. So init here, and we will add self name or car model make and model, car make and model, and after that we will enter the year, and after that we will here we are initializing initialize make and model year and let's actually add the gearbox also, right? Gearbox. So here we will add gearbox. So gearbox can also be automatic, manual. CVT is a different kind of gearbox, but it's still gearbox, right? But in this case, we will add just automatic and manual gearboxes in our cars. So we will also define a new but inside the car class. So here we have this indentation. So here we will define inside this car class the drive. Here we will use self, and that you will understand what these keywords are, and print if here self dot name. Oops, inside the braces here, self dot name or self dot make and model and is now driving. And also we will use make and model. Also we will add year, self dot year, and also we will add self dot gearbox is now driving, right? So for example, BMW 2015, BMW 528 E here, year 2015, and gearbox is automatic, is now driving, right? And after that we will add another here, another function, which is going to be, let's stop here, right? Let's stop driving, and here we will also add self. So here we will print here with format, and we will copy this. Actually, let's, instead of copying this, let's write this right now here. Self.car make and model year, and so gearbox is stopped. That's it. So now I will explain this one by one. So here, oh sorry, it will not return anything because we didn't use this class. We just defined it. We are not using that yet. But here, let's first explain it, and then let's create examples from it. So here, there's a lot of notice here, but don't worry. So you will see the structure through this course, through this section, and have lots of time to get used to it. So first, we define a class called, here we define, oh sorry. So we define a class, sorry, here. Let me actually use my marker. So here we define a class called car. So by convention, capitalized names refer to classes in Python. So there are no parentheses in the class definition here because we are creating this class from scratch. So we then write the doc string. So this doc string here describing here what class does. So actually, let me write this here, doc string. This is a doc string here, and so here we are here seeing init method. So here, oops, actually here
So a function that's part of a class is method. Everything you learned about function applies to methods as well. The only practical difference from now is the way we call methods. So the init method here, the init method you are seeing here, actually let me use different color. This init method here, let's make it bigger so you can see the characters. So this init method here is special method that Python runs automatically whenever we create a new instance based on the car class. So this method has two leading underscores and here two underscores and two trailing underscores. A convention that's helped prevent Python's default method names from conflicting with your method names. So make sure to use the two underscores on each side of init. So if you just use one each side, the method won't be called automatically when you use your class, which can result in errors that are difficult to identify. So here we define init method to have three parameters. No, actually 1, 2, 3, 4 parameters. The self, actually let me, yes, here, the self, make and model, year, and gearbox, right? So the self parameter is required in the method definition, and it must come first before the other parameters here. So this should be first, as I said. So it must be included in the definition because Python calls this method later to create instance of car, and the method call will automatically pass the self argument, and every method call associated with an instance automatically passes self, which is a reference to the instance itself. So it gives the individual instance access to the attributes and methods in the class. So when we make an instance of car, Python will call this init here method from the car class, and we will pass car a make and model, a year, and a gearbox as arguments. And self here is passed automatically, so we don't need to pass it. So whenever we want to make an instance from our car class, we will provide values for only the last parameters, which is make and model, year, and gearbox, and not self here. So the two variables are defined in the body of the init method. Each have the prefix self here, self, and self, actually not this here, self and self, right? So any variable prefixed with self is available to every method in the class, and we will also be able to access these variables through any instance created from the class. So the line self name here, the line self make and model here, actually let me write another code here. The self make and model, oops, actually let me we will write this here, self make and model equals make and model. Here we will get an error here, self make and model. We will do it inside this. So here, oops, actually let me delete this here. So here self, the line self make and model equals make and model takes the value associated with the parameter make and model and assigns to it the variable make and model, which is then attached to the instance being created. So the same process happens with the self, for example, year or gearbox equals gearbox, and the variables that are accessible through instances like this are called attributes. So the car class has two other methods, which is drive and stop driving. Because these methods doesn't need additional information to run, we just define them to have one parameter, which is self. So the instances we create later will have access to these methods. In other words, they will be able to drive and stop here. And for now, the drive and stop don't do much, and they simply print a message saying that our car model year, gearbox is stopped, or in drive here, make and model year gearbox is now driving. So but the concepts can be extended to realistic situations. So you can, for example, do it for a computer game or real world applications or so on, which you will learn in next lectures. Object-oriented programming is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations. And you create objects based on these classes. So when you write a class, you define the general behavior that a whole category of objects can have. So when you create individual objects from the class, each object is automatically equipped with general behavior. So you can then give each object whatever unique traits you desire. And you will be amazed how well real-world situations can be modeled with object-oriented programming. So making an object from a class is called instantiation. And you work with instances of a class. So in this section, you will write classes and create instances of these classes, and you will specify the kind of information that can be stored in instances, and you will define actions that can be taken with these instances. So you will also write classes that extend the functionality of existing classes. So similar classes can share common functionality, and you can do more with less code. So you will store your classes in modules and import classes written by other programmings into your program files. So learning about object-oriented programming will help you see the world as a programmer or coder does. So it will help you understand your programs, and not just what's happening line by line, code by code, but also bigger window here and bigger concepts behind it. So knowing the logic behind classes or object-oriented programming will treat you think logically, so you can write programs that effectively address almost any problem you encounter. So classes also make life easier for you and other programmers, and you will work with as you take increasingly complex challenges. So when you and other programs write code or programs based on the same kind of logic, you will be able to understand each other's work, and your programs will make sense to the people you work with, allowing everyone to accomplish more. So you can model almost anything using classes. Now we will write a simple class, which here we will create a car. That represents car, but not one car in particular, but any car. So what do we know about most cars? Well, they all have car makers, they all have models and years, and we also know that most cars are automatic or manual, right? So use three pieces of information, which is car, model, make, and year, and these behaviors, which is automatic and manuals, will go in our car class because they are common to most cars. So this class will tell Python to make a new object representing a car. After our class is written, we will use it to make individual instances, so each of which represents one specific class. So now we're going to create a car class. So each instance created from the car class will store a car model and make. This will be the same variable, and year, and we will give each car the ability to drive and stop. Or actually we can also add automatic and manual, but yeah, we will decide that here. So class car here, class car, and here we will add just a simple program that that written for cars, and here we will use init, but you will learn what init is. So init here, and we will add self name or car model make and model, car make and model,
and after that we will enter the year, and after that we will, here we are initializing initialize make and model year, and let's actually add the gearbox also, right? Gearbox. So here we will add gearbox. So gearbox can also be automatic, manual. CVT is a different kind of gearbox, but it's still gearbox, right? But in this case we will add just automatic and manual gearboxes in our cars. So we will also define a new, but inside the car class. So here we have this indentation. So here we will define inside this car class the drive. Here we will use self, and that you will understand what these keywords are, and print if here self dot name, oops, inside the braces here, self dot name or self dot make and model and is now driving. And also we will use make and model. Also we will add year, self dot year, and also we will add self dot gearbox is now driving, right? So for example, BMW 2015, BMW 528 E here, year 2015, and gearbox is automatic, is now driving, right? And after that we will add another here, another function, which is going to be, let's stop here, right? Let's stop driving, and here we will also add self. So here we will print here with format, and we will copy this. Actually, let's, instead of copying this, let's write this right now here, self dot car make and model year, and so gearbox is stopped. That's it. So now I will explain this one by one. So here, oh sorry, it will not return anything because we didn't use this class, we just defined it, we are not using that yet. But here let's first explain it, and then let's create examples from it. So here there's a lot of notice here, but don't worry. So you will see the structure through this course, through this section, and have lots of time to get used to it. So first we define a class called, here we define, oh sorry, so we define a class, sorry, here, let me actually use my marker. So here we define a class called car. So by convention, capitalized names refer to classes in Python. So there are no parentheses in the class definition here because we are creating this class from scratch. So we then write the doc string. So this doc string here describing here what class does. So actually let me write this here, doc string. This is a doc string here, and so here we are here seeing init method. So
here, oops, actually here. So a function that's part of a class is method. Everything you learned about function applies to methods as well. The only practical difference from now is the way we call methods. So the init method here, the init method you are seeing here, actually let me use different color. This init method here, let's make it bigger so you can see the characters. So this init method here is special method that Python runs automatically whenever we create a new instance based on the car class. So this method has two leading underscores and here two underscores and two trailing underscores. A convention that's helped prevent Python's default method names from conflicting with your method names. So make sure to use the two underscores on each side of init. So if you just use one each side, the method won't be called automatically when you use your class, which can result in errors that are difficult to identify. So here we define init method to have three parameters. No, actually 1, 2, 3, 4 parameters. The self, actually let me, yes, here, the self, make and model, year, and gearbox, right? So the self parameter is required in the method definition, and it must come first before the other parameters here. So this should be first, as I said. So it must be included in the definition because Python calls this method later to create instance of car, and the method call will automatically pass the self argument, and every method call associated with an instance automatically passes self, which is a reference to the instance itself. So it gives the individual instance access to the attributes and methods in the class. So when we make an instance of car, Python will call this init here method from the car class, and we will pass car a make and model, a year, and a gearbox as arguments. And self here is passed automatically, so we don't need to pass it. So whenever we want to make an instance from our car class, we will provide values for only the last parameters, which is make and model, year, and gearbox, and not self here. So the two variables are defined in the body of the init method. Each have the prefix self here, self, and self, actually not this here, self and self, right? So any variable prefixed with self is available to every method in the class, and we will also be able to access these variables through any instance created from the class. So the line self name here, the line self make and model here, actually let me write another code here. The self make and model, oops, actually let me we will write this here. Self make and model equals make and model here. We will get an error here. Here, self make and model. We will do it inside this. So here, oops, actually let me delete this here. So here, self, the line self make and model equals make and model takes the value associated with the parameter make and model and assigns to it the variable make and model, which is then attached to the instance being created. So the same process happens with the self, for example, year or gearbox equals gearbox, and the variables that are accessible through instances like this are called attributes. So the car class has two other methods, which is drive and stop driving. Because these methods doesn't need additional information to run, we just define them to have one parameter, which is self. So the instances we create later will have access to these methods. In other words, they will be able to drive and stop here. And for now, the drive and stop don't do much. And they simply print a message saying that our car model, year, gearbox is stopped, or in drive here, make and model, year, gearbox is now driving. So, but the concepts can be extended to realistic situations. So you can, for example, do it for a computer game or real world applications or so on, which you will learn in next lectures. Think of a class as a set of instructions for how to make an instance. So the car class is a set of instructions that tells Python how to make individual instances representing specific cars. So let's make an instance representing a specific car here. So under the here we will use without indentation here. We will use my BMW here and car here. Of course, BMW is car. And here we will add here. Actually, you can use Ctrl and P here. CTRL here and P to see the information or the functions you can provide. But here we are also seeing this, which is we need to provide the make and model. Actually, let me here in the first step we need to provide make and model, year, and gearbox. Here this is the same. So as you learned in previous lecture, we don't need to provide self as a parameter, so we will ignore it here. Make, first we are putting make and model, year, and gearbox. So in make and model we will write a string, of course. So BMW 325 E here, and year is gonna be 2002, and the gearbox is gonna be automatic. So that's it. And after that we will print the instance, which you here you will learn all of these codes, what these codes do and why are they doing this. So my cars make and model is here, and here we're my BMW dot make and model, and here print again format my cars car years of production, year of production is the my BMW dot year, is it right? Make and we have make and model, we have year, yes, we got an actually let's try this. Yes, we got an error here. Car object is now attribute year. So first we are entering BMW 310. Actually, instead we need to here. My BMW dot year. We have drive, stop driving, we have make and model. Of course, we need to make it like this. Self we forgot this here. Self year here. Self gearbox. Yeah, gearbox is gearbox. That's it. And here we will get here, and as you can see, this gearbox and year is appeared here. So first we're gonna print year. Let's run this here. And after that, we will also print the gearbox type. Print my car's gearbox type is, and here we will enter my BMW dot gearbox here. That's it. Now I will explain all of these codes, what these do, and here as you can see we have successful output here. So now we will explain all of this here. So the car class we are using here is the one we just wrote in the previous lecture. So here we tell Python to create a car whose name, my car here, my BMW here, whose car make and model is BMW 325e, and the car year of production is 2002, and the car gearbox is automatic. So when Python reads this line, it calls the init method in our car class with arguments, the make and model, year, and gearbox. In this case is, well, as I said, BMW 325e 2002, and automatic as gearbox here. And now then the init method creates instances representing this particular car and sets the name, sets the make and model, year, and other attributes using the values we provided. So we assign that instance to the variable my BMW. The naming convention is helpful here, so we can usually assume that capitalized names like cars refer to class, and lowercase like my BMW refers to a single instance created from a class. Hello, my name is Tayfun, and in this lecture we will try to change our MAC address on the Kali machine. So let's open up a terminal here with this Control-Alt-Tab shortcut here. And after that, actually we opened twice, right? No. Yes. So after that, we need to change the MAC address. So to change the MAC address, you will need to install the NetTools package, but in most Linux distributions this tool is already available. However, if it's not installed, you can install it using this command here, sudo apt-get update here. Enter your password here. It will take just the 5 or 10 seconds. After that, just install the apt-get install NetTools here. As you can see here, it's already installed. As I said, it comes pre-installed in most Linux distributions. However, you can check that or install that with this commands here. So it will prompt for your password when you install something with sudo. You enter your password, and once the tools have been installed, you can view the MAC address with ifconfig command. So here, if this command is not working, you can also use the sudo ifconfig. It will mostly work here without a problem. And here, if everything goes well, you will see this output similar to this, right? So there's a lot of information here, so let's break it down one by one. And I need to open the Gromit here so I can draw something on the screen, though it will be more explanatory here, right? And yes, apply, home, I think this, yeah, we can write like that. Home. Yes, sorry for that, we're gonna fix that here. So as I said, there's a lot of information here, and you will learn what these information means. So there are two values called ETH0 and low here. So these are the two separate adapters. So the ETH0 is the NIC, right? So whereas a LU here is the loopback adapter. For now, we can ignore the loopback adapter, and let's go with the init field here. So the init field, this is the first init field, represents the private local IP address of the Kali machine. So, and the init6 here obviously is the IP version 6 address of the Kali machine. And here our information is here, right? That we're gonna use in this lecture. The ether is the MAC address, and this is the field we want to change. And as you can see here, our MAC address is 000C 29 97 05
and 57. So we will change this MAC address here. So for now, we will go to, actually let me write, okay, delete that. So oops, there's something again, so the if config. So if you want to change the MAC address, you can't do so while our NIC is turned on. So first, you have to shut down the network interface. And to shut down the interface, you can use this sudo if, actually let me clear that firstly. So sudo if config eth0 down. That's it. So this command will shut down the NIC named eth0, as you can see, and as you can see here, we have the tab here which says the network connection has been disconnected. So we are disconnected and we turned our NIC down. So here, oh sorry, yes. So here, if you don't see an error while writing this command, this means that the command ran successfully. So now if you type the if config here, if config again, you will see this output here. So now this command here, as you can see here, we got nothing here. Not nothing. We are just seeing the loopback and not eth0 here. So this is the output we got here. Now you will only see the loopback adapter and that the eth0 is turned down. So to change the MAC address, you can run command here, this sudo if config eth0 hw ether here, and let's change our MAC address to 112233 AA BB CC here, and press enter. Oops, we got here, and as you can see, we got an error here because we need to use double dots and not this character with commas here. So we will do that here. That's it. Cannot assign the requested address here. Let's see what's wrong with that. 334455 here and 00 cannot assign requested address. So what we are doing wrong here is on MAC addresses, the first byte should be even. So here now we will change it to, for example, the first byte to 00 because in bytes, in decimal points, it's actually even. Here we are actually writing hexadecimal here. And as you can see here, we got no error here. So remember that when you're writing for a MAC address, your first byte should always be even. So if there's a no error like this, this means the command runs successfully. So at this point, we can turn on the interface again by running sudo if config. Oh, sorry. Sudo if config. Actually, let me clear that. Clear sudo if config eth0 up. And now let's run the if config command again to see if our changes on MAC address took place. So sudo if config. And as you can see here, that the MAC address of ours has been changed successfully. Now, if you want to scan something on a network, this MAC address will be shown instead of a real MAC address. So now, in next lecture, we will also create a Python script to change this MAC address automatically. So I'm waiting you next lecture. Hello, my name is Tayfun. In previous lectures, we have written manual commands to change our MAC. Ideally, we would like to write a Python script that will help us to change it. To do this, we need to find a way to run bash commands with the help of a Python. Luckily, Python has a standard library that is uses to run system commands called swap process. So this library allows you to interact with the underlying operating system. So to import this library into your model, you can simply write this command import sub process. That's it. So to run a command, the sub process has a method called run, and using this method you can execute system commands on your operating system. So if you want to see the information about eth0, you can run this command here, this code here. So sub process run. We're gonna, after that, inside the parentheses, we're gonna enter this curly braces here, and we will enter the if config, and after that we will enter the eth0 here. And after that we're gonna use this comma, and we will write shell equals true. That's it. And so let's run it. And as you can see here, we got the same output if it would written in this our terminal. So this function requires a list of commands. The other parameter, the shell true, means that we want to see the output printed to the console, and that's what it did here. So if you run this code, you will see an output similar to running the ifconfig eth0 command. And also keep in mind that you need to be a root user to run the command. So it should like, for example, so we need to go to PyCharm projects of our here and run this Python script. So cd, oh, let's actually clear first there, cd PyCharm projects here, and ls here. As you can see here, we are seeing our main.py here. And let's first see what is inside in our main.py. And here, this is the code that's written in our main.py here. Now we're gonna run this. So Python, of course, we need to, as I said, we need to use the sudo python 3 main.py. And that's it. As you can see here, we got the same output as we did in the previous ifconfig command without the Python here. So now that you know how to run system commands using Python, you can repeat preceding commands using Python. So now we're gonna firstly import the sub process. So of course we need to create a name, if name here. Actually, you learned what this name means, name main means in previous lectures. So if name main here, double underscore, and after that we will need to use this double dots here. So interface is gonna be eth0, and our new Mac. So new Mac, you can also ask from the user to enter a new Mac, but you can also written in Python code. So it depends on your needs, but in this case I don't need to get an input from the user because I will write this program. So in this case, for example, 00 111 11 22 33 55 and 11 here. Or for example, instead of writing these numbers, we can also do this here. So after that we will print here that, as you remember, we firstly needed to shut down the interface in order to change the MAC address. And now what we're gonna do is notify the user that we are shutting down the here. Of course, we need to use the formats here. Format shutting down the ETH, the interface dot uppercase. So we will notify that to the user that we are Actually, let me write it down and then explain. So you're shutting down the interface here and interface that upper here. So we will notify to the user that, oops, did we close the grommet here because I can't reach it? So next, toggle clear screen. Okay. So here we are seeing to the user that write the interface on the screen. So if our interface is ETH0, we will print the shutting down the interface ETH0 here, right? So this is how it will work. This is just a good practice to notify the user about what are we shutting down here. After that, we're gonna use the subprocess that run. Of course, as we notify the user that we are shutting down the interface, we need to shut down the interface. So after that, we will enter the curly braces here. If config here, of course, we will need to write in a string. If config here, and after that, we will again enter ETH0. Or instead of writing ETH0, we can also enter the interface, so it will be more practical. So if we need to change the ETH0 to, for example, wireless adapter, we will just need to change this WLAN 0, and it will affect all of the program here, right? So ETH0 interface, and after that we're gonna enter down. That's it. So let me actually see if my voice is written. Yes, perfect. And after that, what we're gonna do is we are print, actually, yeah, we don't need that. So we're gonna print like, let's write, let's changing your, or changing interface, or changing the, let's actually use the format so that we will notify that changing our interface. So we will interface is interface MAC address interface, to make it uppercase, to make it like shown up to the user. So changing interface MAC address to, actually MAC address to here. We will write our MAC address, and after that we will use our new MAC here. That's it. And after that we're gonna change. So since we shut down the interface, we need to change interface as we did in previous lecture. So now we're gonna do is subprocess that run, and here we will enter the braces again here. And now if config, so if config here, again we will enter the interface, and after that we will enter the HW, after that ether, and after that the new MAC. That's it. And after that we will again run subprocess dot run. So we will bring it back, we will make it so turn on the internet interface. So run here if config, and then we will enter the interface, and after that we will enter the up. That's it. So now after that, if there's no errors here, we will print that the network interface turn on. And here, that's it. So now let's run this program, and as you can see here, we are getting the operation is not permitted. Let's actually save it and run it on the here with sudo. And as you can see here, we changed our MAC address here. So now we first, actually, let me run it again. Clear. So let's run the if config here. Actually, let's change the MAC address here to 55, 21, 47, 29, and so on. So let it be here. And now we will enter the first, let's print the if config here. If config. And as you can see, this is our MAC address. This is old MAC address. Actually, let me write that, note that down here with Chrome. Okay.
let me, this is the new, this is the old MAC address, old, which is 00112245 and 24 and 67. That's it. So now here we will also add new MAC address, and we will see right now how the MAC address changes here. Let's clear again, config, and this is our, as you can see, this is the same MAC address, we didn't change it anything. So we will enter the sudo python 3 and main.py, and as you can see here, we changed our MAC address to 00. Actually, instead of writing this, and as you can see, we are notifying to the user that we change our MAC address, a new MAC address is this. And now let's check this out. And as you can see here, our new MAC address is 005521 47 29 47 29 and 67. That's it. And this is our new MAC address. So now that we have learned how to run commands on a system and how to change MAC address of a system using Python, we will stop our lecture here, and in next lecture we will look at the information gathering and different Linux hacking techniques here. So since we did this, that I will share this program with you, and you can modify, share, or if you have any problems, you can ask me directly here. So we will name it the MAC address changer. That's it, super hacker program name, and I will share this program with you. So in this lecture, we learned the basics of networking and how we can protect ourselves on a local network by spoofing our MAC address for scanning purposes. And this lecture helped us to get a deeper insight into the networking aspects of the computer system, as well as how we can use Python to protect and mask our identity in a local network. So in next lectures, you will learn more about networking and Python hacking here. So I'm waiting you in next lecture. Hello, my name is Tayfun, and in this lecture, we will create a simple scanner to scan hosts in our local network and find their MAC addresses. In order to create the scanner, we need to first understand what address resolution protocol is and how it can be used for creating a network scanner. So, address resolution protocol in its simplest form is a translation tool that helps us to translate IP addresses into MAC addresses. So whenever a device needs to communicate with the device within the same network, same local network, it needs the device MAC address. So let's say for example, let me actually open my diagram here to see, so we're more detailed here. So here. So let's say the Tayfun's device wants to communicate with Johnny's device in a local network. So in order to find the MAC address of Johnny's device, Tayfun's device will first look inside the internal list maintained by it, called the ARP list here. So for example, every computer has this kind of list here. For example, this IP and MAC address. For example, this IP has this MAC address, this IP has this, IP2 and MAC2, or IP this here and MAC this. So most computers, or networks, we have those kind of lists that stores
the ARP list. So now, in order to find the MAC address of Johnny's device, the Typhoon's device, as I said, will first look inside an internal list maintained by it called the ARP cache. ARP cache. It's also called ARP list in some. So it will check it, the ARP cache, to see whether Johnny's device IP addresses are mapped to a physical MAC address inside its table. So this is called ARP list, ARP table as well. So you can check the ARP table on your PC by typing this command here. So let me go back to Linux here and here. So you can check the ARP list by using this ARP, and A. That's it. So here you can see that it lists out the IP addresses corresponding MAC addresses associated with them. So you can use the same command in Windows as well. So if the corresponding MAC address of the requested device is not present locally here, so as you can see here, we are not seeing the another IP address other than ours, in this case in Typhoon's device. So this Typhoon's device will send out a broadcast request to the whole network to ask which device has this respective IP address. Here, actually, let me get my pen here and draw some things on the screen. So here, as I said, Typhoon's device will ask to all of the devices to ask this if they have the IP addresses. Actually, the Typhoon's device not ask that like that. Instead, it is here. Instead, Typhoon's device will ask the router to ask this IP address here. In this case, router is gonna find the Johnny's device, and after that, Johnny's device will send a signal back. So in our case, since we are asking who has this IP address, in this case is Johnny's device. So these devices that are not Johnny's device will ignore this request, while the Johnny's device will give out a reply with the corresponding MAC address here, right? So here, this way, the Typhoon's device will get to know the MAC address of the Johnny's device. So once the both devices get to know each other, the communication between them can follow. So once the Typhoon's device gets the MAC address of Johnny's device, it will update the ARP table and it will write, for example, Johnny's device has this IP and this MAC, right? And after that, they will be like friends, right? And that's it. So here in this illustration, you've seen how this works here. And now that we understand how ARP works, we can start working on creating our own ARP scanner with Scapy to find out the MAC addresses of these devices. So you might be wondering why we need an ARP scanner. Well, knowing the MAC addresses of a device can help us to perform man-in-the-middle attack. So as known, MITM here. So MITM, man-in-middle attack, which we will perform in next lectures. So I'm waiting you in next lecture to write that program. Hello, my name is Typhoon, and in this lecture we will create a ARP scanner, address resolution protocol scanner, using Scapy. So the address resolution protocol works on the Ethernet layer. So using Scapy, we will firstly import the Ethernet layer here. So now let's open the PyCharm or IDE, and now we will firstly write the import the statements. So here. So in previous versions of Scapy, you can import the Ether, ARP, Ether, ARP, and SRP libraries like that. But in this updated version of Scapy, you can't import. Instead, you will do this here. Import firstly, and you will get that Ether libraries from import from Scapy layers, and after that, you inside the Scapy layers you will import Ether and ARP from that, and layers L2, and you will enter Ether from that, also from Scapy.layers L2, import also ARP from L2 here, but the S for SRP you will write this Scapy layers recipe here, or I think it might be the send recipe here, send recipe or send recipe here, and we will import SRP from the send recipe library. So now so we imported the layers. So if all the bits of MAC addresses are set to 1, this means that packets is broadcast and it should go to every device in the network. So Scapy uses hexadecimal representation, so we will create this broadcast variable to denote the broadcast address. So here broadcast, and we will use set all the variables to 1, ff, and ff. That's it. So then we can create an Ethernet layer packet and put the destination as a broadcast, right? So we will also need to define the IP range we want to scan. In my case, let's actually find what our IP config is and what broadcast IP is. And it's actually clear that if config, and as you can see here, our net mask is this, our init address is this, and our broadcast address is this. So in this case, we will scan from 192.168.13 from 0, and from 192.168.13 to 255, right? So now what we're gonna do is we will write IP range here, and after that we will write, oops, not this here, 192.168.13. so 192.1, oops, instead we will use the strings 192.168.13 and 1, and we will do slash here 24. So this 24 means that we want to scan from last digit 0 to 255. You also learn, you can actually, I think you learned this in previous lectures here, TCP/IP lectures. So, but I will explain this again. So this represents that we want to scan all the devices starting with IP address 192.168.13.1 up to 192.168.13.255. So the last 8 bits are called the bit mask and represents the number of hosts we want to scan. So remember that an IP address is 32 bits, and we say here that we want to mask 24 bits. So the remaining 8 bits are addressable only. So which means that we are only scanning the last 256 hosts in the network. So now to create the ARP layer packets, we will use the ARP, my ARP layer, and ARP, we will use this ARP library that we imported from the escape layers L2 packet. And now ARP, we will enter the PDST equals IP range. So that's it. So now that we have created two layers, Ether and ARP, next we will create a packet with both of these layers. So we will packet the equals Ether layer here and ARP layer. And we also quickly need to create the Ether layer here. It's so easy. We'll just Ether layer, and after that we will enter the Ether, and inside this parenthesis we will enter the destination DST as our broadcast, right? So we will get this broadcast inside this Ether layer. That's it. So after that, what we're gonna do is, so what we're gonna do is now we will send this packet as a broadcast. To do this, we need to SRP function. So ANS here, we will use the ANS and UNANS. Here, as we will use SRP, we will enter the packet. The interface is going to be, in this case, let's say the ETH0, because we will use ETH0 here. And timeout is gonna 2, I think. Yeah, 2 is okay. So packet here is the name of a packet we want to send, and ePhase is the network interface card NIC we want to use to send this packet. And the timeout, as you can see, it is to make sure that if we don't get a reply in 2 seconds, this means that device is most probably offline. So SRP returns both answered and unanswered packets. So we are interested in answered packets from online devices only. So now to get the IP addresses and MAC addresses of the online devices, we can write the for loop. So we can iterate over the answer to see the IP and corresponding MAC addresses. So for SND and RCV in ANS here, and we will create a new IP. So let's use this. So we will create a new IP. This will take, actually, let me see if it's recording. Yes. So IP here, we will create a new variable IP, and we'll take the RCV parenthesis ARP here, and PSRC. That's it. And after that, we will also use the MAC address here. So RCV as well. In this case, we will use the Ether and SRC. And after that, we will print the online, or first we will write the IP. This actually, let's use the format here. So IP, we will use the IP. So as you can see here, with receiving ARP.PSRC, we got the IP address from the receiving array, and also we got the MAC address from the RCV with saying Ether here. So now what we're gonna do is, after that, we will use the new line, or we can also use tab. So it will be here. And after that, we will use MAC. Actually, let's use the 2 tab. So MAC address is gonna be MAC. That's it. So here the RCV represents the packets that have been received by the sender. So to get the IP address, we can use the ARP layer, and to get the MAC address, we can use the Ether layer. So remember, the fields set in the packets correspond to the respective layer. So the complete code will look like this here, and let's run this. Check this, and as you can see, we got an error here in line 12. So what's the problem here? So the permission error. So as you can see, we need to run it with sudo here. So we will go to this, so it will nice terminal look, and we will cd to PyCharm projects to the phone ls, and as you can see, this is our program. So now what we're gonna do is main python sudo here, of course, sudo python 3 main.py and call it. And as you can see here, we got these packets here. So as you can see, we received 7 packets and got 3 answers, remaining 253 packets. And as you can see here, now you can see the MAC and IP addresses of all the devices available in the network. And let me if config, and let's see what our MAC address is here. So actually, we can also let's get a new Windows machine onto our network and see if this program of ours will show that newly added Windows machine to it. So let's turn on the Windows machine on virtual machine here, and we'll get back in 2 seconds. And here I added my Windows machine to the same network, and now let's check this out. And as you can see here, we added the new MAC address and new IP address and MAC address to the output. And here, let's see if this is the MAC address of our Windows machine. And here, as you can see it, we have the same IP address on our target machine. And here, let's see on the Linux side. Oops, sorry, not like this. On here, and as you can see here, it's the same address here. So we successfully wrote our program here. You can see that all the results obtained in our scan match these values. So you can take a look at these values, or you can add new devices. You can also if there's 100 devices on your local network, you can scan all of these devices according to their MAC addresses, IP addresses. So here, also keep in mind that there was some additional report here. Let's actually use that now. So now let's go to our Kali machine. So here you might see this weird 254 IP address. So here, this represents this here MAC address, and this here represents the DHCP server. So DHCP server assigns IP addresses to the devices in a network when the devices are configured to automatic IP assignment. So, and also this represents the default gateway in the network. So in this section, we learned how data is sent from one device to another over the network. We learned about how data is encapsulated in the TCP/IP protocol and what fields are added to each header. Next, we learned about a very important network manipulation and packet crafting tool called SCAPI here. And we also learned how to craft packets using SCAPI and how these packets can send over the network. So we then learned about address resolution protocol, and finally we created an ARP scanner to get our internet protocol addresses and MAC addresses of live devices in our network. We also added Windows device. We've seen the IP and MAC addresses match, and
in next lectures we will do more awesome and fantastic practical topics like this. So I'm waiting you in next lecture. Hello, my name is Stefan. Welcome to our Nmap lecture. In this lecture, we will dive into the exciting world of network reconnaissance. So today we will explore a crucial task for penetration testers and system administrators, like finding online hosts. So we will discover how Nmap, the go-to tool for network scanning, offers enhanced host detection capabilities and provides valuable insights beyond the traditional ping utilities. Segment 1. The importance of host discovery. Before we begin our exploration of Nmap's capabilities, let's understand why finding online hosts is such a fundamental task. In today's interconnected world, where networks span vast geographic areas on the internet links countless devices, being able to identify active machines within a network or on the internet is crucial. Penetration testers rely on host discovery to identify potential entry points and vulnerabilities, while system administrators use it to monitor network health and ensure the smooth operation of their systems. Segment 2. The Nmap ping scan. So Nmap's ping scan feature takes host detection to the next level by sending a series of probes. So the Nmap goes beyond the ECMP echo request commonly used by traditional ping utilities like ping here. For example, ping, let's ping to ourselves here on our machine. And as you can see, this is just a ping, right? So Nmap goes beyond this echo request commonly used like this. So this comprehensive approach increases the accuracy and reliability of host detection, allowing us to gather valuable information about the online entities within a target network. So segment 3. We can execute a ping scan to launch a ping scan with an Nmap. So we will utilize this command here. So this code here. So Nmap SN, and here we will enter our target, right? So the SN here option instructs Nmap to disable port scanning and focus solely on the host discovery phase. It's worth noting that the Nmap supports a wide range of target specifications, including IP version 4, IP version 6, addresses, host names, and network ranges defined using the wildcards and CIDR notations. So for example, to scan the local network, we will first need to learn what is our local network IP starts with here, and now we will use this Nmap SN here 192.168.0.13.1 and 24 here. So, and as you can see, now we are scanning our host. So segment 4, analyzing the results. So once the ping scan is complete, Nmap provides us with a comprehensive list of hosts that responded to its probing packets. So these active machines represent the online entities within the target network segment or the internet. So by examining the results, we can gain insights into the network composition, identifying potential bottlenecks or misconfigurations, and further refine our understanding of the target environment. Segment 5. Uncovering additional details. Nmap's ping scans offer more than just a host discovery. So when executed with sufficient privileges on local Ethernet networks, Nmap can also identify MAC addresses and associated vendors based on MAC address identifiers. This additional information allows us to gain insight into the devices present on the network, aiding in network inventory management and security assessments. So in order to do that, we will just add sudo before Nmap to run it with sudo privileges, and here you will see also the MAC addresses right here. Segment 6. Under the hood. How Nmap works to understand the mechanics behind the Nmap's ping. This ping scans here. So let's delve into the inner workings of this powerful tool, this SN option, as mentioned earlier, disables port scanning and focuses solely on the host discovery phase. Depending on the user's privileges, Nmap utilizes various techniques to determine the online status of a host. So when executed as privileged users here, so Nmap employs a combination of techniques. So it sends TCP sync a packet to the port 443 and TCP acknowledge. So TCP ACK packet to the port 80 and ICMP echo and timestamp request. So this diverse probe helps to ensure that even hosts with restrictive fileware rules can be detected. So if the user running Nmap doesn't have the capability to send raw packets, it employs the connect system call to send the SYN packets on ports 80 and port 443. Segment 7. Exploring local Ethernet networks. When scanning local Ethernet networks as privileged users, Nmap activates ARP neighbor discovery, so further enhancing host detection capabilities. So by leveraging ARP request, Nmap can identify MAC addresses and associated vendors, and this information becomes invaluable in understanding the composition of the network and identifying the types of devices connected. So in conclusion, Nmap revolutionizes the way we discover online hosts with its robust ping scan capabilities, and by leveraging Nmap's extensive probing techniques and privileged user functionalities, penetration testers and system administrators can gain a comprehensive understanding of their networks. Remember, host discovery is the first step towards a secure and efficient system. So go ahead, unleash the power of Nmap and embark your network reconnaissance journey. Hello, my name is Tayfun, and in this lecture we will explore the fascinating world of a network reconnaissance. So Nmap is renowned for its extensive range of host and port discovery techniques, allowing penetration testers and system administrators to gather critical information about their networks. By utilizing these techniques, we can effectively scan hosts even in the most restricted environments. So let's explore some of the key techniques employed by Nmap for host discovery. We can also trace routes with Nmap. So tracing routes with Nmap from the scanning machine to the target host can provide valuable insight into the network topology. Nmap enables us to include trace route information during our scans. So for example, now we will enter the Nmap SN, we will add the trace route option. So by using this option, we can trace the path taken by packets from our machine to the target host. Let's do this example here. So Nmap trace route, and here we will enter some website. In this case, it's going to be, for example, CodeSally. This is our application, our website, which we installed for penetration testing in this course here. And as you can see here, trace route has to be run as a root, and we will use this sudo here, and after that, and as you can see here, this is our trace route. So this command initiates a ping scan with a trace route enabled for both the CodeSally and our host machine. So we can also add another here, for example, google.com, and here that's it. So we are allowing us to visualize the network path and identify potential bottlenecks or routing UGs here. As you can see, we don't have any UG on routing here. So segment 3, leveraging NSA scripts during host discovery. Nmap's scripting capabilities through the Nmap scripting engine NSE here provide a powerful way to gather additional information about a target during the host discovery phase. By executing the Nmap scripting engine scripts, we can extract valuable insights about the target's services, vulnerabilities, or even perform specific tasks. To execute
nmap scripting engine script without conducting a port scanning, we can use the SN option to skip port scanning and specify the desired script using the script option. So here what we're gonna do is nmap script here, and we will use the DNS root as a nmap scripting engine. So DNS root here, and after that we will enter our target domain or IP address. So in this case it's going to be codesally here.com, and here we will wait the execution here. Let's actually run with the sudo privileges. And here, as you can see here, we got no target specified, and so 0 host scanned. And here, if you are getting this error, you can also use the alternative script for this here. So instead of writing DNS root here, you can also write the DNS nsec here and enum, and after that you enter your domain or IP address. So here, this is an alternative, and this script performs a DNS enumeration by querying for NSEC records, which can provide valuable information about the domain. And here now we will get an output here. And also keep in mind that the success of this command depends on the availability of this DNS nsec enum script on your network configuration, and you may need to install additional nmap scripting engine scripts or adjust the command according to your specific environment. So if you need any assistance, if you encounter any errors, feel free to ask me on the question sections of our course. And as you can see here, we got a lot of information here. We got ports and this here. So here in this command, we are executing this DNS nsec enum script during host discovery, which attempts to brute force DNS records for the codesally.com domain. This can reveal hidden subdomains, but also provide valuable information here, and as you can see, open ports and so on. So we can also use the SN here before the script here, and let's see how the port will change. And as you can see here, this is now we are not scanning port, since this parameter will not scan port here. And here we are sending this host record server here, and as you can see here, our hosting for this domain contains this domain address here, and this is the IP address of this. And one interesting nmap scripting engine script available in nmap is broadcast ping script, which utilizes a broadcast ping request to identify online host within a network. By broadcasting a ping message, nmap can detect hosts that respond even if they have a restrictive firewall rules. And to use this script, we specify it with this script option as we did earlier, along with the desired target range. So we will do nmap sn here, script again with q here, script, and after that we will enter the broadcast ping and 192.168. Let's actually see our if config IP local IP address 13.138 13.1 here, and after that we will enter the 24, and here nmap sn. So we need to, let's actually, oops, we had the error with this typo here, broadcast, and that's it. And as you can see, it's not running for lack of privileges, so we need to run it with sudo here, root privileges here. And now you will see an output. And here, so with this command, we are scanning the local network with the IP range of this 1/24, which we will scan this IP address from 0 to 256 here using this broadcast ping. And here, this can be particularly useful in scenarios where a host might not respond to traditional ping requests here. So, in conclusion, Nmap discovery capabilities provide a powerful arsenal for network reconnaissance by understanding the leverage techniques such as traceroute, NSA, Nmap scripting, engine scripting, and specialized scripts like broadcast ping. We can gain comprehensive insights into network environments, identify active hosts, and uncover potential vulnerabilities. So equip yourself with the knowledge of Nmap's host discovery features and embark on your network reconnaissance journey with confidence. Hello, my name is Stefan, and in this lecture you will learn how to discover open ports with Nmap. In the realm of network reconnaissance, one of the most valuable tasks is to determine the port states of a target. This process is commonly known as port scanning. So Nmap, the versatile network scanning tool, excels at this task. So providing valuable insights into the running services on a target. So in this segment, we will explore essential Nmap options related to port scanning and learn how to effectively list open ports on a target. Segment 1. Launching the default scan. To initiate a default scan with Nmap, all you need to is the target information, which can be an IP address, host name, or even a network range. So let's take a look at this example here. So nmap codesally.com. So here, this command will initiate a scan on the target host codesally.com and provide detailed information about the open ports and their corresponding services. And here it is, the output here. And as you can see, not shown 988 filtered TCP ports and so on. So you will also learn what is here. So in segment 2, which in segment 2. So you will understand the scan results here. So the scan results generated by Nmap offer a crucial information about the target host. Let me actually open the Gromit here, and I will draw things on the screen to explain this better. So here we have, alongside with the IPv4 and IPv6 addresses, reverse DNS names, and latency details, the results highlight the ports and their respective states. And the port states are categorized like this here. So in the first here, we have open ports. This here in open, here as you can see, all of these ports are open here. So with this, we are indicating, so Nmap indicates that the service is actively listening for connections on the port open here. And also we have the closed. With this here, Nmap indicates to us that the probes were received, but no service was detected on the port. And we also have the filtered. So this indicates that the probe's reception couldn't be determined, possibly due to the filtering mechanisms. And we also have unfiltered. So with this here, Nmap indicates us that the probes were received, but the state couldn't be established. And we also have open filtered here. This means that indicates that the port appears to be either open or filtered, but the state couldn't be determined. And we also have the closed filtered here, which indicates that the port appears to be either closed or filtered, but the state couldn't be determined. And here we will also learn
how to customize Nmap scans. So while the default scan provides a valuable information, Nmap offers a plethora of customization options. So for instance, you can specify alternative DNS server using the DNS servers option like this, DNS servers option to control DNS resolution during the scan. For example, this Nmap DNS servers here, and we will enter the Google DNS here, 1888 here, and after that comma we will type, and 8.8.9 4.4 here, and now we will do codesally.com. So by providing this DNS server, Nmap will utilize these servers for hostname resolution. And here furthermore, Nmap performs host discovery to determine if the target is online before conducting port scanning, and you can skip the host discovery step using the PN option here. After Nmap PN, uppercase P and the lowercase n here, and here you will see another result. It might take here, actually let me use the sudo here, sudo enter password, that's it. And here this command will directly initiate port scanning without prior host discovery with uppercase P and lowercase n options here. And here Nmap employs various scan techniques depending on the user's privileges, and the default scan can utilize a synchronized SEN stealth scan or TCP connect scan here. So these techniques ensure comprehensive port scanning while considering the user's privileges and network environment. So port scanning with Nmap unravels the network services running on a target, enabling us to gain insights into potential vulnerabilities and secure our networks. By understanding the scan results customizing the Nmap scans and being aware of the underlying scan techniques, we can effectively explore open ports and their associated services here. And as you can see, we are seeing services FTP, SMTP, RSFTP, domain, HTTP, POP3, EMAP, and so on. So equip yourself with Nmap's port scanning progress and unlock the secrets hidden within your network. Welcome back, fellow network explorers. My name is Tayfun, and in this lecture we will delve into the fascinating world of Nmap port scanning. We will delve into advanced techniques that will help you uncover valuable information about target systems and services. So grab your virtual magnifying glass as we embark on this Nmap journey together. So Nmap offers a variety of port scanning techniques that cater to different scenarios. Understanding these techniques will empower you to choose the most appropriate method for your scanning needs. So by default, the privileged users enjoy the benefits of a SEN stealth attack, synchronizing stealth attack. So this technique utilizes raw packets to detect port states using a technique known as half open. So on the other hand, unprivileged users who lack the ability to create any raw packets rely on the TCP scan technique. So TCP connect scan technique actually. So this method completes each TCP connection fully, making it slower compared to SEN synchronizing stealth scans. So fine-tuning our Nmap scans to focus on specific port ranges is a valuable skill. It allows us to narrow down our search and optimize performance, especially when dealing with multiple targets. So you can specify port ranges in various ways using Nmap P option here. So for example, you can use comma separated lists to scan multiple ports like 80 and 443. Like this here, Nmap P here, and 80 443, and here we will enter the codesily.com, and here we are now scanning only port 80 and port
443, and as you can see here, they are open at service. Port 80 uses on the service called HTTPA, and here for port 443 uses HTTPS, and they both open. Alternatively, you can define range using hyphens here. So for example, such as you can write like P here, and 1 to 100. And here we are telling Nmap to scan ports from 1 to 100 on codesolid.com, and as you can see here, Nmap showed us the open ports on the specific domain address. Nmap also provides the flexibility to target specific ports by protocol. For instance, you can scan TCP port 25 and UDP port 53 on a target using this command here, again P here, and without space after P we enter the T here 25 and U here 53, and here you will enter the target domain or IP address. In this case it's domain here, codesolid.com, and here let's press enter. And as you can see here, your port specifications are illegal example of proper port here. So we did something wrong here, and here after that, oh sorry, we need to add 2 dots here. Yes, that's it. And here your ports include U, but you don't have specified UDP scan with SU here. So you can also scan with this, but in this case we just scan the TCP here and here. And as you can see, it's filtered and it's a SMTP here. SMTP server is actually used for emails and email communication. So here, additionally, you can focus on ports associated with specific services using service names such as nmap p here, and after p, let me clear that. So nmap p here, nmap p, and after p you can enter with space here. So nmap p smtp here, and you will enter domain name or IP address here, codesolid.com, and now we have a segmentation fault here. Let's actually use with sudo here, enter password, and as you can see here, we got segmentation fault again. This fault is actually a bug on the nmaps this version here, so I think they will fix that in next versions. But here you can also fix that by uninstalling the purging and then installing nmap again, which we will do in next lectures, how to fix that fault here. So here now nmap here also provides the flexibility to use the active network interface in order to, however, there may be instances when it fails to do so, or when you need to select a specific interface for network testing purposes. So to ensure nmap scans using the desired network interface, for example, let's see what is our network interface. In this case, it's the ETH0. So here, to ensure nmap scans using the desired network interface, you can use the E argument followed by the interface name. For example, in order to do that, you will enter the nmap here, E here, argument, and after that you will enter the ETH0 in my case, and here, and after that you will enter the code target name, and here in this case our nmap, this code here forces nmap to use the ETH0 for the scan. And here, as you can see here, you can, oh sorry, so you can also use the press T to debugging, or you can use the arrow case to show the process here. And here, as you can see here, it's still using that. So it might take some time here. I know it's actually halfway down here, etc. 59% here. And here our scan is complete with this preferred interface here. So, and as you can see here, we ensure that we are now using the ETH0 for Nmap interface for the scannings here. And congratulations, you learned some advanced techniques for port scanning with Nmap by understanding the differences between privileged and unprivileged scans, and scanning specific port ranges, and selecting the ideal network interface at the end. And you are now equipped to conduct precise and efficient network reconnaissance. So remember, responsible scanning is essential. Always ensure you have a proper authorizations and adhere to ethical guidelines when performing security assessments. And so go forth, explore the depths of your network, and uncover the hidden treasures that await with Nmap. And I'm waiting you in the next lecture. Welcome back, security enthusiasts. In this lecture, we will explore the powerful target specification options provided by Nmap. Understanding different target formats and scanning techniques will enable you to effectively scan IP addresses and host ranges. So let's dive into the world of Nmap target specification. First thing we're going to learn is multiple host specification. The simplest way to specify a target is by directly listing the IP addresses or hosts you want to scan. You can specify multiple hosts by separating them with spaces. For example, nmap let's codesally.com, and after that you can also enter the local IP address. Let me actually look at my local IP address. Config here, IP config, and here 13.138, 13.138, and so on. So here, this command will scan the IP addresses of Kotsali or domain here, and this local IP address here. And here, we can also have octet range addressing and wildcards. So to simplify the specifying a range of hosts, you can use octet range addressing. It allows you to specify a range of IP addresses by using a hyphen between the starting and ending addresses. For instance, to scan host of, for example, this here, let's actually delete the domain for now. We will use on the local host of this here. So to scan the host of this here, 192.168.13.1 and 192.168.13.3 here, and as you can see, we will scan this, right? So you can, instead of this, you can use, for example, this IP address here, the only this IP address, and after that you will enter the 168.13.1 here, and after that ternary operator here, the minus operator, and here you will enter the IP address you want to range from. So if you want to scan the IP addresses from 1 to 20, you can use this like this here. And now in this case, octet range intuition also support wildcards. Keep in mind, enabling you to scan from 0 to 255 with the expression like this here. And here, this is especially useful when you want to scan a subnet with large number of hosts. And you can also exclude hosts from the scan here. Let's actually clear that. So sometimes you might need to exclude specific hosts from your scan, and Nmap provides the exclude option for this purpose. It allows you to exclude one or more hosts from the range being scanned. So here's an example here. Nmap 192.168.1.1 to 255 here, and we will use the exclude here with 2 minus operator, exclude, and 192.168.1 point, for example, or oops, actually our IP address is 13 and not 1, 13 oops, sorry, here 13 point, for example, let's exclude 13.3, right? And here with this command we are excluding the 13.3 from the range of this host being scanned. Alternatively, you can create an exclusion list in a file using the exclude file option to simply list the IP addresses or host you want to exclude in the file, each separated by a new line. For example, let's actually create a new file in graphical user interface here, create document and my exclude list.txt here, and after that you will open that. So of course we need to use it some notepad here. Ouch. Or mousepad, I think. Here, mousepad. This is a text weaving program in Kali Linux. Here. So now, what we are going to do is we will write the IP addresses we want to exclude here. And here, so we will save this, and after that what we are going to do is nmap exclude file here, and after that you will enter the file path. You can also enter the file path using this home here, Kali, and exclude list.txt, and after that you will enter your IP address range you want to scan, in this case from 1 to 255. Oh, sorry. Exclude file, unrecognized option, exclude file here. Let's actually try it without this here, and exclude file again, error here. So if you're getting this error, you're probably using the newer versions of this nmap here. So in order to fix that, we will use some grep and here. So however, you can achieve a similar result by using a combination of other tools and commands. And as I said, one approach is to use grep command to filter out the IP addresses or hosts you want to exclude, and then pass the filtered list to nmap. So let's actually clear here. So we will first, as you remember, we have created the file exclude list.txt. So let's actually read it. Cat exclude list.txt, and here this is our excluded, this is the IP address that we want to exclude from our scan, and we will using the grep command to exclude the IP addresses or hosts from the list you want to scan. So you can use the v here. Let me actually do it again. Nmap v option to invert the match and select non-matching lines. So here nmap f here, and here we will exclude list.txt, and here we have all hosts.txt, and after that we will enter the filtered.txt here, and here we will use the sudo again. If you are getting this kind of errors, probably the sudo will fix it. No targets were specified, and here failed to resolve exclude list.txt and all hosts.txt here. And here we need to create the all hosts.txt in this case, and in order to do that we will use the sec here f192 here with the quote here 192.168.13.g here, and we will unquote it. So from 1 to 255 here we will use this pipe aw key here, and here we will print it one by one, print 0 here, and after that we will uncode it and we will write it to all hosts.txt here. And now let's cat the all hosts.txt to see what's inside. And as you can see here, this is all the hosts from 1 to 255. So what we're going to do is we will run this command again, nmap command, and as you can see we got the error again, all hosts.txt, when no targets were specified. And here, so here we have the two files, all hosts.txt and exclude list, and we have the filter.txt here, and here this is our output. So here we also have the exclude list.txt and all hosts.txt. And here, sorry for the confusion here, instead of using nmap we need to use the grep here. So what we're gonna do is we will change the nmap to grep here, grep, and here that's it. And now let's open the filter.txt. Actually we can use the we can open the filter.txt with cat here, and as you can see here we have excluded the IP addresses from our list, and 20, 21, 22 and 23 it doesn't exist because it already existed in filter. So this is a filtered list that all the ports that we want to scan. So we have subtracted exclude list from all hosts here. So let's actually watch the exclude list here, and as you can see we don't have the 23 here, 22 here, and we will also don't have the 112 here, and as you can see here we don't also have the 112 here, and so on. So what we're gonna do is here, and now we will use the nmap to scan all of this. Nmap lowercase e here and uppercase L here, and we will pass the filtered list to nmap for scanning, and we will enter the filter.txt, and here nmap is scans that. And keep in mind that this method assumes you have a list of all the IP addresses or hosts you want to scan initially, and a separate list of IP addresses or hosts you want to exclude. Adjust the commands accordingly to suit your specific requirements, and please keep in mind that the availability of certain features or options in software tools may be changed since the 2023. So this is the last version and updated version of this course, and it's always good idea to you can also watch the documentation and official sources to make this nmap to more usable, and keep an eye onto the updates. And we can also use this CEDR notation for targets. So CEDR notation, and as actually this CEDR here also pronounced as the CIDR. So this notation provides a compact method for specifying IP addresses and their routing suffixes. It also it allows for more granular subnet masks compared to classful addressing. And CIDR notation consists of an IP address followed by a / and a network prefix length. The network prefix length represents the number of network bits, and for example in CIDR notation, actually let me open the grommet here to write marker here. So here the CIDR notation 24 after the IP address, this means the subnet mask of 255.0, indicating that the first 24 bits of the IP address are the network portion, and the remaining 8 bits are for host addresses. So to scan the 256 hosts in this range, from for example 0 to 255, you can use the CIDR notation after the IP address 24 here, right? So in order to do that, we will do some example here. So nmap 192.168.13.0, and we will use the CIDR notation of 24, and as you can see here we will simplify scanning an entire subnet. So we can also work with a targets list in nmap here. For example, let's actually create a new target list here. Let's open the create document here and target, my target here, .txt here, and here we will open with it with the mousepad here, and now we will enter some IP addresses. In this case 192.168.113.138, 2.168.13.2, and so on. So we in this case we will have two addresses for the scan, and in order to do that, let's actually use the cat targets here, my targets.txt, and as you can see we have two targets. And in order to scan all of the IP addresses in this list, we can use and also to load the targets from the load the targets from the my targets.txt file. You can use the nmap as we did in previous lecture, previous example, lowercase e, uppercase L here, and my target.txt here. And this feature greatly simplifies scanning multiple hosts. And in the target file, you can also mix different target formats. For instance, you can also add here, let's actually open the file here. So 192.168.13.20 to 50, right? So with this, you can also mix different IP addresses and IP ranges in the same file. Remember, here you can add comments to your target list by starting a new line here with this character here. This is really dangerous IP here, and this allows you to annotate and organize your target files for better clarity. And fantastic, you learned the various target specification techniques in nmap, and whether you need to scan specific hosts, define IP ranges, utilize CIDR notation, or work with a target list. Nmap offers a versatile set of options to meet your scanning requirements. And I'm waiting you in next lecture and here. Hello, my name is Tayfun. Welcome to another awesome lecture of nmap. nmap is a versatile network scanning tool. It's widely recognized for its exceptional capability to not only detect the open ports, but also identify the operating systems and services running on remote hosts. So this recipe explores the process of fingerprinting operating systems and services using nmap, providing valuable insights for security assessments, vulnerability detection, and network monitoring. Service detection is a crucial feature of nmap that unveils detailed information about the specific software versions running on a target host. To enable service detection, you can include the SV option in your port scan command. For example, nmap sv, and here you can enter the target host here. In this case, let's actually scan the codesily.com, and here by employing this sv option, nmap initiates service detection and augments the scan results with an additional column named version, displaying the precise software version associated with each detected service. And here now we are waiting for, let's actually, and as you can see, you can, by using the arrow here, arrow keys, you can see the process here. And here let's actually learn my so open my Windows machine on my I open my Windows machine on my virtual machine here. Now what we're gonna do is scan all the hosts to find that open in here fastly, and here we'll also see that, and our scan is almost complete. It's 81% here. And here our operating system detection is ended here, on codesally.com, and here, as you can see here, we are seeing the domain here with ports and so on. We have next service fingerprint. So when performing a port scan with a service detection enabled, Nmap furnishes an extensive report on the identified services. So the service version information is enclosed in parentheses here, Red Hat Enterprise Linux 6. So let's consider an example where where we scan well-known scanme nmap.org host here, and as you can let's actually read this, and here we are seeing some information here, fingerprint, open ports and their versions, their services, light speed, so on. So this gives us a good insight on what this hosting is using. In this case, for example, SMTPD 4.95. In this case, we can search exploits for this. We can also search exploits for this. In this case, it's a Red Hat, but in most cases, it's actually pretty secure, but nothing is unhackable. So, and here we have SMTPD as well. So here, let's actually use the nmap scan me here. Let's clear, and now nmap sv again. Actually, if we use the sudo, it will be pretty good here. Nmap scan me.nmap.org here, and oops, nmap sv sudo. We forgot to write nmap here. Nmap sv scan me.org, and here, here we will see an output here, which the output showcases a comprehensive list of open ports along with their corresponding services and versions, aiding in identifying potential vulnerabilities and monitoring software updates. So here we are waiting for this. It's actually, and here as you can see, 16% is done by now. Let's check it again. As you can see, it's 18.13 here. So while scanning, let's actually use another here. So we can also enable the operating system detection here. So in addition to service detection, Nmap offers powerful operating system detection capabilities. To activate operating system detection, you can include the uppercase O option in your scan command, and keep in mind that running Nmap with operating system detection requires privileged user access. In this case, we will use the sudo here again, and sudo nmap here, and uppercase O, and here we will write codesally.com and enter Kali here. That's it. And here our scanning is complete by now. You can see the server again, the services, and here we are, Nmap provides a output here. All scan results may be unreliable because we could not find at least one open and one closed port. And here aggressive operating system guesses is action tech this here, probably servers, and it's probably Windows in 97%, Linux 94%, 94%, and VMware Player Virtual NAT device. And here, so no exact operating system matches for host. So here we can also scan our local host. So I have Windows 10 machine on my network 133 here, and now we are going to scan this. So because of our Windows system, so our target system in our local host, it will do much more fast. And here, as you can see here, it's guessing Microsoft Windows 2019, which is Microsoft Windows 10. And here aggressive OS guesses is say they are the pretty same here, but that's it. So this is how operating system guessing works. So the actually let's actually I wanna also tell you something. Let's actually run it again. So this upon enabling the operating system detection, Nmap appends operating system related information at the bottom of the port list in the scan result, as you can see here. And here Nmap service detection is facilitated by the SV option, operates by dispatching a series of predefined probes for the Nmap service probes file to the open ports detected during the scan. So these probes are selected based on their likelihood of identifying a specific service, taking into account the port number and rarity score. So service detection plays a critical role in various scenarios, such as vulnerability assessment, service verification, and patch update assessment. So similarly, the -O option here empowers Nmap's operating system detection features. So it achieves this by sending probes to the TCP, IDP, and ICMP protocols against both open and closed ports. So Nmap's vibrant user community has contributed an extensive collection of fingerprints encompassing diverse systems, including residential routers, operating systems, IP webcams, and various hardware devices. And it's important to note that operating system detection necessitates raw packet manipulation, requiring Nmap to be executed in privileged mode. So Nmap adopts the common platform enumeration (CPE) naming scheme, so widely embraced in the information security industry to accurately identify services and operating systems. So this standardized convention facilitates precise identification of packages, platforms, and systems, streamlining vulnerability assessment and risk analysis. Hello, my name is Stefan, and in this lecture we will learn how to scan random targets on the internet. Nmap, a powerful network scanning tool, offers a fascinating feature that allows researchers to conduct scans against random targets on the internet. Although it's important to note that aggressive scanning without permission is not recommended and may be illegal in certain countries, and generating a sample of random hosts can be valuable for research purposes related to publicly accessible hosts. So let's explore how to generate random hosts as targets for Nmap scans. So to generate a list of n random target hosts, you can use this nmap command. Nmap lowercase e uppercase r here, so we will do 20 here. And now here we are generating 20 random hosts. So here let's actually wait, and here as you can see here, we scanned randomly and there is 0 hosts up. So now let's delve into the prevalence of ICMP, Internet Control Message Protocol, on remote servers, and we will launch a host discovery scan against 3 random targets. So nmap sn, so this is a host discovery, and lowercase e uppercase r, and we will do 3 here. And here the scan results will display information about a scanned host. In this case there is a 0 hosts up, so let's actually make it 50, so we will have more chance to get the online hosts here. And here you can use the arrow keys to see the percentage of the process, and here it's 9400. And as you can see here, there's a 3 hosts up, and here accumulatortechnologies.com and so on. So the scan results will display information about a scanned host, such as their IP addresses, responsiveness, their domain if they have any, and the latency. And this is the sample output that Nmap will give it to you. And let's actually learn how it works here, right? So by using the Nmap
lowercase e and uppercase r option followed by some number here, Nmap generates a specified number of external IP addresses and utilizes them as targets in the scan. So this target assignment can be combined with any other scan options as needed. So while this feature can be valuable for internet research, caution should be exercised when using it, and Nmap has no control over the external IP addresses it generates, meaning that the generated list may include critical machines under heavy surveillance, so keep in mind. To avoid any unintended consequences, it's important to use this feature responsibly and ethically. And there's also more here. So if you want to generate an unlimited number of IP addresses and run the scan indefinitely, you can use Nmap lowercase e, uppercase r here, and 0 option. For example, if you're interested here, in this case, oh sorry, no, it's not 0. So 0 option, and here we will scan it indefinitely until the IP addresses end, or we have some error from program, right? And here, for example, if you are interested in finding random online NFS, here network file system shares, you could good this command here, nmap. First we will enter the port here, so because NFS network file system uses 2049 port, 2049 port, and here we will use open and IR here. So here we will scan open the online machines that uses this port, and this port is open in that machine here, so we will scan it on unlimited here. And here, as you can see here, we have a here, as you can see here, it's running all the way. So here, and there is also legal uses with port scanning here. So it's essential to be aware of the legal implications surrounding port scanning. Engaging in port scanning without proper authorization is generally unwelcome and even illegal in certain jurisdictions. And before conducting any scanning activities, it's crucial to research and understand the laws and regulations in your local jurisdiction. So Nmap provides comprehensive documentation on the legal uses associated with port scanning, which can be found on their websites here. Let's actually go there. So we will go nmap.org here, book and legal issues.html. So here I highly recommend that anyone considering internet-wide scanning takes the time to read and understand these resources. Here there's also, as you can see here, security list, security tools here. So there might be some error, legal uses here. So they might be changed this link here. So but here you can see, we also can Google it here. We can also go it here, and here nmap legal uses, and here we will go to nmap's official website here, and that's it. So yes, we need to use this here. So that's it. And as you can see here, when used properly, nmap helps protect your network from invaders, but when you use improperly, nmap can, in rare cases of course, get you sued, fired, expelled, jailed, or banned by your internet service providers. So reduce your risk by reading this legal guide before launching nmap here. So there's a here, as you can see, there's a port scanning is not crime, and the strong opinions on a port scanning legality and morality. And here, as you can see here, I love BMW, their nice car here, M3 I think. Yes, and here you can read all of this chapter to understand the legal uses that comes with scanning ports here. So I'm waiting you in next lecture. Hello, my name is Stefan. Welcome to another awesome lecture. So in previous lecture we mentioned what an address resolution protocol is, and in this lecture we will look at it in more depth. So in the local network, communication takes place between devices using MAC addresses instead of IP addresses. So they are also called link layer addresses. So ARP is a request response protocol, which means that one device requests a service and other one replies in response to that request. So suppose that two devices are present in a network with no external internet connectivity. Here actually we had them
we had diagram of this here. So suppose we have two devices here, which is Typhoon's device and Johnny's device, with no internet, external internet connectivity. So for them to communicate with each other, they need to rely on an underlying protocol, which is known as the layer 2 protocol. So we already briefly learned about ARP tables. So by using ARP table, device can maintain a list of all the devices on a network by using mapping of their IP and MAC addresses. So this is the regular ARP table would look like here. ARP cache in first place, ARP cache MAC address in second place, and as you can see, we have all the ARP tables of. So the Typhoon's Windows 11 has router's ARP table, and the router here has Typhoon's Windows 11 ARP tables here. So this ARP table technique is quite old and was designed without security considerations in mind. So it has some inherent weaknesses that can be exploited, as we will see in later lectures. But first, let's start about learning about what ARP poisoning is. So before we start learning about ARP poisoning, but let's look at the ARP again. So ARP is basically a program on your internet that's installed on your PC that performs all tasks related to address resolution protocol automatically without needing to any input from the user. So to get an address from a machine, it puts FFFF, like lots of F, 6 times 2 F's here, I think here. So it puts this amount of F's, which in IRP here, it means broadcast here. So I want to show you something that we learned in previous lecture. Let me actually open my Kali, and yes, perfect. So you remember this example that we did in previous lecture here? Oops, here. So as you can see here, we have lots of S. So these F's mean broadcast in ARP address resolution protocol. So this A's means broadcast. So let's go to our diagram again. So we use that F's, remember? So here, this F's as a broadcast address. So we are sending this F's to everywhere. And it does this to send to requests to all the active devices in the network while asking the relevant question. So subsequently, the intended device replies with an appropriate answer. So let's look at this diagram here. So now here let's go to previous diagram that we drew in previous lectures. And here, can you see it? Yeah, perfect. So our Typhoon's device sends request, and Johnny's device replies with an answer along with a MAC address. So looks pretty straightforward, right? So actually, there's a design flaw in this protocol. So when a Johnny's device receives a request, so if Johnny's device receives a request, it has no way of knowing whether the information being provided by the requesting device is correct or not. So in this way, you can easily spoof the packets. And now let's go to this example here and see what's changing here, right? So here, actually, let me make it this a bit down here so we can see in a zoomed mode. Can you see it clearly? Yes, perfect. And now let's consider a scenario here. So let's say our Typhoon's device wants to communicate with an internet-based device. As we already know, it can't directly connect to internet by self, right? It can't connect to internet by itself. So it must go through the gateway first a router, and then router connects to this, right? So the corresponding IP and MAC addresses of the device are shown is here. So the Typhoon's Windows 11 and the gateway maintain their own ARP tables. So for Typhoon's Windows 11 to send a request to the external server, it will look inside its own ARP table, which is here. This is the Typhoon's 11 ARP table.
to find the MAC address of the gateway device, and this is the ARP table of this gateway device, right? So once it successfully finds the device's MAC address, and as you can see, it found it from here. This is the MAC address of our gateway device. This is information about our router. This is information about our computer, and this is the ARP table as written here: ARP cache IP, ARP cache MAC, ARP cache IP, and ARP cache MAC. So this here represents the step 1 in this diagram, as we explained here. So if there's only one device on the local network, the ARP table in the Typhoon's Windows 11 will look something like that, right? So the ARP table in device of Typhoon's Windows 11 will look something like that. So now, since the gateway is a bridge between a local network and the internet, I will figure out the external IP address for the packet. So then, using its own external or public IP address here, as you can see, we have public IP and private LAN IP here. So, but in Typhoon's Windows 11, it actually doesn't have a public IP since it has the same router 1 IP as the router one, right? So they are sharing the same public IP here. So using its own external or public IP address, it will forward the request to the server located at 89.201.20.19, and this is the step 2. And the server here will process, actually, since we are completing this here, we're gonna make this red, and this means that we completed the steps here. So here, the step 2, actually, instead of making red, it will be much explanatory if we make it yellow. And here, so this is the step 2, right? So the server will process the request and reply to the router. So the server will process the request and reply to the router, and this is the step 3 here. And the router will receive this reply and figure out where the external packet should go to. And how does it figure out where the packet should go? As you may have guessed, it will look at the destination address and destination port. Using its own ARP table, it will see where the respective device is located. And the ARP table in the router will look like this here. It knows our Typhoon's Windows 11 IP address and MAC address. So, and in the step 4, the router will simply forward the reply to the intended recipients. So that's it. This is how our diagram works. So far we have learned how a normal request or response works. And now here we will add an additional player called hacker or pentester. So we learned about how ARP works in this following way. As we already know, devices keep connecting and disconnecting indefinitely. Here, since they are keeping disconnecting and connecting, the ARP program doesn't keep this IRP table indefinitely, right? Another reason for this is the Dynamic Host Control Protocol, DHCP. I think you have heard about this, right? So DHCP. So another reason for this is that the Dynamic Host Control Protocol, this server, DHCP server, automatically assigns IP addresses to devices in a network. So when a device goes offline, the IP address becomes available again so that it can be assigned to a new connected device. So if our Typhoon's Windows 11 goes offline, and this is the IP address of Typhoon's Windows 11, it could be given to, like, for example, Jonathan's Kali Linux or Jonathan's Ubuntu here, and they could instead of using in the IP address of Typhoon's Windows 11, this 192.168.1.102 could be given to, like, Ubuntu system, the Jonathan's Ubuntu system, and whatsoever. So and as I said, For this reason, devices in a network periodically send ARP responses to other devices in a network to let them know of their current IP and MAC addresses here. So this ensures that all the devices have an updated record of the IP and MAC addresses, and this is how it's done to make the less complications and less like errors in the network here. So now, when a device receives an ARP response, it just updates its ARP table without any authentication or validation. So you can see the problem here, right? So if a device creates an ARP response with a fake information and sends it over to a victim or target machine, the receiving device will update its ARP table with fake information without validating the correctness of the data. So another weakness in the ARP protocol is that it allows us to accept responses, even if it didn't send a request, right? So now, let's look at another diagram here where I drew how attackers work, and now I will explain all of this here like in this lecture. So I hope you're seeing more here. So now, here we have attackers Kali Linux and Typhoon's Windows 11, right? So here attackers Kali Linux, which belongs to the hacker, will generate two fake ARP address resolution protocol responses. One for the victim and one for the gateway router. So it will send an ARP reply to the device of this Typhoon's Windows 11, right? And pretend to be a router. So similarly, it will send a reply to the router and pretend to be a device. So now, it will simply, as I said, it will go to Typhoon's Windows 11 and say, bro, I am a router, and it will go to router, bro, trust me, I'm a Typhoon's Windows 11, right? This is how it works. Pretty liar, right? So here, now both device, Typhoon's Windows 11 and the router will update their ARP table with this new fake information. So now, if Typhoon's device makes if the Typhoon's device, right, will makes the same request as it did in the previous case to the external server, instead of requesting going to the router, the request will go to the attacker. So the attacker can then choose to forward the request to the router, and at this point, the router will think the request is coming from from device A, and in reality, the request is coming from our attacker's Kali Linux device, right? So attacker's Kali Linux device, in fact, intercepting all the network between the router and device. So this is how man in the middle attack type work, and in next lecture we will create an example application with this here. So I'm waiting you in next lecture. Hello, my name is Stephen, and in this lecture we will learn how to build an address resolution protocol spoof program. So before we move on, let's take a look at the ARP tables again in both Kali as well as the Windows. And you can see Windows ARP table in the right top corner of the screen here. And I think, yeah, you can see it. And here we will also check the ARP A here. You can see we have here ETH0, Ether as well, and this is our, and some of this is incomplete, but I think this 128 is belongs to Windows. So as you can see here we have the correct MAC addresses for the router located at 192.168.13.2. Kali here is located at 138. And sometimes you might not see own IP addresses in your ARP packets, but sometimes you can see, so it doesn't make any big difference here, so don't worry about it. So, and our Windows 10 is located at 192.168.13.128 here, and we can see the IP address. So we are in the same network as Windows 10 here. So we can now close the we will just close the windows, but we will not turn it on or turn it off here. That's it to see fully here. And now what we're gonna do is we will start our project. You can also open the PyCharm here and delete old project, or you can create a new project from the file, a new project here, and that's it. So I suggest to use virtual environment, but you can also use this on your own Python 3 program here. So now what we're gonna do is we're gonna import some of the libraries. Actually, let's import all of the libraries, and so while we are coding our program, the integrated development environment will suggest us what the libraries and packets we want to import. So now let's from scapy.all we will import all here, but here we will this asterisk actually means that we want to import all the modules present in Scapy. So as we learned in the previous lectures, to spoof we have to create fake responses. So first we will create a response intended for the victim, and to do this we will create an ARP packet and see what fields can be set in it. So we will use the my ARP response here, and we will create a new ARP class here. As you can see, we got an error because we have to import the Scapy layers L2 ARP here. So I think if I would increase the size of the text a little bit, you will see better here, and we'll use the custom font 18. Perfect. So now what we're gonna do is, after that we will print this ARP response. In this case, this will not ask any root privileges, so we can run it here. And as you can see here, ARP has 000 says 1. As you can see, it's 108. It ends with 138. And do you remember it somewhere? And as you can see, it's our local. It's our Linux machine's local IP address. So, and after that, we will also use show. And let's see what will change here. And as you can see here, we are seeing Ethernet 10 megabit IP version 4, and we are seeing our IP address and MAC address here. So now the output would look like this, and we can also check this on here terminal and Python 3 main.py here. Oops. And as you can see here, we are seeing all of the information that the ARP provides us, address resolution protocol provides us. So the fields that we are interested in start from OP here. So OP stands for operation or type of packet. So this is here who has operation, which means that it is an ARP request, address resolution protocol request. So, but we are interested in creating an ARP response instead. So, which is HWSRC here. So now HWSRC, and we also had HWDST and PWDST. As you can see from DST, haven't been set for this packet yet. So now we will make the modifications in this packet in order to spoof the victim. So actually, let me get my pen here. Okay, so we will change the OP to 2, right? Oops, sorry. We will change the OP to 2, and actually we will change the OP to 2, implying that this is a response here and not a request. So and by default this value is 1, which means it corresponds to the who has. So the 1 is who has, and 2 is just a response and not a request. And we will also change the PSRC here. You can see here we will change the PSRC address field to make it equal to the value of the IP address of the router, since our router is located at here. Remember this. Actually, let me open the new tab and if config, and here our router is located at here. Actually, let me write the ARP A here, and as you can see, our router is located at here, and we will set this field to the value. And lastly, we will set PDST. So we will set the PDST to the IP address of the victim's machine, so which is in this case is our Windows machine, and our Windows machine has an IP address of 128. So we will also set the HWDST address, which is the victim's MAC address, and here this is the victim's MAC address here, so we can see it freely, right? And now here in next lecture you will also write the code for it. In this lecture we actually introduced what we will do to create our project. Actually, this is not a quite simple project that we did in earlier lectures, but this will be like so much bigger than the previous projects here. So I'm waiting you in next lecture. Hello, my name is Stefan, and in this lecture we will learn how to build an ARP spoof program, address resolution protocol spoof program. So before we move on, let's take a look at the ARP tables again in both Kali as well as the Windows. So let's firstly look at those tables in Windows here. I will open the screen now. Okay, perfect. And as you can see here, we are seeing our address resolution protocol here. Let's actually write ARPA, and that's it. Here, as you can see here, we have use physical addresses and internet addresses here, and here we will also check that in Linux. We will not turn off the Windows operating system, but however we'll just close the screen right now. But actually Windows operating system is running now in here, and now we will go to our Kali Linux operating system, and we will check the ARPA. And as you can see here, the ARP table in Linux and Windows looks like this. And as you can see here, they have the correct MAC addresses for the router located at, let me actually, here, as you can see, they have all the addresses located at 192.168.13.2. So as you can see, you can see it on the Windows operating system as well with the same MAC address. So this is our router, and here this is our, I think, let me ifconfig, and this is our Kali Linux operating system attacker system in reality. It's IP address, and also we have the ether, we have the MAC address of it, and this 128 is Windows 10 operating system, which is the victim here, target machine. And now to spoof these devices, we will take on this problem step by step. So first we will tackle spoofing the victim machine with the MAC address of the router. So this is the IP address of the router, and this is the MAC address of the router. So now we're gonna open the PyCharm here, or whatever your internet integrated development environment is. In this case, it's PyCharm. I think it's one of the best IDEs for Python. And now we're gonna import scapy all and import everything. So this asterisk here means that we want to import all the modules present in scapy. As we learned in the previous lectures, to spoof we have to create a fake responses. First we will create a response intended for the victim, and to do this we will create an my ARP packet, and we'll make it ARP class, and after that we'll print this here. So ARP response, my ARP packet, and after that, or actually let's, instead of writing this my ARP response, it will be more logical to write like that. So as well as we will write this ARP response, and let's run this and see what will happen. As you can see, ARP who has 0.0.0.0 says this, which is, in this case, it's the attacker IP address, right? And now the output, of course, is going to be look like this, and we can also check it from the terminal, and as you can see, we got the same result as we did here. And the fields that we are interested, we have to get more detailed information, and in order to get that, we're going to use the show method. And we have a problem here because we need to import the escape layers here, and now it's everything. And as you can see here, we are interested from OP here in these 5 addresses. So OP stands for the operation or type of packet. Let me check actually if you can see it. Yes, we can actually close the windows, but it's actually, as I said, in reality, it's actually running in the background. You're just seeing the Kali Linux here. And now the OP stands for operation or type of packet. So the who has here operation, this is a who has operation, which means that it is an ARP request, address resolution protocol request, but we are interested in creating an address resolution protocol response instead. So here also we so we're gonna change this. Remember, this has to be changed. And we also have HWSRC. This is the MAC address of the Kali machine. We can check this by writing ifconfig to verify it, and as you can see, this is the same MAC addresses. And also similarly, PSRC is the IP address of our Kali machine. So HWDST and PDST haven't been set for this packet yet, but now we will make these modifications here. So now we're gonna go to Python, PyCharm, and we will create following. We will write following codes here. So my ARP, so we will manipulate and edit this ARP response here. So we will set it to 2, and I will explain all of these codes right now. And PDST is going to be, we will write the Windows IP for that. So now let's check. Oh, sorry, I opened browser accidentally, so we can close it. And we will gonna check the Windows IP. This is the Windows IP address and the Windows MAC address. And we're gonna go to PyCharm again, and we will write the Windows IP, and we will notify the, for example, the next programmer to, and we will add a comment that this is a target machine and Windows 10, and we also need to set the Windows MAC address. So my ARP response dot HWDST, and here we will copy this here, perfect, and we'll paste this. Oh, sorry, not this. So we will paste this right now here, and as you can see, this is the target machine Windows 10 MAC address here, and this is the IP address. That's it. And after that, we will also need to edit the my Kali MAC. So we will enter this HWSRC, and this is going to be our Kali attacker machine MAC address, and this is here right here. We'll also copy that to it, and attacker machine, and this is the Kali MAC address, and we will also need to set some fake field value, ARP response, my ARP response dot PSRC, and we will set one. Let's actually set the router here. Yes. Yeah. And here we have only crafted the last field, and we will be sending it from the, we can also make a tree here. So we will be sending it from the target machine or attacker machine, while pretending to be like Windows 10, right? So once all fields have been set, you can print them to see if they have defined correctly. Now we know what we're gonna do is we're gonna delete this print here. Actually, let's copy it, cut it from here and paste it right after this manipulation phase here. And as you can see, this is the output here. We can also check it and verify it from the terminal. We will run clear the console and run it again here. And as you can see here, this is our output. And as you can see here, our OP is changed, right? So this is the output you're gonna see here, but remember this IP addresses will be different on you, and you need to change this IP addresses according to your network or MAC addresses here. So now let's check this here, and so they are the two different physical addresses here. And now what we're gonna do is we'll go back to Linux here and test this here, and we will also add while loop here. So we go back to Linux, we will add the while loop here. So while true here, while true. So this code will run continuously, and that's it. So after that, we will go back to here and clear the screen and run it again. So sudo python3 main.py here, and as you can see, our loop is working and looping here. And now what we're gonna do is we will go to Windows, and here, as you can see here, use, and we will go to ARPA here, and as you can see here, we have the two same physical addresses here. So now when you run this program, whenever, if you are not using loop here, so you can go, if you are not using loop, you can quickly go to Windows machine before the ARP table gets reset, and you will see that the ARP table of the Windows machine has been poisoned, and that is the ARP table entry shows the wrong MAC address for this gateway. And instead of pointing the actual gateway, it now points to Kali's MAC address. So now let's go to Kali here and check. Actually, we can now stop it, and now we will go to Kali here, and we will use the ifconfig here, and our MAC address is exactly the same as the Windows one. As you can see here, Kali MAC address is now matched to, so they now share the two same MAC addresses in our network, local network here. So this is how ARP poisoning works here. So I'm waiting you in next lecture. Hello, my name is Stefan, and in this lecture we will turn this code into function, and we will also create a new function that we will spoof router as well. So now what we're gonna do is we will just cut this code here, and we will turn it into function like that. Let's actually see here. So now what we're gonna do is we'll do define function. So we will, so as you remember, this code is for spoof target, spoofing the target here, and after that we're just gonna copy this here. So now we have a spoof target method function, and now we will also add spoof router. So, and we will create a similar function to this as well, but here we will actually change some values, right? And def, so here this was a spoof target, and this is going to be spoof router here. And after that we will also, for now we will copy this and we will here. So that's it. And here this is in, remember in previous here, fake router IP. So here we are pretend to be that IP here, and pretend, and here we will also add fake target, or instead we will write the fake device, and here we will pretend to be that
device or that IP here. So, and after that, for example, remember our Kali machine's IP address here. If config, this is the IP address of our Kali machine. And remember, our Windows machine IP address ends with 128. So now we will change this to 128 here. And here we will paste the router's IP address instead of a target machine's IP address. So now this is the router's IP address. As you remember, our router IP address was this here. We will changing to here, and also we will also need the router MAC address. We can find it with ARPA. It was ending with 2 here. So this is the MAC address of our router here. That's it. Now we're gonna paste it here. So we will also change the router's MAC address here. We will changing to here, and this is also this will be stay same, and this is the attacker's machine, which in this case is Kali Linux, and this is the fake device present to be that IP. So as the name suggests of our function, this with that code we are spoofing router, so we are pretending that we are some device, right? So in this function we change the value PDST, HWDST, and P is RC, and here complete the program will look like this. Actually, let me delete that lines, and also here, from here, that's it. So here, and after that we will also add if and main here, if name main here, if name here, and main. So this code will work whenever our program starts. Main here, and after that here, as you can see, we get an error here because we need to here add this. And after that we will first spoof the victim, in this case spoof the target, and after that we will spoof the router, spoof the router. That's it. So and keep in mind that we will only spoof these devices once for now. To create a permanent spoofing, we can do this codes like loops and continuously send these packets after a certain delay. So this way the ARP tables will not get a chance to reset, and you will be able to permanently spoof these devices, so as long as your spoof program is running. So in order to do that, we will do the while true here, and we will just add here. So in reality, actually, you also don't need to wait or add some delay in it, but we will not add here for now. We will first spoof our target, and after that we're gonna spoof the victim. So the target here. So now let's run this. This might be asking for some permission. As you can see, operation not permitted. So we're gonna open our desk, and now let's go to PyCharm project, go to our project name, and here, that's it. It's clear. Now we're gonna run with sudo with super user privileges, and we will do main.py and Kali here. Oops, Python 3, of course. Python. That's it. And as you can see, we keep sending packages here, and here let's actually check the internet now. So we will close the internet because you will need to here And as you can see, when our internet is not working here, right? Let's actually go to myip.com. So our internet will not work for now. So we will now interrupt this, and our internet immediately will come back here. Here. And as you can see, our internet has come back, and let's run it again. Here, as you can see, it's running now. So that's it. So here, now we will also try to spoof these devices once, but we can also try to put an exit condition in our loop. So now what we're gonna do is we will use try and catch. Oops, to close this. And now here, what we're gonna do is we will use try here, while true we will spoof the target, and after that we will also spoof the router, and after that we will let's say we will wait for 1 second, and after that we will, after some user entering keyboard, we will interrupt it. So we will terminate our program. So except keyboard interrupt, keyboard interrupt as error here, or we can also just write E here, and also after that we will print the program is terminated and run successfully. That's it. And after that we can also run our program again. Let's cdt pycharm ls cdf typhoon, and here we have the main.python file. We will use the sudo again, python 3 main.py, enter the password. That's it. And as you can see here, we are waiting 1 second to spoof the router and spoof the target IP address. In this case, the target IP address, actually let me go over here. In this case, the target IP address is our Windows 10 machine, which it's online now. I will show you right now here. And as you can see here, now we will use the ARPA, and we will see some weirdness here. Now what we're gonna see is ARPD here, so delete this. Oops, ARPD, that's it. ARPA again, ARPA, and here, as you can see here, we have this IP address. Now we will go back to Kali machine. We will also check this ARPA, and as you can see, we only have one ARP, which is the target here, which is the router here. Target is our Windows 10 machine here. So and also you will need to import a time module. Although the spoofing programs looks complete, there's a slight problem. So if the victim now tries to request or go to some internet here, our victim, our target machine, will see an error. So let's try this out, and you will see if we can't enter the internet actually. As you can see here, we are just waiting and waiting. We don't have reach to the internet here. So this is because the packets we are going, the packets that are going to the Kali machine, but it's blocking packets from being forwarded, as you can see here. So to enable packet forwarding, you should run the sysctl command on your attacker machine. So now we will open the terminal and we will do sysctl here, w net ipv4 IP forward 1. Oops, of course we need to use the sudo here, and as you can see we change it to 1, and now, and as you can see here, we have reached the internet. So this will enable IP forwarding on the Kali machine, and now our target user will be able to access the internet without even noticing that someone is intercepting their traffic. So in next lecture we will monitor that traffic intercepting with Wireshark, and the next lecture is actually more interesting. So I'm waiting you in next lecture. Hello, my name is Tayfun, and in this lecture we will intercept that traffic here. So in previous lectures we did some advancements to this program here. Now we will open the Wireshark to see what the user is doing. So here we will go to here Wireshark, or you can also start Wireshark from your terminal and enter the password, because Wireshark wants to run on sudo privileges. And here after that you will select the ETH0 interface here, or you might VLAN 0 in this case if you are using wireless. And what we're gonna do is, let's actually stop intercepting traffic for now. We can also use, actually, let's make it more here. So now what we're gonna do is, in Wireshark, remember, actually we learned about how Wireshark works. In Wireshark here, this is the filter. So you can apply your display filter to here, and to see only the traffic originating from Windows machine, you can set this filter, set this from the filter menu here. So what we're gonna do is, oops, Wireshark, I think it's got crashed. Our system resources is not that much here, so these things might happen from time to time. So let me actually fix that. Perfect. Yes. So here IP.src we're gonna do, and remember what our IP address of our Windows machine was. It was, I think it was the IP or ARP A, and here we're gonna see our Windows IP address here. So this is our Windows IP address, and now what we're gonna do is, this is here, and we can also, no, this is actually our Kali Linux machine IP address here. No, yes, this is Windows, and 139 is Windows IP address, and 138 is our Kali Linux attacker's IP address. So we can also check. Let's actually, for now, let's reach to the system and check this IP with IP config here, and as you can see, 139. So we will not touch any systems here. And now, so we can also find the HTTP login page for now. But now, actually, let's go for now. Now what we're gonna do is, we will add this IP address to here. So 192.168. So we will enter our target machine IP address as we spoofed here, and we also need to run our program here. So actually it's running here in the background, as you can see, from 1 second. So every 1 second we are executing these functions, both spoof target and spoof rudder, and after that we are sleeping 1 second here. And now what we're gonna do is, let me open the recording program to see if you are seeing our Windows machine clearly. Yes, perfect. And now what we're gonna do is, we're gonna go to terminal, As you can see, it's running. We're gonna go to the second tab or Wireshark here, and as you can see, we will add our target IP address. So it's gonna be 13.139. So our IP address, I hope, no, as you can see here, pretend to be that IP one. As you can see here, our IP addresses is changed, so we will change our target machine IP address to this, because every time you turn your computer off, if you are using the DHCP server and not static one, you will get this kind of problems. But it's not actually big problem. You can just scan the network and you can easily find that IP and MAC address of the device. So as you can see, actually you don't need to find that MAC address twice here. Here, as you can see, this is the 235. This is the router's MAC address, and we will get that here. This is the target MAC address, target machine, Windows 10 MAC address here, and here let's actually check if we already have same MAC address. Yeah, perfect. We have the same MAC address here, and we will pretend to be that IP here. So in this case, we will make this 19139 here. That's it. As easy as that. And now we're gonna run this program again. Perfect. And here we will go to here and apply that filter. And as you can see here, we send we can intercept the traffic here, and let's go to somewhere in our Windows machine and let's see what will happen. So we'll use some Google Docs here, HTTP here, and we will also use the admin here. So we will go to some admin page here, and let's actually here we have to start the intercepting from that file. We are having a quite problem with this program here. Now we're gonna copy this here, but without saving. Open Wireshark again, enter password, that's it. And now we're gonna go to ETH0, and here we will apply the filter. In this case, the filter was ip.src, and this filter here. Perfect. Now we're gonna go to, as you can see, it's recording, adding new incoming destination. We can see the source, destination, and protocol here. In Windows, now we're gonna go to, as you can see, we have some here university login page. So we will not do anything harmful to this page. We will just enter some info. So this is our special username and password, some super magic password here, and I will not see this password, and so we will get error. So now we will go back to, as you can see here in Kali machine, we are getting some new connections, so we can stop this here. And now here we should see the packet arriving in this Wireshark here. So now we have this here and login. So we have and here we will apply some filtration again here. So we will add the, so as you remember, as you know, the most login methods using post here. So we will use HTTP request method is gonna be post here, post, and here let's apply that filter. Perfect. And after that we will also add and here also we can also start continue without saving here. Oops, sorry, we need to do that again here. Sorry. Actually, this is our special username, and let's enter some password. No matter how hard our password is, we'll gonna able to see it. Now we will go here. Oops. Actually, we can open this, and we'll go to here. And now we will stop the intercepting. And after that, we will enter our filter methods. So now we're gonna do http dot request dot URI path contains login. Yeah, that's it. And after that, we will gonna be able to see it. Oops, sorry. Okay. So here we'll delete this. And as you can see, we got nothing here. So in some here, you might get an error for this, or you might get nothing because you would want to use different filtration here. So we can also make it more this. And as you can see, we got this here. And as you can see here, we have this. As you remember, this is the IP address of our LMS website of some university. Here we can see a lot of information about it, the frame length, frame number, destination, here source, and here we will see our information. Let's right click on it. We can also protocol decode here. Okay. And here we have a form items. And as you can see here, this is our passwords, right? So let me actually here. I think you can see it here, right? We will take a screenshot now. Oops. Let me take a screenshot right here. And now, here, you will see it right now. As you can see here, this is our special password, special username, and also we have a password here. So this password might be quite hard to brute force or something, but we got it easily. So this is how our Wireshark and Python program worked, and I am waiting you in next lecture. So we can also do another website here, but for this lecture, I think it if it will be more practical lecture for you, and you will understand better how this procedure works if you do this by your own. So I'm waiting you in next lecture. Remote access Trojans are commonly used tools in cybersecurity for both legitimate purposes and by malicious actors. So, remote access Trojans enable remote control and management of a computer system, allowing a user to perform actions on a remote machine through the network connection. So, while some remote access Trojans like TeamViewer are widely used for legitimate purposes, others are specifically designed to be stealthy and hard to detect, and making them attractive to hackers. So, remote access Trojans consist of two components: a client program that runs on the victim's machine and a server program that runs on the attacker's machine. So, these components work together to establish a network connection and enable remote control. So there are two main configurations in which remote access Trojans operate, depending on who initiates the communications, which is forward connections and reverse connections. So let's get started by learning about
forward connections. So in forward connection setup, the attacker initiates the connection with the victim's machine. So the attacker server program actively connects to the client program running on the victim's computer. So this configuration is useful when the attacker knows the victim's IP address or has some access to a network infrastructure that allows them to reach the victim's machine directly. And we also have the reverse connections. So in a reverse connection setup, the victim's machine creates a connection to the attacker's machine, and the client program running on the victim's computer establishes the connection with the attacker's server program. So this configuration is often preferred by attackers because it bypasses firewall restrictions and allows them to gain access to systems behind network boundaries or with dynamic addresses. So both forward and reverse connection remote access Trojans provide attackers with a range of capabilities to control the victim's computer remotely. So once the connection is established, the attacker can perform actions including but not limited to file management, like manipulating files and directories on the victim's machine, such as uploading, downloading, modifying, or deleting files, and system control, executing commands or running scripts on the victim's computer, enabling actions like launching applications, manipulating settings, or restarting the computer, surveillance, monitoring the victim's screen, capturing keystrokes, or accessing the webcam and microphone for covert surveillance, and data theft, so stealing sensitive information such as login credentials, personal documents, or financial data stored on the victim's machine, and also botnet creation, transforming the compromised machine into a part of botnet, which is a network of infected computers used for coordinated cyber attacks. So for remote access Trojan purposes, we will use socket programming in Python. So before learning about malware development, it is necessary to learn about the network programming in Python and how we can create a network application. So the first step in learning network programming is to learn about what we call sockets. Sockets here. We can also write it on the screen like that. Sockets. Oops. Sockets. Sockets here. So sockets provide a fundamental mechanism for creating network-based applications, and our malware is going to be essentially a network application, right? So let's start by understanding the sockets first. So before we jump into socket programming, let's understand what sockets is and how it can be used to develop network-based applications. So a socket is one endpoint of two-way communication link between two programs running on the network here. So this is the sockets, for example, and this is the communication link. So it's actually, it might sound like something more basic, but it gets more complicated when we deep dive into it. So a socket is a bound to port number so that the TCP layer can identify the application that data is destined to be sent to. For example, for every socket we need some port number. So this is IP and port, right? Port. And sockets are generally used in client-server communication, where one node is a client, here, client, and another node is server, and that's responding to that call here or connection, right? So at each end of the connection, each process, such as network initiation program or a network responding program, will employ a socket.
So a circuit is typically identified by an IP address concatenated with a port number like this. In typical scenario, a server usually listens on a certain port for incoming connection requests from clients, and once client request arrives, the server accepts the request and initiates the socket connection with the client. So servers implementing specific services here, such as HTTP or HTTPS or like telnet, FTP, and so on. So they listen on popular, known, and well-known ports such as 80, 21, and 443. And keep in mind that ports from 1 to 1024 are regarded as well-known ports and should not be used in implementing on your own programs, as they are already reserved. So in some ports you might use this in some programs, but somehow they will be used for some programs and your connection will be failed somehow. So and let's try to understand how sockets work in Python here. Now we will import socket. So to create a socket in Python, we utilize a socket library. So this library is a part of Python's standard package. This is a part of Python's standard package, so we don't need to install anything. So now let's take a look at the application programming interface of this module. So an API is a software interface to code base that lets you access functionality of the code with some level of abstraction. So we have this socket here, for example, socket.socket here. So this socket here, application program interface, helps us to create a socket object. So we can make use of this function called this, so to create a socket, right? So let's take a look at the parameters of this method. So to see what parameters are available in the function, we can use Control and P to see it briefly here. And as you can see here, it gets family, address family, socket kind, port, and file now here. We can also open this here with here, generate folder, go to declaration or usages here. And as you can see here, we are seeing family type proto and file now here. This is the function here, how it's written. And here you can also use the docs documents to learn more about the socket function. And here, as you can see here, we are seeing that, oops, not here. So here we are seeing a socket in a class, and its constructor requires family, type, proto, and file no parameters. In this case, it's not actually using. And as you can see here, we have a comments here and docs. So for now, you just need to understand that calling the constructor of the circuit here calls calling the constructor of the circuit calls return a socket object that can be used to communicate with other devices. And we also have socket.bind here. So also let's take a deep look at this again. We'll go to implementations, and here implement a type declaration here. We can also go to type we will go to declaration or usages or implementation. I'm sorry. Cannot find declaration here. So that's because cannot find the reference bind socket pair here. So we will create a functional model. So here, after you created this socket object here, for example, socket or my socket, and after that, after creation of the socket, we will do my socket dot bind here. So this function here lets us implementations, and as you can see, this bind here. So to create a server, you need to bind a socket to the IP address and the port that the socket will utilize for communication. And also keep in mind that this function is only used when creating a server program. So for servers, these must be explicitly assigned, since the server has to listen for incoming connections on a specified port. So in the case of a client, the IP and port are automatically assigned, so you will not use this function on a client application, but you will need that in server application. And we also have the listen here, listen function. So this listen function is used by servers to listen for any incoming connection as per the configuration assigned this bind here. So my socket.bind method. So in other words, it waits for any connection attempt to the specified IP on the specified port, and this requires a queue size for the number of connections to be held in quote here. And as you can see, we are only going the backlog one integer here. So here this means allow 213 connections at a time. In most cases, you can use also, depends on the project actually. You can also use 1000 connections at a time or 5 connections at a time. So it depends on the project, right? And we also have the accept. So as the name indicates, this my socket accept. So socket accept here, accept connections made by clients. So this is actually a blocking function call, so which means that the program execution will pause here until the connection is successfully made. So once a connection is made, the execution program will continue. And we also have the mySocket.connect here. So as you remember from the accept, this is also a block execution until the clients connect. So the question now arises, how do clients connect? So there's a connect comes into play. This method initiates a connection to the server, and if a server is waiting for incoming connections, communication will follow. So when a call to socket connect happens, socket accept gets unblocked in the server and execution of the program continues. So don't worry if this all seems very confusing to you at the moment as to which functions are called in the server and which functions in the clients, but you will get a clear idea of this when we build examples here. And we just need to also consider 3 parameters as well, which we will use in next project of ours. Then one of which the socket.send. So once the connection is made between the server and clients, the most important part of the program comes, which is to send data over these connections. So this is where most of the user-defined logic will reside here. So the socket send method is used to send bytes over the network. So and keep in mind that the input to this function is bytes. So any data, as you can see, it's bytes, right? So any data you want to send over this connection should be in the form of bytes. So which is not a hard thing to convert from bytes to strings or from files to bytes. So it's actually easy, not like sounds like you might confuse it from first, but and like I will be honest, because like 5 or 6 years ago when I started working on these sockets, like damn, how we will send and receive bytes over the network, but we can't read the bytes. But don't worry about it, because Python has libraries and functions to turn bytes onto like meaningful messages or meaningful messages to bytes, so don't worry about it. And we also have this socket, my socket. Of course, we have this send, and we will also need to have receive. So this method, as the name suggests, is used to receive bytes once the user sends the data. So also keep in mind that every call to the send or receive methods should be handled properly. For example, if the server is sending data, the client should be ready to receive this data and vice versa. So the input to this method is the number of bytes you want to receive at once here, and bytes here. So this is the buffer. This is the buffer created by the program to temporarily store data. And once a certain memory of bytes arrive, they can be read, and the buffer is ready for the next cycle. And lastly, I know this lecture actually might be quite long for now, but this is the last method here that we're gonna use here, which is the close. So once you have done everything you wanted to do with a program, you must close the socket so that the port can become available to other programs to be used. So also keep in mind that even if you don't close the socket properly, it will be released by your operating system after a period of time once your program exists or computer restarts. So however, it is always a good idea to close the sockets manually inside the program. So if the program exists and the socket is not closed properly, any incoming request may be blocked, or the operating system may refuse to use the socket for the next program because it may think that the port is still in use. Hello, my name is Tayfun, and in this lecture we will write a program for the attacker server or the pentester server that our pentesters will use that server here, that program. As you learned in previous lecture, we need two programs for the remote access Trojan for the server and client side. So now let's go to our Kali machine environment, and as we've done, we will not require any external libraries in this lecture, but it's always a good idea to use virtual environments to keep track of the dependencies on our program. Also, you will also now create a new file, or actually let's create new file named, actually we can also delete this main.python file and delete this from here. We will also do it here, and now we're gonna right click on the project folder and click on the Python file, new Python file, and now we're gonna write the, since we're gonna create the server side of the application in this lecture, we will write server rat, and that's it. And here let's actually check our IP address of the Kali machine. So if config, and as you can see, this is the IP address of our Kali machine, and for the victim's IP address, we're gonna check actually let me check if this Windows is opened here. It's opened. Let me actually show it to you. This is the Windows here. It's opened and active. So for now, we were just gonna hide it. Now we'll go back to Kali Linux, and here what we're gonna do is we're gonna get the IP address of Windows machine without even touching it. So now we're gonna use the nmap to define what device in our local network uses the operating system. In order to do that, we will enter first the 192.168.13 and 1. After that, we will add 24 to just scan 255 IP addresses and press enter. And keep in mind that this is not 0 or lowercase o, this is uppercase O here as a parameter. And as you can see here, this CPIP fingerprinting for operating system scan requires root privileges, and now we will use the sudo to run it. So Kali, and also we will open the notepad here. Now or I think it was a mousepad, yes. And here we will write the Kali or attacker, or actually pentester is more appropriate term for this example. And here we will write 192.168.13, and here we have the 13 point, I think it was, yeah, 138. And after that we also, let's actually also add the operating system, which is Kali Linux 2023. And also after that we will add the target machine, target, or yeah, target here, and target here we will, after this nmap scan, let's go back to it. And here, as you can see, we are seeing all the devices in our network. Here this is VMware, and we have this IP address here, and as you can see here we have the nmap scan for 139, and we have, this is the router of our local network, and here this is our Windows machine. And as you can see here, it might say Windows, Microsoft Windows XP, that's the old version of it, but here, as you can see here, it's written 2019, or might be this Windows Server 2019. So actually this is just a guess. So nmap, as you can see, it's also written the just guessing here. So now we know that this target machine runs on Windows, probably Windows 10, and as you can see here, Microsoft Windows Server 2019 and Windows Microsoft Server 2019 is actually Windows 10. We can check it out from here. MS Server Windows or 2019 here, and we will check how it looks like. It's yes, I think, yeah, it's Windows 10, based on Windows 10, but it was a server version of it. So we know that it is Windows 10, and now we will also add the IP address of our attack target machine, 192.168.13 and 139, and that's it. And here Windows 10 here. And after that, what we're gonna do is we're gonna go back to PyCharm here. We'll close that, because actually it's going to be good to put some space on the left side of the screen here. Now the IP address of our Kali machine is this, and for the victims or targets Windows machine is this. So next we need to select which port we will be listening on for incoming connections. So as you learned in previous lectures, we need ports, right? So we need to select ports. So you can select any port above 1024, or you can select any port. We will add this here as a comment, any port on, or any port above 1024 and less than 65,300, 300. Actually, let's actually check the maximum number of ports here. Maximum number of ports, max number of ports in TCP/IP, and here we will get the answer of 65,535, right? 65,535. And here, let's actually, we will use the port number 9877, and yeah, you can also choose whenever you port, whenever you like, or whatever number you like here. But in most conditions, you need to choose the like most suspicious, less suspicious port number. For example, 1337 is mostly used for, or 1339 is mostly used for remote access Trojan programs. So you can also choose some 880 to like make it less suspicious. But you can choose, as I said, you can select any port above 1024 and less than 65,535. And now we're gonna write our program. So as I said, we will use we will use 8788. So we will firstly import the socket here, and after that we will create the socket object here. So actually we will also need to use the if name to run our program here, and after that we will use the main. So here actually you learned in previous lecture where we are reading this, and after that we're gonna use the hacker server socket here, and after that socket that, remember, you learned almost all of the methods that we're gonna use in previous lectures. I think it was a 18-minute lecture, so it was a pretty long. So socket. So first we're gonna socket AF inet. So this is the IP address here. Socket inet. So you will know why are we writing this inet here. And after that we will also input as a parameter of socket kind, in this case socket.sock stream here stream. That's it. And here on the first line we are simply importing the socket model from the Python standard library STL, and next we are creating a socket object. So the two parameters, socket.af inet and socket sockstream. So let's see what they mean, right? What they mean. So remember that we talk about the IP version 4 and IP version 6, right? You remember that? And so this is exactly what the socket AF inet and socket sockstream means. So if you want to use IPv6, which you probably won't, you will, in that case, you will use inet6 here, and as you can see, inet and inet6. So inet6 is IP version 6 and inet is just a regular IP version 4. So remember that this here, actually let's run if config here, I will show you again, and as you can see, this is our IP version 6 address of our local here, and this is the IP version 4 address. So we're gonna use IP version 4, and here next here we need to define what protocol layer we wanna use. So here we have options for either TCP or UDP socket. So in our examples, we want to use reliable connection. So we will use TCP, and so sock stream means that we are creating a TCP socket here. So if you want to create a UDP socket, you can also, which again, you probably won't for the most part, you can use the socket.sock stream. Here, as you can see, we have sock dgram and sock stream. So we're gonna use sock here, sock stream here. But if you wanna use the UDP, you can select that sock dgram. So we will use sock stream here. Sorry, sock stream. Perfect. So this is the TCP and IPv4 TCP here. And next, we will bind this server to the Callis IP address on. Let's remember the port. So here, port here. So port. So we will bind this to our IP address. As I said, attacker IP, and we're gonna enter the attacker IP here. And as you can see here, we enter the attacker IP in the strings, of course. And after that, we will enter the port. So of course, we will not use the different ports for attacker and server side. So we will just use the one port for each side. So think of ports like doors here, like doors in hotel, right? You need to use same doors to meet some person on hotel, right? So that is how the ports work on a TCP/IP model. And also we will use the socket address. So my socket address here, we will pass two arguments, IP and port. Attacker IP and attacker. Oops, actually, sorry for that. We have, as you can see, we have hacker server socket here. And now what we're gonna do is we will create the two here, my socket address. It's gonna attacker IP and attacker port. So attacker port. So as I said, sorry for this. Attacker port. There's no attacker port and no victim port. There is a same port, so they are using same port but different IPs here. So this is how internet works. So also keep in mind that you have to give the IP address and port here in tuple. So this is, we created tuple here to the socket point here. So you need tuple, as I said. And here we will enter the hacker server socket, the bind. We will bind this my socket to here. And what we're gonna do is here we'll pass this my socket address, and after that we need to listen for incoming connections on the specified socket with the help of this command, which is hacker socket.listen and 5. As you remember, this is the second here. So now that our program configuration is almost complete, we can start listening for incoming connection requests, which we will do in next lecture. So I'm waiting you in next lecture here. Hello, my name is Stefan, and in this lecture we will be creating a simple server application using Python sockets, and I will guide you through the code step by step and explaining each line and function along the way. So by the end of this lecture, you will have a clear understanding of how to create a basic server using Python. So let's start by writing the server application here. So as I remember, in previous lecture we did this here. So we added first we created set the attacker's IP addresses and the port numbers to the list, and actually this is the kind of the IP address that we've been waiting the request or response from. So we will changing to 0.0.0, and because in this case, for example, we have this amount of computers in the network and they all have the specific IP addresses. So these are the computers, and this is the attacker computer here. And here, by typing the specific IP address, this means that we are waiting the response from specific IP address here, specific computer, and actually that's not a good solution for remote access trojans in most cases, because we will want clients from every IP addresses, and that's why we're gonna write 0.0.0 to wait all the clients from every IP addresses here. And after that we will have the port here and IP to listen here, and we will change also here IP to listen. That's it. And after that here, remember we create a socket object for the server here. Oh, sorry, we create a socket object for the server, and after that here we, as you can see here, my socket address IP to listen port. So this is a tuple. we will define the server address and IP here, and after that we bind the socket, in this case my socket address variable, to the server address. Yes, you remember we have used the socket AF inet, which is IP version 4, and TCP here, we use TCP protocol. And after that here we listen for incoming connections, and we here allowed 5 queued connections here. And after that, let's actually use the print here to show the user. In this case, the only user that the server is gonna run on it, it's gonna be V. And so this is the server is actually the attacker application. And here we will print here, so listening for all incoming client connection here. And here I want to mention that we are printing message for like listening for all the, we are notifying the user that we are listening for all the client connections here. And after that we will accept a client connection. So in order to do that, we will use client socket. In this case, it's going to be client socket, and we will also add a client address here, and we will make it equal to server socket here. In this case, our server socket is hacker server socket that accept here. That's it. And here we will print the client's address to confirm the connection. And in order to do that, we will print here, and we will print that we are connected to client here, and we will print the client address. So you can also do this with formatting here. In order to do that, we will use this, and here we will just add F here before the quotes here, double quotes. And after that, we will receive the print message from the client. So we will, so the client will send us some message here, and we will receive and print that message to the user. And here, while we will work this loop will run until we press the Ctrl C or terminate the program somehow. We will create a new value here, which is data. So client socket that receive here, and we will write 1024, and we will also decode that. So here, data here. So here we will receive the data from the client. In this case, we have a condition that we wanna receive that data up to 1024 bytes and decode it from bytes to string. So remember, in previous lectures I explained that if you want to send some message over the network, you need to first turn it to bytes, and when you're receiving it, you need to turn it bytes to string, right? And here we will also add if condition here. So if no data is received, it means that the client has closed the connection. So we break out of the loop here. So if not data, we will just break here. That's it. And after that, we will, after breaking the loop here, we will print the received message, or just write a message from client here. And after that, we will enter the data. So we're gonna use the here data. That's it. And we will also use format. Perfect. And after that, of course, we need to, after using the circuit, we need to close the circuit. We will use client circuit dot close here. And after that, we will server socket server here, socket server, or I think we have the client socket, client address, and we have hacker server socket dot close as well. And this is a client socket, and this is the server socket here. And now we're gonna run this program here to say everything is okay. And as you can see here, we are waiting for the response here. And now we're gonna run this program on terminal. Sudo python 3. We might get an error because we are running the program twice on the same port, but we are still listening here, and we will test that out here. Server rat. And as you can see here, address is already in use, and we will stop this here. And here, as you can see, Vascience, they're closing this as well. And here, and as you can see here, we are listening from the terminal here. Actually, they're quite the same thing here in this case, but here, as you can see here, we are listening from terminal. So I'm waiting you in next lecture for developing the client application. So this was the server side. So here in previous lecture, we completed our programming, but if you didn't understand it, the line of codes, and here I will explain these codes line by line. So if your program worked and you understand everything we wrote here in the previous lecture, then you might skip this video and continue on the next lecture, which we're gonna develop a client side of our remote access Trojan application. So let's get started. So now in first line, we're gonna import the socket module, which provides the necessary functions and constants for creating sockets. And in line 3 here, the if name equals main condition ensures that the following code is only executed when the script is run directly, not when imported as a module here. So, and here we have we are setting the attacker's IP, and as I explained in previous lectures, so we're gonna get the connection not to a specific user, but from all the users on the network. And here we are setting the port number to listen on, and here we are creating a TCP socket object for the server using the socket here, socket method, and socket AF_init specifies the address family of IP version 4, and the socket sockstream indicates that this is a TCP socket. So, and after that, we are combining the attacker's IP address here, IP address and the port number to form the server address as a tuple, because server address accepts this as a tuple. So remember, tuples are like lists or dictionaries, so they are the variable types. So this is a primitive type actually, so this is not from the socket module here. And here, after that, we bind the server socket to the server using bind. And after that, we start listening for incoming connections, and the argument 5 here specifies the maximum number of queued connections. And in line 14, we are printing listening for all incoming client connections. So here we will printing the message indicating that the server is listening for client connections. So when we run this code, and as you can see here, we see this message and our program is still waiting. And after that, here this accept, we now accepting a client connection using accept method blocks until a client connects and returns a new socket object representing the client connection along with the client's address. So, and after that, we are printing the address to confirm the successful connection here.
And here we will enter a loop to receive and print messages from the client. So here we are receive data from the client using a receive method, and the argument 1024 specifies the maximum number of bytes to receive at a time. Here decode the received bytes into the string using this decode method, and we have a if statement here. So if no data is received, which is, for example, an empty string, it means that the client has closed the connection and we break out of the loop. And here we are printing the message from the client, and we are also here closing the client socket and server socket. And to summarize, what we have created a server application that listens for incoming client connections, accepts a connection, and prints any messages received from the client. So we have gone through the code steps by step, explaining each line and function along the way. In next video, we will create a client application that can connect to the server and send messages. So stay tuned for that. So I hope you find this lecture helpful in understanding how to create a basic server application using Python sockets. And in next lecture, we will create a client application to combine with a server and build a complete client-server system. So thank you for watching, and see you in next lecture. Hello everyone, my name is Tayfun, and in this lecture we will be continuing from our previous lectures on creating a client-server system using Python sockets. So in this lecture, we will dive deeper into the client application code, explaining each line and functions in detail. And by the end of this video, you will have true understanding of how the client applications work in Python. So here, let's begin by reviewing the client application code here. So first, we will write it, and here, in order to create a new Python file in PyCharm, or actually you can use these tricks in other, for example, Visual Studio Code as well. You will click on the right click on the project folder here, and here you come to new and select the Python file from it, and we will name it client rat here. So we will make this rat here so from the this is a simple messaging application. However, in next lectures, we will execute commands, get a screenshot, get a keylogger. So we will do that. But for now, we will do a simple messaging protocol with using TCP, and after that, we will widen our program to do that. And here we will firstly import the socket, as well as I always do, I will explain all of the codes line by line, and you will have a best understanding of how these codes work and what these codes mean. So it's actually easy to write codes, but it's actually more harder to understand what these codes mean. So here we will name here, and here main as well, two equal to signs, main, and after that we will firstly set the target server's IP address and the port number to connect to it. In this case, our target is going to be our Linux machine, Kali Linux, because this is a client rat, right? So what we're gonna do is we will firstly check the if config here to see what is our IP address, and as you can see here, it ends with 138. And in order to do that, we will use the server IP here, and 192.168.13.138. So 168.13.138. That's it. And we will also use the port here. So we have to use the same port as we use in server side. It's this here. So we will use server port as well, and that's it. A3. Oops. Actually, server port in server port we have to write in integers. I think it was a
87 and 88, yes. And after that, we'll combine the target IP address and the port number to form the target address as a tuple, because the client socket, so our socket here, accepts tuple only. And after that, we will target address here, and after that we will first enter the server IP of server IP, and after that server port. And after entering this, we have to create a socket object for the client, and in order to do that, we will use the client socket, socket here, socket, and we will use the socket.socket method, and here, as we did in previously, we will use so remember, this is a server and this is a client here, so we will use the socket IP version 4 and TCP here, TCP protocol, and here we will use as well here socket, so here, and after that we will also use this TCP. So if we use the UDP on the client side and the TCP on the server side, our program of course will not work, because they don't share the same language, same protocols with each other. And here we will also use a sock stream. That's it. And after that, we have to connect to the target server. In order to do that, we will use the client socket dot connect, and after that we will get the target address, because and as you remember, this is a tuple which holds the server IP as a zero index and the server port as a first. And here we will enter the target address as well, and that's it. So after that we will need to print a message indicating that the client has connected to the server. So now we will print that the client is connected to server IP. We will also write the server IP to inform the client. Actually, this is a remote access Trojan, so we will not inform it, but for us we will write some here. Client is connected to, I think we can write it for learning purposes here, but in reality, of course, you will not write your client is connected to something or the IP addresses here. Remote access Trojans or remote access tools has to be stealthy, right? So now we will use the server IP, and after that we will also use the server port. That's it. And here, after that, of course, we need to use a double dot here, so I'll make it look more presentable. And after that, we need to get user input for the message to send to the server. In order to do that, we will use the message input here. We will get input from the user, and here we will enter your message, or is that your here? Enter message. We are just a program writing here, right? We don't have to get personal. Enter your message, of course, here, and we need to send the user input message to the server embedded as bytes. So as you learned in previous lectures, we need to send our messages in bytes. So as I told you, we firstly need to convert our string to bytes on the client side, and in order to receive that text message on the server side, we need to turn that byte to readable string here, right? So now we will use so after that we get the message from the user. Actually, let's run this and see what happens. So as you can see, connection refused, because there's a no here. Actually, we can firstly 138, because connection refused because we are not open the server here, server side of the rat. So we will now open cd PyCharm, and again we will go to the here, and now we will Python 3 server rat here. That's it. And as you can see here, it brought us a listening for all incoming client connection, and whenever we run it, and as you can see here, address is already in use. Oops, because we are running in the server here, so we need to run the client here. And as you can see here, we need to enter the message, here, as you can see here, we entered the message and process finished here, so our program is completed the execution, and we didn't receive any, but we connected to the client here, right? But now what we're gonna see is, you will see how to get a response and turn this message here, this input, into the byte here. And in order to do that, we will use the client socket.send. We will send this and encode this. So message.encode. We will not give any variables inside this parameter because we don't need to. So we will send the user input message to the server, and we will encode as bytes. And after that, we will have to receive a response from the server, right? So response here, and we will client socket dot receive 1024. Actually, in this example, in server side, we haven't programmed it yet, but as I said, we will like make this application more and more bigger and bigger. We will add functionalities to this remote access trojans and so on, so it will be so much better here. So now we will decode it here if we have any messages, but in this case, in our server side, we haven't coded this messages to send something here, as I remember. Yes, as you can see, we are not sending any message to the client side, right? And here, after decoding it, we will need to print a service response. For now, as I said, we didn't program it on the server side, but it wouldn't hard to write this here, but it will not affect any of our functionality. This code will just stay here, and if there's any response, it will print to the here. And print here, we will use the server response is and here we will also add response. So as you remember, I always use formats for writing things like that, mixing variables with printable strings here, and we will enter the response here. And after that, we need to close the client. So client socket dot close. And here we completed our program. Let's firstly run it, but here I have a much bigger surprise for you. So we will run it on the Windows 11 machine to see what happens. So now I will run the CMD on my host machine here. And here right now, I will copy the client side here. So as the tradition, our server side is going to be the Kali machine because it's an attacker, and our target side is going to be Windows machine. So now I will copy this and run it on Windows 11 actually. Hello, my name is Stefan, and in this lecture we will first explain the codes we wrote here in the client side. In previous lectures we explained the server side here and what this code means and what their function is, and here we will explain these codes one by one. So here we are importing the socket model, which provides the necessary functions and constants for creating sockets. And here with this, as you remember from previous lectures, this condition ensures that the codes is only executed when the script is run directly and not when imported as a model. And here we are defining the target server IP and server port here, and here we are combining the target IP address and the port number to form the target address as a tuple. And here we are creating the TCP socket for the client using socket here, and here we are using AF-inet, which specifies the address family IP version 4, and here we are specifying that indicates that this is a TCP socket here. And here we are connecting to the target server using this connect method, and we are passing the tuple here as a server IP and the server port. And after that, we are printing the message that indicating the client is connected to the server IP and server port, and here we are entering message. So we are getting the user input for the message to send to the server using this input method here, input function, and the user's input is stored in this message variable, and we are now send the user input message to the server using this send method, and the message is encoded as byte here for sending here. As you remember, we need to send the messages over networks as a byte format here, and then we will need to turn that to string here when receiving that. And here we are receiving a response from the server using receive here, and the argument 1024 specifies the maximum number of bytes to receive at a time. And after that, we are printing the server response, and we are closing the client. So here, let's take a closer look at the key concepts and functions used in this client application. So the first phase is socket creations. So we create a socket object for the client using the socket finit and socket stream. So as you remember, socket init specifies the address family of IP version 4, and socket stream indicates the TCP, and in the phase 2 we are connection establishment. So we are doing a connection establishment. So we connect to the target server using the connect function and pass a target address as an argument, and this establishes a TCP connection between the client and the server. And after that we are sending a message here. So we use the send function to send the user's input message to the server, and the message is encoded as bytes using the encode method, and this ensures that the message is sent in a format that can be understood by the server. And after that we are receiving the message. So we receive the response from the server using this receive function here, and the argument 1024, as I said, specifies the maximum number of bytes to receive at a time. So this is actually ideal for our messaging application, but you can do more, for example 2048 or like more here, depending on your needs and projects here. And at the end we are closing the connection. So after receiving the server's response, we close the client socket using the close method. So this releases the resources and terminates the connection between the client and server. So here in this lecture you understood how it established a connection to the server, sends a message, receives a response, and closes the connections. And we also discussed the key concepts and functions used in the client application. Now what we're gonna do is as you can see here, we have this Windows CMD screen here. This is a different computer. This is my computer here. Now what we're gonna do is we're gonna go to the terminal here and run this application. So here, let's firstly check our IP here, and as you can see it's 138. Now what we're gonna do is we will go to the project folder here, in this case PyCharm projects ls, and we will go to project name. So clear here, and we have client rat, client server. So I have copied the exactly client rat to my Windows machine, Windows 11 machine, and now we will run the server rat, and then we will run it from the client side here. And what we're gonna do is Python 3 or Python 3 here, server rat here, and as you can see here it wrote us that listening for all incoming connections. Now what we're gonna do is let me actually open the Windows on the second screen here and on that side. So perfect. Now what we're gonna do is we will write let's actually read the inside of the program, with the cat here. Of course we need to go to Python 3 hacker tools. I copied this program to Python 3 hacker tools here. So let's make it bigger and here click enter, and here we will have this client rat.python file. As you can see, it's the program size is actually so small, 557 bytes. So now let's actually read this inside files with cat here, and as you can see here, oops, cat. So cat is not recognized internal or external command. So here, of course, the cat is for Linux here, so we will write the type here and client rat. And as you can see, we are seeing this the input of the client rat application. So we can go to PyCharm here, and you will see the same. And as you can see here, port is same. This is the server IP. This means that we need to provide it of our Kali machine IP address. And everything goes okay, and now we can run the program. So Python, and we will write the client rat py. So here Python is recognized as an internal or external command or operable. Yeah, of course we need to write it. So here I written a typo here, Python client, and as you can see here, we connected to the Kali machine, so we can send the messages here, passwords here, and as you can see here, we received on the attacker side. We can write another things as well, and so on. So this is how our programs work. In next lectures, we will be widening our program functions. We will make, for example, keyloggers, like screenshot makers, and so on. So I'm waiting you in next lecture. Hello, my name is Stefan. Welcome to today's lecture on developing a remote access Trojan for educational purposes. In this lecture series, we will explore the fundamentals of creating a rat using Python, and today we will focus on the server-side implementation of it. So a remote access Trojan is a powerful tool that allows authorized or unauthorized users to remotely access and control computers over a network. It can be used for various purposes, such as penetration testing, network administration, and remote troubleshooting. So, however, it's important to approach its development and usage responsibly and ethically. And in this lecture, we will dive into the server-side code of our remote access Trojan, and we will establish a network connection between a server and client, allowing us to send commands from the server to the client machine and receive the outputs back to the server's terminal. We will then walk through each line of code, discussing its purpose and functionality. So by the end of this lecture, you will have a solid understanding of the server-side implementation of our remote access Trojan and how it enables remote command execution. In this lecture, we will continue our journey by developing the client-side code, completing our remote access Trojan implementations. So remember, the purpose of this lecture series is educational, emphasizing responsible and ethical use of such tools, and it's essential to respect the legal boundaries and obtain proper authorization before conducting any activities related to hacking, penetration testing, or network security. So let's get started with our exploration of remote access Trojan development, starting with the server-side code here. And together we will learn how to create a functional remote access Trojan that can execute commands remotely and receive outputs in the server's terminal. So feel free to customize this code here. And for this lecture purposes here, we will delete this code. Actually, we will write the same code to the previous lectures for the messaging application, but it will, for some here, it might be watching from all over the lectures again for this section, and that's why we're gonna delete the codes here and we will write them again for educational purposes here. So we will explain this again and more depth here. And now what we're gonna do is we will write firstly import the socket here, import socket. So here we will also if name again, if name here, do equal to signs, and again main here, and after that we will create a socket object for the server. in order to do that. So we will again use the same variable hacker server socket here, and socket dot socket. That's it. Again, socket.af init for TCP/IP version 4, and also we will also use the socket dot sock stream in order to use the TCP protocol. And after that, we will need to define the IP address and port to listen on. We will use IP to listen. It's gonna be 0.0.0.0. We will listen all available network interfaces, and the port is gonna be again the same port 8788 here. So port 8788. So here we will need to bind the socket to the IP address and port. So we will create a new tuple, my socket address here, and we will create the first we will pass the IP to listen, and then port here, and after that we will also bind this variable tuple here with this bind method, my socket address, and after that we will need to listen for incoming client connections. So here we will set the maximum client connections or client queue for 5 listen here, and after that we will print to the user that we are listening to all incoming client connections. So listening to or listening for all incoming client connections here, and that's it. And after that we will need to, if there's a client connection, we need to accept the client connection when it arrives. So in order to do that, we will use the client socket, and here client address here, and we will equal to hacker server dot accept, and after that we will print the client IP address and port, and we will know that what the client and port we are working on. So connected to, or actual new connection, and here we will write the client address. Actually it was it was client address and client it was client address and client socket. Actually it's right, only client address only, so we know the port already, or we can also use this port. That's it. So here we will write the client address and port like this, and after that we will need to write a while loop. So while true, we will write prompt the server operator to enter a command to execute on the client. In this case, the server operator is RV, and so now we will the command here. So command, and we will input some commands here, and we will notify that enter command to execute on client here, and here or type exit or exit to quit here, and after that we will send the command to the client. We will client here client socket dot send and command that encode here. Actually, instead of writing the plural, we can just use the command here instead of commands, and we will here we will check if the server operator wants to exit here. In order to do that, we will just turn the command to lower, because the server operator might write exit like that, or with uppercase E here and then down lowercase xit here, and that's why we will turn it the command to lowercase to check the proper here and exit. That's it. And after that we will break the loop here if this condition occurs here. So now we will need to receive the response from the client. So response here, client socket. We will not use that response here, but for next lectures we will need that here. Decode, we will also need to decode here if there's any response arrived. And after that, we need to print the output from the client on the server's terminal. So print here, we will use the format. So output from client command line. And here, after that, we're gonna use a new line, and after that we will print the response. So here, since we completed our application, now we will close the client and server sockets. Client socket dot close here, and server socket dot close. That's it. Close here. Now let's actually run current while, and as you can see, it's listening for all incoming connections. So if there's a connections arrived, now we will enter some commands here. In this case, it will do nothing because there's a no connection into our machine here. So now I will explain all of the codes here. It will not take a long here. So firstly, we imported the socket. With this code, we import the socket model, which provides low-level network functionality. Here, as you remember, we are with this if name equals main, we are checking if the script is being run directly and not imported as a module. And here, as I explained in previous lectures, this hacker server socket variable, we are creating this socket EF inet here to creates a IP version 4, and this creates a TCP socket object for the server, and we are here specifying the IP address to listen on using this 0.0.0.0 means that the server will listen on all available network interfaces. This is the port. We are specifying the port to listen on. You can change this to any available port number. And here we are my socket address. We are here combining the IP address and the port here, IP address variable and port variable into a tuple to bind the socket. And here we are with this code, we are binding the socket to specified IP and port. And here we are enabling the server to listen for incoming client connections. And the 5 parameter that we wrote here specifies that the maximum number of queued connections. And after that, we are printing here, and after that, we are accepting a client connection when it arrives and returning a new socket object for communication with the client and client's address. And after that, as you can see here, we have the command input. So we are printing just here. And so after that, we are inside the while loop. With this here, we are prompting the server operator, in this case us, to enter a command to execute on the client. And after that, here, client socket.send command encode here sends the command to the client after encoding into bytes. And after that, if this line of code here checks if the server operator wants to exit, if so, it breaks out of the loop. And here on the response here, we are receiving the response from the client, and the 1024 parameter specifies the maximum number of bytes to receive. And here we are printing the output from the client on the server's terminal. And here we are closing the socket for the client connection, and we are closing the socket for server socket. So this code here covers the server side code explanation. It sets up the server to listen for the client connections, prompts the operator for commands to send to the client, and prints the output received from the client. So in next lecture, we will also develop a client side of the application here. So I'm waiting you in next lecture.
Hello, my name is Stefan. Welcome to our Remote Access Trojan Development Lecture Series. And in previous lecture, we explored the server-side implementation of our Remote Access Trojan, which allowed us to send commands to a connected client and receive the outputs in the server's terminal. However, we have just two little errors here because one of this here in the client socket, I hope you noticed it when we wrote that code in previous lecture. The thing is we need to firstly receive and decode here, right? So receive 1024, and after that we will need to decode, and here we just forgot here in our keyboard to write the parentheses after the encode here. So that's it, our program will run successful again. So actually in previous lecture our program ran successful, right? Do you remember that? But our program actually, when I did try it, our program got crashed when we tried to connect with the client. So in this lecture we will also develop a client. So in this lecture we will complete our remote access Trojan implementation by developing the client-side code, and the client will establish a connection with the server, listen for commands, execute them on the client machine, and send the outputs back to the server. Throughout this lecture, we will dissect the client-side code line by line and understand its functionality here. And we will cover concepts such as socket creations, connecting to the server, receiving commands, executing shell commands using the sub process here, sub process module, and sending the outputs back to the server. So by the end of this lecture you will have a complete understanding of how remote access Trojan works from both the server and client perspectives, and you will be equipped with the knowledge to build a functional remote access Trojan that allows remote command execution and output retrieval. And remember, this lecture series focuses on educational purposes only, emphasizing responsible and ethical use of such tools. Always ensure you have a proper authorization before conducting any activities related to hacking, penetration testing, or network security. So let's dive into the client-side code and learn how to develop the essential functionalities of our remote access Trojan. Together we will take another step towards mastering remote access Trojan malware development, and feel free to customize and adapt this script to your lecture style and objectives. And I hope in this lecture you will learn about all the things about client development here. So let's get started. Firstly, we will import the sockets here. So here we will firstly import the socket, and after that we will also import the sub process. As you remember here, so we will execute commands in the client operating system with the sub process libraries modules here, and we will also add if name here, and here main. And after that we will define the server IP and port to connect to. In this case here, attacker IP here is going to be 192. Attacker IP is going to be our cal IP address here. So if config here, and you will see this IP address here. Let's actually use this again. So if config, and here 138, so we can copy this, or here 168.13.138, and that's it. So after that we will also need to use the same port, attacker port here, port. In this case our attacker port was the 8788, so 8788 here. Also add the 2 dots here, that's it. And here give name main here, and that's it. So here we got also the problem here because we already did use this, so sometimes let's actually invalidate and restart. Sometimes it might happen like this. Here, that's it. And now what we're gonna do is
here. And now what we're gonna do is we will also create a target address. So or here we will do the attacker address here. It's gonna be the server IP. Oops. It's gonna be attacker IP and attacker port. And after that, we need to create a socket object for the client. In this case, we will the client socket here. It's gonna be socket here. We will use the IP version 4 and socket.af init sock stream here. And after that, we need to connect to the server. And in order to do that, we will use client socket again and client socket dot connect, and we will pass the target address as a tuple. Attacker address here. And after that, we will notify to the client. Actually, we don't need to, but for this lecture purposes, we wanna see what is going on the client machine. So we will print that here, of course, with the format client is connected to, and we will also write the attacker address or attacker IP and attacker port. That's it. And after that, we are done. We need to go to while loop here, while true here, and we need to receive the command from the server. Command. I will explain all of the codes in more detail after writing this. Command here and here. Client socket that receive here, and we will enter the how many bytes we wanna buffer size, and we will also decode it. And after that, if our client wanna exit, so if the command was to exit from the server, if our command here that lower is here exit, then it's gonna be exit. We will break the loop and stop the program. That's it. And here, and after that, here outside the if condition, we will need to create the output variable in order to get output from the command. So output here sub process that get output and command. That's it. So we will get output from that command and client socket that send. So we will get that output to our server machine, so attacker machine. And here we will output that encode here, and after that we need to close the client socket. So client socket dot close here. Perfect. And we are done with that client remote access Trojan here. So we can open the this here, or we can also run this program to see if everything is okay. Oh, sorry. Here Python can't open the file main.py because this is not the main.py here. We will need to use the current file, and here our connection is refused because there is no server rat open for right now. So we will run the server rat firstly. Oops. And as you can see, listening for all incoming connections. So whenever we gonna run this on the second terminal, actually instead of running this from the terminal, let's actually run it on the Windows machine later. But firstly, we will do what we will gonna do here. We will explain all of the codes again. So firstly, with this import socket code, we are importing the socket model, which provides a low-level network functionality. And here with subprocess, we are importing the subprocess module, which allows executing shell commands. And here we are checking if the script is being run directly and not imported as module. So we are defining the IP address of the server to connect to, and you need to change this to the appropriate IP address of yours. And here we also have the attacker port, which is we are specifying the port of the server to connect to, and make sure it matches the port used in the server-side application. and we also have the attacker address. So we are combining the server IP address and port into a tuple, and then we have a client socket variable here, which we are creating a TCP socket object for the client. In this case, the socket AF init is the IP version 4, and sockstream is a TCP here. And we also have the client socket.connect command here, which is we are connecting the client socket to the server, and after that we are printing it. So we are printing a message to indicate that the client is connected to the server, and we are starting an infinite loop for receiving and executing commands from the server. Then we have the command here. We saw client socket receive 1024 and the code here. So with this command, we are receiving the command from the server, and the 1024 parameter specifies the maximum number of bytes to receive. And after that we have if condition here, so we are checking if the command received is to exit. So if so, we are breaking out of the loop, and we just have 3 lines of code left. The first is the output is we are executing the command using the subprocess get output function, and here we are writing output to this variable here. And here we have a client socket. We are sending the output back to the server after encoding it into bytes. And lastly, we are closing the client socket here. So now let me actually open my Windows CMD here, and what we're gonna do is we're gonna run this program here.
And here, as you can see, let's actually make it on the top here and increase the font size. So I copied this client right here, and now we will run it on our Windows machine here. So here we need to go to Python 3 hacker tools, and we have the client rat.py here. And as you can see here, its size is increased because we write more code compared to previous lectures here. And now what we're gonna do is we're gonna touch client here. Oh, sorry, this was not touch here. I think it was a take for the client rat here. Oh no, I think it was a type to get the read text files. And as you can see here, we have the output here. This is just a code that we wrote. This is the exactly same code that we wrote on the PyCharm here. So now what we're gonna do is we're gonna run it, right? So Python. So we're gonna run it to the server and see what happens. So Python, our client rat, and as you can see, client is connected to this IP address, and let's see what happened. And as you can see, enter the command to execute, and as you can see, it's not quite looking okay here. So we're gonna change this here to this, and after that we need to new line enter command. That's it. And here it will look more presentable now, and we will run it again. Clear, and run it again. And as you can see, we are address already in use, and in order to fix that, we need to terminate the previous process using so in order to terminate that, we need to get an process ID here. Netstat will do that work here for us, and as you can see here, we have a lot of information here. So the process IDs and so on. So, but instead, and as you can see here, it's 13. This is the IP address of us, and we can also use different command for terminate or ls off here, ls off here. And as you can see here, so we can also use the you can, in order to fix it, you can also use the different port number for this. And as you can see, it's already fixed, so it might take some 5 or 10 seconds to restart and close the network. Your network driver here will close that connection automatically if it's not working here. And as you can see, we're listening for all incoming client connections. And now what we're gonna do is we're gonna go to our Windows machine,
and here, and as you can see here, whenever we enter, client is connected to this here. So now we need to enter a command. In this case, let's actually use a dir here, and as you can see here, we got the exactly same output here. So volume in drive C has a no label here, right? And we can also use a widget to download some files from the internet here. Let's actually try that. So in order to do that, we will use the curl here. So now we will go to open our browser, and we will go to some website to find some image, or we can also even we can download the entire like applications and so on. So go here, but in this case, let's actually use that here. Let's actually download the Kali here, or let's go to DuckDuckGo. You have been hacked here, and now we will go to images, and that's it. So we can choose some of the. So you have been hacked, so we can download this here. So we will copy the link, and here this is, as you can see, this is the link. And now what we're gonna do is we're gonna write the curl command. So curl our website here, and O here with uppercase O. We will use the hack.jpg here, and as you can see here, it's downloaded now. Now let's use a dir again, and here we got an error here because the broken pipe. So we will run our program again on the, and here as you can see, let's see what happened. I will run this again. So here we have this. Oops. Let's clear that. And here we're gonna go to here again, and let's put the server up, and as you can see here, it's giving us error again. And I want to also show you how to change the port number of it. And here we can change the port number, for example 19,900 here, and we also need to change it on the client side, 19,900. So 19,900 here, is it same? Yes. So you can change the ports, but you need the exact same ports to if you want your program work. So here in this lecture we covered the client side code explanation, and it establishes a connection with the server, receives command from the server, and executes them using the sub process get output, and sends the output back to the server. So remember to customize the server IP address and port to match your server's details.